Hey everyone, welcome back to another video session by Simplilearn. In this session on C++ full course for beginners, we will be learning different concepts and topics of C++. This video tutorial will help you in learning and understanding the C++ programming language in both theoretical and practical way by doing some hands-on examples. But before we begin, make sure to subscribe to our channel and press the bell icon to never miss an update. So we'll start with the introduction to C++ programming language and how to download and install C++ in Windows. Then we will start with the first program in C++ along with the terms like variables, types, then the concepts like if-else statements, loops, functions in C++, call by value, call by reference, and friend function. Then we will cover topics like arrays, pointers in C++, this pointer, references, and memory management. We will also learn about sorting in C++. After that, we will move on to object-oriented programming topics like classes in C++, OOPS concepts, etc. And after that, we will move on to topics like vectors in C++, STL, that is Standard Template Library, and in the end, we'll also learn to make some projects in C++. So without further ado, let's get started. So let's start with the introduction to C++ programming. C++ is a popular programming language introduced by John Strostrup in the year 1979. The aim was to make a dynamic language that is efficient and has some additional features to C. Initially, it was called C with classes as it was an extension to C language, but later renamed as C++. It is general purpose case sensitive language and it is called pre-compiled language because it converts the source code directly to the machine understandable code. It is an intermediate level language because it contains both features of high level and low level language. C++ supports the features of object-oriented language like encapsulation, inheritance, polymorphism, etc. It also supports procedural programming and functional programming as well. Welcome to this video where we'll be telling you how you can install C++ on VS Code and Dev C++. After we are done with the installation, we'll also learn how to run a program on both of these code editors. So we'll start with Visual Studio Code. To download VS Code, let's go to Google and search for Visual Studio Code or VS Code. We'll click on this first link. This is the official web page for downloading the Visual Studio Code. And we'll now click on this download for Windows blue button. And now we'll click on download now. Here it is getting download, and as you can see, thanks for downloading Visual Studio Code for Windows. Once we are done with the download, we can click on this open folder. Here it is. Now we need to install this file, so we'll double click on this file. And this is the setup wizard. We'll click on this I accept the agreement. And we'll click on next. As we have accepted the license agreement, now we can select our destination folder or we can leave it as it is. But make sure there must be 293.2 MB of free space on that particular disk space. Now we'll click on next. Here we can again click on next. There is no need to change over here. And now you can click on this create a desktop icon button or anyone else as per your choice. Now we'll click on next. And now we'll click finally on install. It is getting installed. It will take some time. Now we can click on this finish button. Launch Visual Studio, we have marked it. it is already marked, so when we click on this finish button, it will launch the Visual Studio Code. So as we can see, this is the Visual Studio Code. So as we have installed VS Code, now we have to configure it so that the C++ programs can run in this code editor. So in order to do that, we need to add some extensions. So we'll click on this extensions button. Now here we will write code runner extension. We'll write code runner, and this is the extension. We'll click on this install, and it is getting installed. Here are some instructions. We can click on Ctrl plus Alt plus N, or press F1 and then select type run code, but we'll deal with that later. Now we'll add another extension, that is C/C++. Here it is. We'll click on this install. Here we can see downloading Visual Studio Windows Debugger. It is getting installed, and I think it is installed now. So as we have added both the extensions, so let's move on and do a program of C++ in this code editor. We can define strings as a collection or group of characters. It is basically used to represent text in the program, and we can perform many operations on strings in order to manipulate it. The syntax of string contains a collection of characters surrounded by double quotes. For example, here string is the type, str is the name of the string, and coffee is the value that is assigned to the string. In C++, there are two ways to create a string. First is C-style strings. In C-style strings, collection of characters are stored in the form of arrays. They are basically arrays of type character. The second way is using string objects. We can create string object to hold a string. They are implemented in the standard library, which we must include in the program using #include. So here we will do an example of string, and we'll do some push back and pop back operation on it. So first of all, we'll include the header file #include iostream. Then using namespace standard, Okay, now we'll start with int main. Alright, first of all, we'll write string data type, then the name of the string s. Here s is the name of the string. Alright, now first of all, we'll display a message to enter a string. So okay, enter a string. Now get line. This is the syntax when you want to take the input of a string. So get line, cin is used to take the input, and s is the name of the string. So this is how we take the input, and now we will print another message saying that you have entered Now here we will print the string s. Next line and L. Okay. Now we'll do some operations like s dot pushback. This will add an element at the end of the string. So let's say we want to add y. So we'll write y inside the bracket, s dot pushback, and inside the bracket with single quotes we'll write y. Now we'll display a message saying after using pushback function, we'll print the string. That is, after using the function pushback, the string would look like this. And now we'll use another function s dot popback. It will delete the element from the end. So we'll write cout and we'll display the message after using popback function. Let's write popback only, and we'll print the string. Okay, now after that we'll write return 0, and I think it's done, only the spelling is wrong over here. Okay, yeah, now let's try to run this. As we can see the message, enter a string. So let's say I have entered Barcelona. So you have entered Barcelona after using pushback Barcelona y, because we have used y over here. We want to add y at the end of the string. So after using pushback Barcelona y and popback function after that we have used, and we know that it will delete the element from the end. So here we can see there is no y. Popback function have deleted the element. So this is our output. Next is if-else statements. If-else are two conditional statements that are generally used when we want to run the code based on some conditions. We run a block of code which is inside if statement only if the condition is true. For example, if the number variable here is equal to 10, then only the block of code will execute and will print the message you got it. Otherwise, it will run the else block and display the message written inside that block, which is not this one. So first of all, we'll create a new file. We'll go to File and click on this New File. Now, in order to save this one, we can click on Ctrl S, or we can go over here and click on this Save As. Now we can select the location. Like, let's keep it over here only. Let's name it as visual.cpp. .cpp is the extension which is used when we want to do a program in C++. Now we'll click on this save button. Now let's do a simple program to check whether the program is running on this code editor or not. So we'll include the header files, #include iostream. Now we'll write namespace standard. Now we'll write int main. Now inside int main we'll display a message, welcome to this video. Okay, now return 0. Make sure to save this after making changes, or you can click on Ctrl S, or you can go to File and click on this save. So once you have saved the program, now you can run it. We can click on this play button. It will run the code. As we can see in the output, welcome to this video, we can see. Here it is. So It means our program is working. It is running fine. Now let's do another example in which we will take the inputs from the user. So let's make a new file. We'll go to file and click on this new file. Now we'll save as and we'll write visual2.cpp. Alright, in this program we'll take the input from the user. So start with header files #include iostream. Our spelling is wrong. #include iostream, after that using namespace standard. Now inside int main we'll take the inputs from the user. We'll display the message, enter the first number. Now using cin we'll take the input. We forgot to mention this, declare this n1 variable, so we'll write int n1, int n2 and int sum equals 0. Alright, here we have taken the input of n1, the first number. Now we'll take the input of another number by displaying the message, enter the second number. We'll write n2. Now we'll add both of these, n1 plus n2, and we'll display the result. We'll write end line so that it looks good. Alright, now we need to save it. We'll go to file, I'll click on this save. Now it is saved. Now we can run this program. We'll click on this run code. Now in order to write the first number over here, that is, in order to write in the terminal, we have to configure the Visual Studio Code. And to do that, we'll go to file and we'll now go to preference, and in the settings we'll click on the settings, and here we will type run in terminal. Alright, now we can scroll down and here we can see code runner run in terminal. In my VS Studio it is already marked, but you have to mark this if you want to write in terminal or enter the inputs in the terminal. Alright, once you have marked this, you can close it and then you can Control S, that is save, and then you can close the VS Studio and then open it again. Once you are done, now let's try to run this. So now you will be able to write the inputs, like let's say 4. The first number is 4. Now the second number, let's say 9. On addition it becomes 13, which is the right answer. So these were some configurations that you need to do if you want to run a program of C++ in Visual Studio Code. So as we have understood how to download and configure Visual Studio Code for C++ programs, so let's move on to learn how we can download dev.c++ and run C++ programs in that. So let's go to Google and type dev.c++. This is the first link. We'll click on that. Now this is the green button saying download. We'll click on that to download dev.c++. As you can see, it is getting downloaded. Your download will start shortly. So now we'll click on download now. Now it is getting downloaded. It will take a while. The size of this file is 48.1 MB. So as you can see, the downloading is almost done. So the downloading is complete. Now we'll click on open folder. Here it is, dev C++ setup. Now we'll click on this setup. We'll click on yes. The setup is loading. So now here we will select the preferred language. It is English. We'll click on OK. Now we'll click on, this is the license agreement. We'll click on I agree. Now we'll click on next. We don't need to change this, I think. The space required is 346.8 MB, and we'll click on next. Now if you want to change the destination folder, you can, but I don't want to change it, so I'll click on install. Now it is getting installed. It will take a while. It's done, and now we'll click on finish, and it is marked. So when we click on finish, it will launch the dev C++. So here we have to select the language. It is English, so we'll click on next. Here again we'll click on next, and now we'll click on OK. So this is our code editor, that is dev C++. So let's write a code. First of all, let's create a file. We'll go to file and go to new, and we'll click on source file. Alright, now we need to save this one, and in order to save this, we'll click on file, then we'll go to save as, and now we'll select the destination and name it as dev.cpp. Alright, now let's start with the header file, #include iostream. We'll do a simple program over here using namespace std, because we want to check that whether the program is running in this editor or not. Namespace std. Now we'll write int main. Inside int main we'll display a message, welcome to dev C++. Alright, after that we'll write return 0. Now let's try to run this, and in order to run this program, we'll go to execute, and now we'll click on compile and run. Here this is the pop-up, welcome to dev C++. As we can see, this is the output. Now press any key to continue, it will close this window. So our output is correct, welcome to dev C++. So this is how you can run a program in dev C++, and our program was also working fine in the Visual Studio Code. So this is how you can download both of these code editors to run the C++ programs. Today we'll be discussing about loops in C++. So let's begin and see what's in it for you. So we are going to be learning today about while loops, what is a loop, then different types of loops like for loop, while loop, do while loop, then there is nested loop. After that, there are control flow statements like break and continue. But before we begin, if you're new here and haven't subscribed already, make sure to hit the subscribe button and the bell icon for interesting tech videos. So let's start with the first topic, that is while loops. In order to perform a particular task or operation many number of times, we need loops. These are used when we want to execute a block of statement repeatedly rather than just writing those statements again and again. For example, imagine you want to display your name on the screen 50 times. Now to do that, there are two methods. Method 1 is writing your name 50 times by doing the hard code. And method 2 is writing your name once with the loop condition, and your name will be automatically displayed 50 times. Now it is pretty obvious that you would prefer the second approach because you don't have to put effort in writing your name 50 times. Plus, it is easy to write code in few lines. So method 2 is the functionality of loop. It reduces time in writing the code, plus it increases the simplicity. Now let's understand what is a loop. Loops in computer programming is a series of tasks that are used to run some particular code repeatedly until a specific condition is met. Loops tells the computer when to start the condition and when to stop it. Now, this is a basic flow of a loop. After the initialization, the condition is checked. If it's true, then the block of statement will get executed as long as the condition is true. And if the condition is false, the loop will terminate. Depending on the program, different types of loops are used in different times. So let's first see different types of loops. First is for loop, then while loop, then there is do while loop. After that, there is nested loop. These are four types of loops in C++. So let's discuss these loops. First is for loop. It is a repetition control structure that is used to iterate a piece of code based on the condition is true or false. If the condition is true, the statement inside the loop body is executed, and once if it returns false, the execution of statement will get terminated. And after every execution of for loop, the increment or decrement parts will update the loop counter. Now let's move on to the while loop. In this loop, the condition is evaluated first. If it's true, then the set of instructions inside the loop body will execute, and this will happen repeatedly until the condition becomes false. And when it becomes false, the loop will end. Now the main difference is we use for loops when we know the number of times the body of the loop needs to run, whereas we use while loops when we don't know the accurate number of times the body of loop needs to run. Now moving to the next loop, that is do while loop. This loop is quite similar to the while loop. In this, the loop will execute the set of instructions once before checking if the condition is true. After that, it will repeat the loop as long as the condition is true. That means, in do while, loop body will execute at least once irrespective of the test condition. Now coming to the nested loop. When one loop is defined inside the body of another loop, then it is known as nested loop. In C++, there are at least 256 levels of nesting, and the flow of execution for nested loop is, first it includes the initialization of variable, followed by condition 1. If it gets satisfied, then it will search for the second condition. If that also gets satisfied, then it will get increment, and when the condition gets satisfied, it will search for the new set of statements, and follows the same flow of execution. In C++, break statements are used to terminate the execution of the loop. And by terminating the execution of loop, we means finishing or stopping the execution. Like if we want to block or terminate a loop at some point, all we need to do is to use the break statement with a condition on which we want the loop to stop, and it will terminate the loop's flow or iterations. So break statements are mainly used for two cases. One is it can be used inside the loop, and second is it is mostly used in switch statements. And this is the loop's flow diagram, in which first there is a loop body, then if the condition is true, then there is a break statement which will terminate the loop, and if the condition is not true, then the loop will continue to iterate. As you can see in this example, the loop is iterating from 0 to 10. Inside the loop, there is a condition and then the break statement, which will make sure that the loop will terminate when I becomes equal to 4. After the break statement, the control will jump out of the loop body, and that's how the break statement works. Its output would be 0, 1, 2, 3. It will not exceed 4 because of the break statement. Now, coming to continue statement. The continue statement is a bit similar to the break statement as it is also used for termination. But the difference is that it is used to terminate the current iteration and not the complete loop. For example, if a loop is iterating from 0 to 6 and inside the loop there is a continue statement on 4, then all the elements will be printed except 4 because continue statement skips that particular iteration and continues with the next one. And in break statement, the complete loop flow terminates. So when the continue statement is used, then within the loop, the control skips or terminates that particular iteration and continues with the next iteration. As you can see in this example, first loop body, then there is a condition. If that is true, then the continue statement will terminate and continues it with the next iteration. And if that is false, then control will go to the remaining part of the loop as always. Now in this example, we are using continue statement. Here the loop is iterating from 0 to 10. Inside the loop, there is a condition and then the continue statement, which will make sure that if the value of I becomes 4, then terminate that iteration and moves to the next iteration. After that, elements are getting printed with the help of cout function. Now its output would be 1, 2, 3, 5, 6, 7, 8, 9. It will not display 4 because of continue statements, as we know that the continue statement skip that particular iteration. So when we use I equals to 4, then it skips that particular iteration.
If getting your learning started is half the battle, what if you could do that for free? Visit Skill Up by Simplilearn. Click on the link in the description to know more.
Alright, so as we have covered the theoretical part, so now let's do some examples on break and continue statements in our code editor, that is VS Code. Now we'll make a new file and we'll name that file as loops.cpp. Okay, loops1.cpp. Now here we will do a program in which we have to print the digits from 0 to 10 using for loops. It will be a basic program just to understand it. We'll write the header file #include iostream. Now we'll write using namespace standard. Now here is the int main. Now we'll write the for loop with a for keyword. Inside the for loop, we'll initialize I with 0. Now we'll put a condition I less than equal to 10, which means the loop will keep on executing until I is less than 10. Now we'll put increment I++. Now inside the loop brackets, all we have to do is to print I, so that all the digits get printed. So now let me tell you, here what we are doing is, we are just making the loop to run from 0 to 10. As we can see that I have made I 0 to I less than equal to 10. That means loop will move from I 0 to 10. Now let's try to run it. Here we can see all the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here is our answer, and let me tell you one thing more. To put return 0 after the loop, it's a good practice. Now I'll again run it. The output will be the same, but it's a good practice to write return 0 in the end. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So instead of writing the hard code, we can just use the for loop in this case. It's a basic example of for loop, but you can try some more examples in order to understand it better. Now let's do one example of while loop to understand it better. We'll be doing a basic example of while loop in which all we have to do is to print Happy New Year 11 times. Let's start. First of all, let's name this file loops2.cpp. Now let's start with the header file, that is hash include iostream. Now we'll write using namespace standard. Now here is the int main. Now first of all, we'll declare n equals 0. We'll take a variable n and initialize it with 0. Now we'll put the while condition with the while keyword, writing while n not equal to 11. Here what it means is the loop will keep on executing until n becomes equal to 11. Now here all we have to do is to print Happy New Year so that it will get printed along with the loop 11 times. And then now we'll write n plus plus. We have written n plus plus so that the loop will keep on incrementing every single time. After that, now we'll write return 0 outside the loop. Now we'll try to run this. So here's our output, Happy New Year 11 times. So this is how it's done. This is again a basic example of while loop, but to understand it better, one must practice some more examples on it. Now let's do one example of do while loop also. Let's make a new file. First of all, let's name that file loops3.cpp. I think the name is already taken. Then we'll write loops4.cpp. Okay, now so we'll write the header file. First of all, we'll write hash include iostream. After that, using namespace standard, now in this program, all we have to do is we have to print the sum of all the digits from 0 to 9. So let's start. We'll write int main. So now let's first of all declare a counting variable sum and initialize it with 0. Now we will initialize another variable I with 0. Now the syntax of do while loop is do keyword, and now we will add some code inside the body. We'll write sum equals sum plus I. Here what we are doing is we are simply adding sum variable and I variable and storing it to sum variable itself. We are doing this because we want to find the sum. That is why we have to store it in a single variable. Now we will need to increment I, or else loop is going to run forever. Now we will write file I less than 10. We have written I less than 10 because we want to find the sum from 0 to 9. And make sure to put a semicolon in the end in case of do while loop. Now we will print sum in this while loop. We'll write sum is sum variable. Now this loop will keep on executing till I is less than 10. Now in the do while loop, sum is calculated by repeated addition and increment. In each repetition, it is checked whether the number I is smaller or equal to the inputted number. If it is smaller, then the loop continues, but exits the loop if it isn't. After the control exits from the loop, sum is printed. Now let's try to run this code. Here it is. Sum is 45, which is the right answer. This is our output. So this is how it is done in do while loop. So now let's do one example of our last loop, that is nested loop. First of all, we'll name the file loops5.cpp. Now we'll start with the header files. Now using namespace standard, now in this program all we have to do is to print a star pattern of half pyramid form using nested loop. So let's try. We'll write int main. Now let's initialize two variables, that is I and j. Now let's say we want to make a half pyramid of 10 rows. Then it means we need to run a loop which runs for 10 times. So let's write for initialize it with 0, I less than 10, I plus plus. Now here we have written I less than 10. Instead of this, we'll write I less than equal to 10 because we want the 10th row to be printed also. Now we'll print /n in order to insert a new line. Now we'll write another for loop which will decide number of stars in a particular row. So we'll write j equal to 1 because this for loop is for the column section. Then j less than equal to I, which is a row, then j plus plus. Now we'll print star. Now one more thing, instead of 0 we'll write I equals to 1 because we want to print stars from 1 to 10. So now let's discuss its working. Initially we have I equals to 1, that is the outer loop value. Now for this value, a complete run of jth loop is happening, that is j equal to 1 validated by j less than equal to I. Now this condition is used because the pattern which we are going to build is having increment of star as the number of rows increments. So for I equals to 1, j equals to 1 is executed. Then j++ is done, which increments the value of j to 2. Now j equals to 2 failed to execute as 2 is less than equal to 1 is false. Therefore, only one star is printed. Again, we go to ith loop. Now for I equal to 2, we'll check every value of j which can be executed, that is 1 and 2. Since only two values can be true, therefore 2 stars are printed. Similarly, we check for I equal to 3, 4, 5 and so on till 9, as we have the condition I is less than 10. So now we'll try to run this and check whether the pattern is printing or not. Here it is, half pyramid form using stars with the help of nested loops. So this is our star pattern. We can make some more different types of patterns using nested loops, but we have done only one example in order to understand the concept. So now let's move to our control flow statements and let's do some examples of them. Okay, now make a new file and let's name this file as control1.cpp. Now we'll write the header file and the namespace standard as we have done previously. So let's do it. #include iostream using namespace std. Now here we will write a program in which we have to print the numbers from 100 to 200, like 110, 120, 130 with a gap of 10. But after 150, we will terminate the ongoing loop. Now how can it be done? With the help of break statement. So let's start. First of all, we'll write int main. Now we'll take a variable num and initialize it with 100. Now we'll write a while condition and we'll write num is less than equal to 200 because we want the loop to run from 100 to 200. Num less than equal to 200. Now we'll simply display those numbers. Now we'll write an if condition that if num equals 150, then we'll terminate the loop. And for that we have to write the break statement inside the if statement. So let's write if num equals 150, then we have to break the loop. Write the break statement. Now after that we'll increment this by 10. We're incrementing this by 10 because we want the numbers to be printed like 100, 110, 120 like this. That is why we are incrementing it with 10 and not with 1. Now we'll write out of the loop just to be informed that we are finally out of the loop. Return 0. Now we'll try to run this. Here we can see, here we can see 100, 110, 120, up to 150. After that, we are out of the loop. This means the code works fine. So this is the example of a break statement. Now after this, we'll do another example of continue. So let's start. Let's make a new file and name it control2.cpp. Now we'll write the header files. Using namespace standard. Now in this program, all we have to do is to print the numbers from 100 to 90, only excluding 96 from them. Now how do we do it? With the help of continue statement. So let's start. First of all, we'll write int main. Now we'll declare a variable num and initialize it with 100. Now we'll write a while condition, while loop, in which we write the condition num greater than equal to 90, because we want the loop to run till it is equal to 90. That is why we have wrote greater than equal to 90. Basically, we want the loop to run from 100 till it becomes equal to 90. Now inside the loop, we'll write the if condition in order to skip 96. So we'll write if num equals 96, num equals 96. Now we'll use a decrement operator, because our starting point is 100, our ending point is 90. That is why we have to use the decrement operator. Now continue statement. After that, we'll write value is, and we'll write the variable num. Now we'll write num minus minus. Here we are writing minus minus because we want it to get decrement after printing also. That is why we have written num minus minus after printing num. Now let's try to run this also. Hope it works. Okay, I think there are some errors. So some brackets were missing. And we'll write return 0. Now we'll try to run it. Here it is. As we can see, 100, 99, 98, 97, but 96 is missing. So this is all we have to do in this program. And this is the basic example of continue statement. In order to understand these examples better, you must try more examples on each of these loops and control flow statements so that it will be easier for you all. Today we'll be discussing about C++ functions. So let's go ahead and look what's in it for us. First, we'll discuss what is a function. Then we'll understand why we use functions. Then types of functions like built-in function and user-defined function. Then function declaration. After that, function calling. Then function call methods. And at last, we have recursion. Also, don't forget to subscribe to our channel and hit the bell icon to never miss an update. Moving on to the first topic, that is what is a function. Functions are blocks of code that are designed to perform a specific task. It basically divides the complex problem into smaller portions and make the program easy to understand and reusable. And by reusable, it means we can define the code once and we can use it many times. We can also pass data into the functions in the form of parameters. And this is the syntax. First is return type of the function, then we will write function name, then inside the bracket, these are the parameters. Now, let's discuss why we use functions. Functions make the program less complicated because once function is defined in the program, then it can be used over and over again, which reduces the complexity of code. And it helps in avoiding the duplicity of code and it reduces the amount of code. Due to this, we can easily debug and maintain the code. Now, coming to the types of functions. There are two types of functions in C++, that is, built-in functions and user-defined function. Now, let's discuss these functions. First is built-in function. These are also known as predefined functions or library functions. We don't need to define these functions because these are already present in C++ libraries, and the implementation of these functions are also available in library file. And to use these functions, we don't have to write them separately, we simply call them. Now, coming to the user-defined functions. C++ allows us to define our own functions. These functions are created by programmers according to their requirement. This allows a way to wrap a set of statements to perform a specific task, and that group of statement is given a name so that it can be invoked later from any part of the program. Following is the example of user-defined function. Here club is a user-defined function with the return type void, and it is being called from the main function. Now, let's learn about function declaration. Function declaration basically acts as an identification for the function. It informs the compiler about the existence of function's name, the number of parameters in the function, and its return type. These things acts as an identifier for a function. And this is the syntax for a function declaration. First, we will write the return type, then we will write the name of the function. After that, inside the bracket, we will write the number of parameters. For example, in this chess function, int is the return type, chess is the name of the function, and inside the brackets, these are the number of parameters. Although we can write the names of parameters, but names of parameters are not important in the function declaration, only their type is required. Now, let's learn about function calling. In order to use a function, we'll have to invoke or call a function. When a program calls a function, the control of the program is transferred to the called function, and when the called function completes its task, then the control is returned back to the main program. So the functions are called by writing the name of function, and after that writing the required parameters inside the brackets. And this is the syntax. First we will write the function name, and after that we will write the arguments which we want to pass. For example, sum is the function name and a and b are the arguments.
So first is call by value. Call by value is a method in which copies of variables are passed to the functions. And as the copies of variables or arguments are being passed, so that is why the changes that are done inside the function does not affect the arguments. And this is the syntax. Inside int main, we can see that we are calling a function and passing the values. Here val1 and val2 are the actual parameters. These are those which are passed to the functions. And inside the brackets of called function, we can see n1 and n2. These are formal parameters. Formal parameters are those which are received by the function. So here we can say values of actual parameters, that is val1 and val2, will be copied to the formal parameters, that is n1 and n2. Now let's have a look at an example in which we are swapping two numbers. As we can see, inside int main we have assigned 120 to x and 150 to y. After that we have called a function named swapIt, and inside the brackets we are passing the values of x and y, and these values are getting received by called function, and inside that function there is a logic to swap the code with the help of temporary variable temp, and these values of x and y are then displayed inside int main. But its output is same. X is still 120 and Y is still 150. There is no change after swapping it also. So this shows that actual value of the variable is not getting modified. This shows that changes done to the parameters inside the function does not affect the arguments. Now let's learn about call by reference. In this method, instead of passing the arguments, the address of the argument is passed to the formal arguments of the function, and the address is used to access the actual argument referring to the same location, so any changes that are made gets reflected to the actual parameter. This is the syntax of call by reference, in which we have assigned 200 to the variable num, and then the address of this variable is passed to the function and 20 is assigned to it. Now on displaying the output, the value would be 20 and not 200 because the value is assigned to the memory location. That is why change is getting reflected. Now let's have a look at an example of swap. This is the same example as that of the call by value, but instead of passing the copies of variable, we are passing the address of the variable, and inside the function values are getting swapped with the help of temp variable, and then it is getting displayed in the main function. In this case, we can see in the output the values of variables are actually swapped. M is now 300 and N is now 250. Now let's do some examples of call by value and call by reference in our code editor, that is VS Code. Now we will do an example of call by value in which we will try to change the salary with the help of a function. So let's start. First of all, let's make a new file and name it call1.cpp. Now we will include the header files #include iostream. Now we will add namespace standard. Now first of all we'll write int main. And we will declare a variable sal and assign a value 27,000, let's say salary, to this sal variable. Now we will call a function. Let's name that function as salary underscore change. And now inside the brackets we'll write sal, as we know that in call by value we pass the copies of the variable. So now we'll display that variable. We'll write value inside main. And now we will write the variable name sal and handle now return 0. Now let's make the function salary change. We'll write void salary underscore change. It's void. Now here we will write int, the data type, and the variable s, that is the formal parameter. Sal here is the actual parameter and s is the formal parameter. Now we will assign as a new value, let's say 30,000. Here we have assigned as 30,000. Earlier the value of sal was 27,000, and then we passed the copy of the variable sal to the function salary change, and there we assigned 30,000 to it. So let's print over here value inside function. Sal and L. Here we have to write S because the variable name is S. Okay, now let's try to run this. Here we can see value inside function is 30,000 and value inside main is 27,000. Here we can see the value of the variable that is passed gets changed, but the original value inside the main function doesn't changes. So we can say changes are not reflected to the original value, which happens in call by value method. So now let's do one example of call by reference. Let's make a new file called to.cpp. Let's include the header files #include iostream . Now we'll write using namespace standard . Now we'll start with int main. Here we will declare a variable sal and assign 27,000 to it, as we have done previously. Now we'll call a function named increment. And inside the bracket we will pass the address of sal. As we know that in case of call by reference we pass the address. So after that we'll just write the message saying salary inside main, and we'll write the variable sal, then endl. After that we'll write return 0. Now our job is to write the function. We'll write void increment and here we'll write $sign s, because here we are passing the address, not any copy of the value or the variable. Here we are passing the address of the variable, so that is why we have used $sign. Now we will simply write the logic to increment. So we'll write s equals s plus 5,000. Let's say we want the salary to increment by 5,000. Then we will display the variable s. So first of all we'll write the message salary inside function. The name of the variable, after that endl. Now let's try to run this. Here we can see that the salary inside the function is 32,000 and salary outside the function, that is inside the main function, is 32,000 as well. Here we can see that the changes are reflected to the original values as well in the main function, and we know that in case of call by reference, any change inside the function is reflected outside the function because we are passing the address of the variable. So this is our output, 32,000 and 32,000. So these were some basic examples of call by value and call by reference.
Now here we will do a program in which we have to do the sum of two integers with the help of function. So let's first of all make a new file, Function.cpp. Okay, so let's start. First of all, we'll declare the header files, that is hash include iostream. Now the namespace standard. Now we'll write int main. Now inside int main, we'll declare a variable named s. Here we have declared this variable because we want to store the sum of those two integers in this variable. So we'll call the function, let's name the function as sum, and let's assume the variables to be 5 and 5. Here sum is the name of the function and 5, 5 are the arguments. Now we'll make the function sum. Here int is the return type, sum is the name, and int a, int b are the parameters. So in this function, we'll write the code to do the sum of these two integers, and for that we have to store the sum in a variable. For that, we will now declare a variable c. Now we will write c equals a plus b. Here we are storing the sum of a plus b into the variable c. Now as we know that the return type is int, so we have to return the variable instead of printing it. We'll write return c. Now in the main function, we'll print that variable. We will print the variable s because after the function completes its task of addition, the output will come back to the calling function, which is getting stored in the variable s. So we'll write the result is now we will write the variable s. Let's see. Hope it runs. The result is 10. 5 plus 5 on addition will get 10. Let's write 3 and again try to run this. The result is 8. 5 plus 3 equals to 8. So this is the right answer. Now we will do another example of C++ function in which we have to find the larger number or greater number among two elements. So let's do that. Let's create a new file. Function1.cpp. Now we will include the header files #include iostream. Now using namespace standard. Now first of all we'll write the int main. Now the variable n1. Now we will declare another variable n2. These are the two variables among which we have to find the greater number. So we'll display a message saying that enter the first number. Now we'll take the input n1. Now we'll do the same for the other one. We'll write enter the second number. We'll input the second number. Now we have to make a call to the function named, let's say, maxi, and we will pass these arguments n1, n2. Now let's make this function maxi. The return type is void. Maxi is the name. We'll write the variables n1, n2. Now we'll write the if condition because we have to find the greater number among both these elements. So we'll write the if condition. If n1 is greater than n2, then it must print the n1. So we'll also display a message saying that the larger number is n1. If n1 is greater than n2, then we'll display the n1, and if n2 is greater, then we'll display the n2. We'll write the variable n2. So let's see if that runs or not. I think we have to write the first number. Here we can see enter the first number. Enter the first number. So we'll write, let's say, 56, and the second number would be 78. The larger number is 78. So among both the numbers, as we know that 70 is greater than 56, so this is how we can show it with the help of functions. So these were some basic examples of C++ functions.
In today's session, we will learn about C++ recursion. Now, let's have a look at what we'll be covering today. First of all, we'll discuss what is recursion. Then we'll understand the working of recursion, that is how it actually works. After that, we will learn about types of recursion, and at last we will go through the advantages and disadvantages of recursion. So, what is recursion? Recursion can be defined as a process in which a function calls itself again and again until a certain condition is met. Recursion basically brings about several number of iterative calls to the same function. However, it is important to have a base case to end the recursion. For example, imagine you are calling your friend again and again for an urgent piece of work until he picks up the call. Now, here calling your friend again and again or one after the other is a recursive function, and when he picks up your call is the termination condition. And this is the basic syntax where the function name is recursion and it is being called from the main function, and inside the recursion function it is calling itself. Now let's understand its working. In a recursive function there are two parts, that is the recursive case and the base case. In the recursive case the function is being called by itself again and again, and the base case is when the function finally stops calling itself. So when the recursive function is called from the main function, then the called function will execute and it keeps on repeating as it is being called by itself from within the function again and again until it meets the base case that will terminate its calling. For example, factorial of 5. In this problem we can see a pattern, n into factorial of n minus 1. To be clear, n is 5. So n minus 1 is 4. And it is going on till n becomes 0. Here factorial is the recursive function and n minus 1 is the argument that is getting passed for every n into the recursive function. In this case, if n becomes 0 or 1, it is the base case, and n into factorial n minus 1 is the recursive condition. Now let's understand the types of recursion. First is direct recursion. As the name suggests, in this type of recursion, function calls itself directly. For example, void recursion. Here recursion is the name of the function and is being called by itself from within the function directly. Although there is no base case in this example, but it shows the idea of direct recursion. Now, coming to indirect recursion. When a function calls itself indirectly, that is, if a function calls some other function to make a recursive call, then it is known as indirect function. For example, here recursion function is calling some other function sub, and sub function is calling the recursion function. Here both the functions are calling other functions to make a recursive call. This is called indirect recursion. Now coming to advantages and disadvantages of recursion. The advantages are, in recursion we only need to define the base case and the recursive case. So therefore it provides a simple and clean way to write a code. Second is, recursion is more preferred in problems like tree traversals, Tower of Hanoi, graphs, because these are inherently recursive problems. Now, disadvantages. Disadvantages are, the recursive program generally acquires more space than the iterative program. This is because after every call to the function, each function call will keep on adding to the stack until the base case is reached. Second is, it requires more amount of time because of function calls. Now let's do some examples of recursion on our code editor, that is VS Code. Now here we will do a program in which we will find the sum of natural number up to a number which we will enter, and we will do this example using recursion. So let's start. First of all we'll name this. Recursion.cpp. Okay, now we will start with writing header file, that is #include iostream. Now we'll add namespace standard using namespace std. Now first of all we'll write int main. Now we will declare a variable, let's say num. So basically we want to enter a number. So for that, first of all we'll display a message saying that enter a number. Now we'll take the input as num. So now here we will make a call to the function, and in that function we will pass the variable num which we have taken the input of, and we will print this with a message. So let's say we'll print it like cout, and the message would be sum is, and this is the function name sum, and this is the variable which we are passing. After that, let's write return 0. Now let's make this function sum. We'll write int, the return type, sum, the name of the function, and the variable num. Now first of all we have to make a base case. So we will write the base case as, we'll make if num is not equal to 0, then here we will write the recursive case, return num plus sum num minus 1. So here we are adding the numbers with its previous number, and because of recursive condition it will keep on calling the same function, sum function, again and again till the base case, that is num becomes equal to 0, is achieved, and once it is achieved the calling would be stopped. Num not equal to 0 here means that if num is not equal to 0, then only this statement num plus sum num minus 1 will execute. Okay, so now after this we'll try to run this. Enter the number, let's say 5. Sum is 15. Here we can see sum is 15. Okay, let's recheck. 5 plus 4 equals to 9, 9 plus 3 equals to 12, 12 plus 2 equals to 14, 14 plus 1 equals to 15. So our answer is correct. So this is how we can find the sum up to any numbers which we want to find the sum of. And now let's do another example. So let's name this as Recursion2.cpp. Now here we will do a program of factorial. We will enter a number and we have to find the factorial of that number. So let's start. First of all we'll write hash include iostream, that is the header file. Now using namespace standard, now we'll write int main. Okay, now we will declare a variable number, and we want to take the input from the user, so we'll display a message saying enter the number. Now we will take the input, we'll write number. Now we will call a function and we will pass the argument number as we have done in the previous question. So let's do it. First of all we'll display that saying the factorial of the number you have entered is, now we will make a call to the function. Let's say the name of the function is fact, and we'll pass the argument number as we have done previously. Now we'll write return 0. Now let's make this function. We'll write the return type int, now fact. After that, now we will write the argument int number. Now we will write if condition, and we'll write number less than 1, and we will return 1. So here we have wrote this condition because as we know that the factorial of 0 is 1, and if a number is less than 1, that it means it is 0, and if it is 0, then our program should return 1. And we'll write now else condition, else if it is not 0, that means we will write the recursive condition, that is number into fact number minus 1. Now this is the condition that is responsible for finding the factorial of a number. For example, if we input 5, then here we can see the condition would become 5 into fact 5 minus 1, that is 4. And this 4 will be passed as argument to this fact function. And then the condition would become 4 into fact 4 minus 1, that is 3. And it is also passed to the function. And similarly, it will go on until it becomes less than 1. Now let's try to run this. Enter the number. Let's say 6. The factorial of number you have entered is 720, and we know that the factorial of 6 is 720. So this is the right answer. And let me tell you, this is the base case and this is the recursive case in this program. Now after that, let's do one last example of recursion. Okay, so now let's make a new file and name this file Now first of all, we'll add the header files, iostream, now namespace standard, using namespace standard. So here we will do the program of Fibonacci series, and we know that Fibonacci series is basically in Fibonacci series each number is basically the sum of its two previous numbers. So let's start. So first of all, we'll make int main. Now we'll declare a variable num. Now we want to take the input from the user. So first of all, we'll display a message saying that enter the number. Now we'll take the input. We'll write num. Now we will make a for loop and iterate that loop from i0 to num. So we'll write for keyword int I equal to 0, I less than num, I plus plus. Now inside the loop we will write cout to display, and we will call Fibo function, and we will pass I as an argument because we want to print the series. So we will write cout Fibo and we'll pass I as an argument, and just for the space now we'll write return 0. In Fibo function we have passed I as an argument because we want to print the series. So first 0 will be passed, then 1 will be passed, after then 2 will be passed, and so on. So now we will make the function Fibo. Int is the return type, Fibo is the name. Now the argument num. Now in this Fibo function we will put if condition for checking if the num is equal to 0 or 1. If yes, we will return the value of num, else we will recursively call Fibo using n-1 and n-2 because Fibonacci series is basically the sum of previous two numbers. So first of all we'll write if num is less than equal to 1, then return num else return Fibo num minus 1 plus Fibo brackets num minus 2, because we know Fibonacci series is basically the sum of previous two numbers. Now if the num is 0 or 1, then it will go to the if statement, and if it is greater than 0 and 1, then it will go to this recursive statement. So for example, if n equals to 2, then we will call recursively 2 minus 1 and 2 minus 2, that is 1 and 0 respectively. Since 2 minus 1 will give 1 and 2 minus 2 will give 0, these will be evaluated in if statement as they are less than equal to 1. So it will give 0 plus 1, that is equal to 1. Now let's try to run this code. Enter the number, let's say 6, 0, 1, 1, 2, 3, 5, which is the right answer. The Fibonacci sequence for 6 is 0, 1, 1, 2, 3, 5. So this is how we can do Fibonacci series or Fibonacci sequence with the help of recursion. And I suggest you to do some more examples on recursion to understand it better. In this session, we will learn about friend functions in C++. So let's go ahead and have a look at what we'll be covering today. In this session, we will cover topics like why do we need a friend function, what is a friend function in C++, then the declaration of friend function, and after that, we will learn what is a friend class, then we will understand features of friend function and its advantages. But before we begin, make sure to subscribe to our channel and hit the bell icon to never miss an update. So first is, why do we need a friend function? Friend functions are used when we want to access the private or protected members of the class, but without the help of the objects. It helps us in avoiding the case where the functions must be a member of both the classes in order to access them. Or, in other words, a function doesn't have to be a member of both the classes in order to access the class data. A friend function is also used to perform operator overloading. Like functions, operators can also be overloaded, and because of the friend function, it is possible. Now, let's understand what is a friend function. A friend function is not a member function of the class, and it is defined outside the class. And we know outside members cannot access the class data, but the friend function can access those private, public, and protected class data. because the friend function is friendly with the class. Now let's move to declaration of friend function. The declaration of friend function must be done inside the class. The friend function is declared using the friend keyword, then the return type, then the name of the function that is made a friend of the class. Its definition is done outside the class, and we don't use the friend keyword while defining it. But while declaring it inside the class, we use the friend keyword. Now, coming to the next topic, that is, what is a friend class? Exactly like a friend function, a class can also be a friend of another class. A friend class is that class that can access the data members and member functions of a class to which it is a friend. We need to pass the objects of the class to a member function of the friend class if we want to access those private and protected members. Also, if the classes are declared friends, then all the member functions of the class will be a friend function to the friend class. Now, let's have a look at the syntax. Here we have done the forward declaration of class table. This will allow the access of the objects of the class table in the class club. Inside the class club, we have declared friend class table. That means the class table is a friend of class club and it can access members of that class. After that, we have defined the class table without the friend keyword, as we can see. Now, coming to features of friend function. So here are some features of friend functions. So let's start with the first one, that is, a friend function can be easily invoked just like a normal function. It doesn't require any object or so to invoke. Next is, the scope of a friend function is not limited. It can be a member of another class as well. Third is, a friend function can be declared in any part, that is private, protected or public parts of the class. Fourth is, the object of the class can be used as an argument for the function. And the last is, a friend function can access the members by using the object name and dot operator along with the member's name. Now, coming to advantages of friend function. The first advantage is, with the help of friend function, we are able to access the non-public members of the class, that is, the private members. The second advantage is, friend function helps in operator overloading. And the third advantage is, because of the friend function, we are able to share the private information by a non-member function, as friend function is not a member function. And the last advantage is, friend function allows us to generate more efficient code. So these were some advantages of friend function. So now let's go ahead and do some examples on friend functions to understand it in a better way. So let's open our Visual Studio Code and do some examples. So first of all, let's make a new file. Let's name it friend1.cpp. Alright. So now here we'll do a simple program of friend function. So let's start with including the header file --include iostream. Now we will write using namespace standard. Alright, and inside the main function, first of all we will create an object of a class. Let's say the name of the class is salary and the name of the object is s. Alright, after that we will simply write return 0 and we will do the rest of this after creating the class. So we need to first create the class. Now we'll write class salary, which is the name of the class, and inside this class first of all we'll write private access modifier, and here we will write or declare a variable named sal. After that, now we will write or declare the friend function. So we know how to declare a friend function. We'll write friend keyword, then the return type, that is int, and then the name of the function, let's say increment, and then the objects. As we know, we have to pass the name of the class with the object because we want to access the private member of the class. So salary s, which is the object, and after the class we'll write the semicolon. Now we have to create or define this increment friend function. We'll write int increment. Here we haven't used the friend keyword because this is the definition. Now inside the arguments we'll pass the object Alright, now inside the main function we will call this friend function. So first of all we will display a message saying that increment is, that the increment in the salary is, and then we will call this function and we will pass this object. Alright, now inside this increment function, which is a friend function, we will use object s dot operator and then the name of the variable, which is private. Now all we need to do is to increment this salary variable. So we'll write s dot sal plus 7000, which is the increment, and then we will return s dot sal. Alright, now as we can see, this increment function, which is not a member function of this class, is accessing this private variable of salary class and is incrementing 7000 to the salary. So now let's save it first and let's try to run this. There is some error. Let's have a look at that. Alright, yeah, there is some spelling mistake, increment. Now let's save it and run it. So as we can see, increment is 7000. So this is the correct output. So this was a simple example of friend function. Let's do another example. So here we will do an example of friend class, and we know friend class is a class that can access the data members and member functions of a class to which it is a friend. So let's start. First of all, we'll include the header files, hash include iostream, and then the namespace standard. And we forgot to name this file, so let's do it. Let's name it friend2.cpp. Alright, now let's proceed. Int main. Inside the main function, first of all we will create an object of a class. Let's say the class name is num2 and its object is obj2, object2. Now for now, let's say we'll write only return 0. We'll do this part later onwards. Now let's create the class. Alright, so the class name would be num2, num1 actually, but we know in friend class we have to do the forward declaration. So we will write class num2. So this is a forward declaration of class num2. Now inside class num1, first of all we'll declare a variable in private. So let's say the name of the variable is int n1. Int is the data type, n1 is the name of the variable. Now we have to do the declaration of friend class. So we'll write friend keyword, after that class num2, which is the name of the class. Alright, after this let's create this. First of all we have to put the semicolon. Alright, now let's write this class num2. So this is our friend class num2. We haven't used friend keyword over here, as we can see. Alright, in this class we'll use the private access specifier and we'll create another variable n2, and then we will write the public access specifier and we will create a constructor of num2, as this is the name of the class and this is object we have created. So now we will create the constructor of this class num2, and now in this constructor we will initialize n2 with 65 or whatsoever number we want, because in the end we have to find the average of two variables. So this is the second variable n2 and we have assigned the value 65. So now let's make the function of average, because we want to find the average of both the numbers. So int is the data type, avg is the name of the function, let's say, and inside this function we will make an object of num1 class and the object name is obj1. Now as we have created the object, by mistake we have wrote I obj1. So as we have created the object of num1 class, so its constructor would be invoked, which we will create now. But first of all, here we will write return the average. So we'll write obj1 dot n1 plus n2. divided by 2. So as we know that obj1 is the object of num1 class, so that is why we have used obj1 dot operator n1, that is the name of the variable, plus n2 divided by 2. From here we can find the average, and before that we have to create the constructor of this class. So now all we need to do is write public access modifier, now num1, and inside this num1 we will assign the value to n1 variable, which is, let's say, 11. Alright, so now in the main function we have to call this function avj, that is the average function, and we forgot to put semicolon over here. Alright, now we'll display a message average is, and now we will call the function obj2 dot avg, which is a function. So here we are calling this function. So let's save this. So we have saved this. Now let's try to run this one. As you can see, the average is 38. So 65 plus 11, 6, and 76 divided by 2, which is 38. So this is the correct output. So this is a fine example of friend class. As we know, class num2 is a friend of class num1, so it can access all the members of class num1. In class num2 we have created the function avg over here. This is the function avg. Here we are doing the average of both the numbers, and as class num2 is a friend of num1, so we can create objects of num1 in num2 class. And after doing this, this is our output, that is average is 38. So this is an example of friend class. Now let's do another example. So here we will do an example of friend function in which a friend function is a friend to two classes, and this would be an example in which we have to do the product of two numbers. So let's start. First of all, let's include the header files as we have done previously. iostream namespace standard. Now let's save it, friend3.cpp, and spelling is wrong. Now let's start with the main function. Inside the int main, first of all we will create the object of class A, that is A, and class B object would be small b, and we will use these objects to call the functions, but we will do that part later onwards. First of all, we'll simply write return 0 over here, and now we will create the classes. Alright, so here we will create a class, but before that we have to do the forward declaration of another class. So this is the forward declaration of class B, and now we can create the class A, and inside the A class we will declare the variable x, let's say. Now we will use this public scope, and we will create a function within this class, let's say void assign. Now inside this function we will pass the variable I, because we have to assign the value of this variable I to the variable x. So we will assign the value of I to x like this, and before that we have to do the calling from the main function. So we will do that later. First of all, we will create the friend function, and here we are declaring this friend function. Void is the return type, product, let's say, is the name of this friend function, and A comma B are the arguments. Now let's call this assign function first of all. So all we need to do is we will make a call from this main function a dot assign, which is the name of the function, and let's say we have passed the value 45. Now here we will create the class B. Inside the B class we'll similarly create another variable y, and now inside the public scope we will create function of the same name, that is assign. Now in this assign function we will pass I as the argument, as we have done in class A. Similarly we'll do it over here. We will assign the value of I to this variable y. Once we have done this, then we will declare friend function. As we know that the friend function is friend of both of these classes, so we have to do it inside both of these classes. We have to declare the friend function, and now we will declare the friend function in this class as well, product. Alright, after the class we will use the semicolon. Now we will create the friend function. So here we are defining the friend function. We use void product, which is the name of the function. Data type object name. Alright, now all we need to do is we'll do the sum a.x into b.y, and now we'll use semicolon. So here a.x will hold the value which have been assigned, that is 45, and now b.x, b.y will hold the value which we will call from here b.assign. Here we are calling and we are assigning the value, let's say 20. We are passing the value 20, and this 20 value will be assigned to this y, and 45 into 20 would be the product. So everything is done. Now all we need to do is to call the product function, and as we know that the product function, that is the friend function, is the friend of both of the classes, so it can access the private variables. So we'll do that, product a comma b. Here we are calling this. Now let's save this one and let's try to run this. There are some errors, let's check them. Class A. Alright, so we forgot to make some space over here. Now let's save it again and let's try to run this. As we can see, the output is 900. So 45 into 20 is equal to 900, which is the correct answer, and it means the program is working fine. So this is a fine example in which a function, that is this product function, is a friend of both the classes, that is class B and this class A. Here we have done the forward declaration and we have made the friend of class A, and here we have declared the friend function in class B. And as we can see that this product function can use or access the private variables of both the classes, and so this is by using the private variables we have done the product of both of these numbers, and its answer is 900. So these were some few examples of friend functions. You can try some more examples on it. It will enhance your knowledge in C++ as it is an interesting topic. Welcome to this video on C++ header files. And in today's session, we will learn about why we need header files, then what is C++ header file. After that, we will learn about types of header files and how can we create our own header file. And at last, we will have a look at some examples of header files. Header files allows us to assemble all the predefined functions in one place, and it is helpful because it is easier to gather the declarations in one place and then use them whenever we need them. And as all the declarations are gathered in one place, so it automatically reduces the complexity and it also decreases the number of lines of code. There are many functionalities of header files. One of them is it helps in taking the input from the user and also helps in displaying the output in a program. Now let's learn what actually a C++ header file is. Header files are the set of libraries that contains predefined functions at a common place. So it basically stores the declarations at one common place and they are being used while writing a program. These header files usually have a .h extension, and we use #include before writing the header file to inform the preprocessor that we are including this header file. Now let's discuss types of header files. There are two types of files in C++. First is predefined header file. These files are already present in C++ compiler. We simply need to import these header files using #include, which will inform the compiler about the header file, and then we can write the name of the header file between the angle brackets. Next is user-defined header file. These header files are defined or created by users. In C++, user can create their own header file and include it in the C++ library, and it can be used whenever it is required. Now let's learn how to create this header file. In order to create your own header file, First of all, we will write the C++ code which we want to use whenever we want. After that, we will save the file with .h extension. As we can see in step 1, we have written the code of two integers that are getting multiplied, and now we will include this in the program. To include this in the program, we will use #include, and after that we will write the name of the header file inside the angle brackets with the .h extension. Here #include will inform the compiler that a header file is added. And now, as we can see in step 2, after the declaration of two integers, we are calling the function product and passing the arguments x and y. After running this program, we will get the output as 45. Because 9 into 5 equals 45, and we don't need to worry about writing the logic of it because we have already included this header file. Now let's have a look at some examples of header files. #include IOStream. IOStream is the header file that is used to read and write the standard input-output streams. Because of this header file, we can take the input and display the output. And in case of IOStream, .h is not used because after standardization of C++, IOStream became standard header whose function is now in std namespace. Unlike earlier when functions were defined in IOStream before standardization. Next is fstream. Fstream are associated with files. It is basically used to read the information from files and write the information in it. And next is iomanip. Iomanip is a library that is used in the manipulation of input and output statements. So these were some examples of header files.
Today we'll be discussing about C++ array. So without further ado, let's get started. So what's in it for you? We will start by understanding why do we need arrays, then what is an array, after that types of array like one-dimension array, two-dimension array, multi-dimension array, and their memory representation. And lastly, we'll go through array initialization. So first is need of arrays. We use arrays because it allows us to store similar type of data within contiguous block of memory. And it allows us to iterate through those variables conveniently using indexing. Usually, an array is used to store similar kind of data like marks scored by all the students of a class and record of attendance of all the employees in an organization. Now moving to what is an array. An array can be defined as a collection of similar kind of elements. These are always stored in contiguous memory locations, that is one after the other. The total number of elements in an array is called the length of the array. Now this is the way you can visualize an array. Here each block is capable of storing data values of some type in sequential manner, and each element can uniquely identify by its index in the array. And this is the syntax of array. Int is the data type, array is the array name, and 5 is the size of array. Now there are few types of array in C++. Those are one-dimensional array, two-dimensional array, and multi-dimensional array. So let's first of all discuss 1D array. This is the simplest form of an array. In this array, data items are arranged linearly in one dimension, having single index value to represent data elements. Now this is the syntax of 1D array. Type is the data type, then there is array name, and after that size of array. And this is the example of one-dimensional array. Now coming to its memory representation. Here we can see 2, 7, 4, 8, 1, 6 are the elements inside the memory blocks. And 0, 1, 2, 3, 4, 5 are the indexes. So by using index, we can easily access the elements, and once the array elements are accessed, a number of operations can be performed. Here array of 0 means 2 and array of 1 means 7, and so on. As each element is of type int, that is 2 byte, that means the array occupies 12 contiguous bytes because each block contains 2 bytes and there are total 6 blocks. Now coming to the two-dimensional array. In this array, each element is referred by two indexes, that is rows and columns, and they are stored in the form of matrices. The first index shows a row of the matrix and the second index shows the column of the matrix. Now moving to its memory representation. As we can see, this is a 2D array with 3 rows and 3 columns. And we can also say that these are basically three 1D array containing 3 blocks each, combined to form a 2D array in the form of a matrix with size of 3 cross 3. The horizontal lines depicts rows and the vertical lines depicts columns. And we know that index starts from 0, so first elements get stored at array 0 0, that is 0th row and 0 column. Then second element is stored at array 0 1, that is 0th row and column 1, and likewise all the elements are stored in the array. Now coming to the multi-dimensional array, these are defined as array of arrays. That means each element of multi-dimensional array is an array itself. They can have any number of dimensions and it stores the data in tabular form. A two-dimensional array is also a multi-dimensional array. And this is the syntax for a multi-dimensional array. Here, type is the data type of array, then array name is the name of the array, and size 1, size 2, up to so on size n are the dimension of sizes. After that, this is the basic example of a multi-dimensional array. Now, coming to the next topic, that is array initialization. So, there are two ways to initialize an array in C++. First is, you can initialize an array when you declare it by including the initial values in braces after the declaration. While declaring, we could use curly braces to set the values inside it. For example, in this array of size 6, the element 2 is at 0 index, 5 is at 1 index, 1 is at 2 index, and so on. If we don't mention the size of array, then the array will only be large enough to hold the elements added within the curly braces. Other than this, we can set the value after the declaration by assigning the element to the array using its index. Like array of 0 equal to 5, here we are assigning 5 to index 0, and array of 1 equal to 7, here we are assigning 7 to index 1, and same goes for the array of 2. Now let's do some examples on array to understand them better. We'll do these examples on our code editor, that is VS Code.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now we'll make a new file. And let's name that file as array.cpp, array1.cpp. Now we'll do a basic example in which we have to print the elements of array. So let's start. First of all, we'll write the header file #include iostream. Now using namespace standard, now we'll write int main. Now we'll start by writing the data type int. Now we'll write the array name, that is, let's say coupon, and now the size of array, let's say 6. Now curly braces. Now inside these curly braces we'll write those elements, let's say 5, 8, 7, 3, 9, 1. So these are those elements, and this is our array declaration. Now here int means the data type, coupon is the array name, 6 is the size of array, and 5, 8, 7, 3, 9, 1 are the elements of array. Now after that we'll write the for loop with for keyword. Now we'll initialize I with 0, I less than 6 because it is the size of array. Now we'll increment I. Now in this loop, all we have to do is to print this array. So how do we do that? So let's do cout and inside the bracket we'll write I. So here we have printed the array inside the loop, and we have put I inside the array bracket. Now the loop will run from I0 to 6, and likewise all the elements from 5 to 1 will get printed. So let's see. Let's try to run this code. So this is our output 587391. So this is how we can print the elements of an array. And if we want to print a particular element from the array, all we have to do is to write the index number of that element inside the bracket. Let's say if we want to print 7, all we have to do is to print its index number, that is 2. Now let's run this. See, 777. It is because of the loop that from I0 to I6. That is why it is getting printed 6 times. Now if we remove the loop and try to print it, then it will get print only one time. Let's see. Here 7, and this is what we want to print. Now let's do another example. Let's name this file array2.cpp. Now in this example, all we have to do is to do the sum of all the elements of the array. So let's start by writing our header file #include iostream. Now using namespace std, now we'll write int main. Now here first of all we'll declare a variable sum and initialize it with 0. Now we'll declare another variable n, and n will depict the size of the array. So first of all, in order to scan array, first of all we have to scan the size of it. So we'll scan n. Now we'll declare the array. And inside the bracket we will mention n because it is the size. Now we'll write for loop, and we will initialize with I equals 0, I less than n, which is the size of array, and we'll increment I plus plus. We are writing for loop here because we want to scan the array, and as in this array there are more than one element, so that is why we need for loops. So now we will scan the array. We'll write C in, then name of array, and inside the bracket we'll write I. Now here we have written I inside the brackets because we want to take input of elements from I equal to 0 to n, which is the size of array. Now we'll take another for loop. Now here we will write another for loop in which we are initializing I from 0 to n, and inside that for loop we will do the sum of the array. So we'll write equals to 0, I less than n, which is the size. Now we will increment I plus plus. Now inside this for loop we'll do the code, we'll do the logic of adding the elements of the array. We'll write sum. As we know that we have already initialized sum with 0, we'll write sum equals to sum plus array of I. Now for this statement sum equals to sum plus array of I, we are adding each value in the array one by one into the sum, which is initially 0. When I equals to 0, then the sum will be equal to 0 plus array of 0. And this sum will keep on getting stored inside the variable sum. As our I increments, our sum keeps on storing the addition value. Now we'll print this sum outside the loop. We'll write cout and we'll write sum is now we'll write the sum variable. Return 0. Let me tell you, return 0 is optional in C++. Basically, return value is exit status of the program and 0 is considered as OK. In C++, compiler includes it automatically, but it's a good practice. Here we forget to write the data type. Now we'll try to run it. So first of all, we'll write the size, like let's say 6. Now the elements of the array, let's say 1, 2, 3, 4, 5, and 6. Now we want to find the sum of these elements. Sum is 21. Let's recheck. 1 plus 2 equals to 3, 3 plus 3 equals 6, 6 plus 4 10, 10 plus 5 15, 15 and 6 is 21. So this is our right answer. So this is another basic example of array. So after this we'll do one example of two-dimensional array also. So let's make a new file and we'll write the header file. Let's name this file as array3.cpp. Now namespace standard. Now we'll write int main. Now we will declare a 2D array of 3 rows and 3 columns with elements inside it. Three rows, and in the second bracket we'll write 3 columns. Now we'll write the curly braces and another curly braces. This is the way to declare a 2D array. Now 2, 7, 9, let's say. Now again curly braces. 1, 3, 8. Because we are creating a matrix of 3 cross 3, that is why there are total 9 elements inside the array. So now we will create a nested for loop where the outer loop I, which is for the rows of matrix, is initialized from 0 to 2. We'll write int I equal to 0. Now I less than 3, I plus plus increment. Now we will write inner for loop j, which is for the column, and we will initialize it from 0 to 2 as well. We'll write for int j equals 0, j less than 3, j plus plus. Now we will print the array. In the first bracket we will mention I, that is the number of rows, and in the second bracket we will mention j, that is number of columns. And in order to add space, we will add space in the output. Now outside the bracket we will mention AND-L. Shift the elements to the next line. After that we'll write return 0. So this is our output, 541279138 in the matrix form. That is why I have used this space to make the output look good, and this AND-L. So this is our output, 541279138. So this is how we can print the elements of a multi-dimensional array or two-dimensional array. These were some basic examples of array, and in order to understand these programs you must practice more examples on it.
In this session, we will learn about sorting in C++. So let's go ahead and have a look at what we'll be covering today. We will learn what is sorting in C++, then the categories of sorting, which are internal and external sorting. After that, we will understand types of sorting in C++, that are bubble sort, selection sort, insertion sort, and quick sort. And at last, we will understand sorting using C++ library. But before we begin, make sure to subscribe to our channel and press the bell icon to never miss an update. So first is, what is sorting in C++? Sorting in C++ is a concept in which the elements of array are rearranged in a logical order. Now this order can be from the lowest to the highest or highest to the lowest. Rearranging them in a sorted order helps in dealing with many problems like searching the maximum element or the minimum element from an array of elements. In C++, sorting is categorized into two types, that is internal sorting and external sorting. So let's understand these. In internal sorting, the data to be sorted is present in the main memory, and the process of sorting will also take place in the main memory itself. While in case of external sorting, the data is not always present in the main memory because the data is large. So data is filled in the main memory in small portions. So this is the difference between internal sorting and external sorting. Now coming to types of sorting in C++. There are various types of sorting in C++, that are bubble sort, selection sort, insertion sort, and quick sort. So let's start with bubble sort. Bubble sort is one of the easiest sorting techniques in C++. In this technique, the comparisons are done starting from the first two elements. The adjacent elements are compared. If the element on the left is greater than the element in the right, then the swapping is done, and it will proceed till the end of the array. So first the comparison will start from the first two elements, that are 22 and 13. And as we know that 22 on the left is greater than 13. So we will swap these elements and make them 13 on the left and 22 on the right. Now it became 13, 22, 5, 7, 11. So now we will compare 22, which is at index 1, with 5, that is at index 2. And as 22 is greater than 5, we will swap these elements as well. Then again we will compare it with the next element, and if 22 is greater than that element as well, then we will swap them as well. So in this way, round 1 of comparison is complete, as one of the element reached its actual position. Two more rounds of the comparisons will occur till the array becomes sorted. It is because for n elements the number of comparisons are n-1. So number of comparisons here would be 3 as the elements are 4 in numbers. Now coming to selection sort. In this selection sort technique, the smallest element is fetched by comparing itself with the rest of the elements and is sorted at the first position of the array. Once the first element is sorted, the search for second minimum element begins from the rest of the array and is positioned at the second place. Similarly, one by one, all the elements are positioned like this. So this is selection sort. Now moving to insertion sort technique. In this sorting technique, the elements are sorted by comparing the second element with the first element. If the second element is smaller than the first, then we will swap it. After that, we will compare the third element with all the elements that are before it. Similarly, it goes for the fourth element and so on. Once all the comparisons are done, the elements becomes sorted, as we can see in the figure. So this was insertion sort technique. Next is quick sort technique or quick sort algorithm. Quick sort algorithm is one of the most widely used algorithm and the most efficient sorting algorithm. The quick sort algorithm follows a divide and conquer approach. In this approach, a pivot element is selected and the array is partitioned into two halves on the basis of this pivot element. The elements that are smaller than the pivot element are shifted to the left side of it, and the elements greater than the pivot element are shifted to the right side of it. After this, both the left and the right subarrays are sorted and combined. For example, let's suppose we have 6 elements 5, 15, 1, 8, 22 and 6, and we want to sort them using quick sort. So first of all, we will select any pivot element, let's say 6. Now we will divide the array to two subarrays based on the pivot element in such a way that the elements smaller than the pivot element are on the left and the elements greater than the pivot element are on the right. As you can see in the figure, elements smaller than 6 are on the left and elements greater than 6 are on the right. Now we will sort both of these subarrays separately. We will select a pivot element from each of the subarray. Like we can see, from the first subarray we have selected 5 and the second subarray we have selected 15. Similarly, if the element is less than the pivot element, then adjust it on the left, otherwise on the right. By doing this, both the subarrays will become sorted and now we can combine them to become a complete sorted array. So this is how quick sort algorithm works. So as we have understood about the sorting technique, now let's understand how to sort using C++ library. We can sort using the C++ library as well. To use that library function, we must include the #include algorithm header file. This function compares each and every element within the range. The syntax of function is sort, then within the brackets there will be the starting iterator and the ending iterator. And we must include this algorithm header file with #include, which is a preprocessor. So as we have understood about these sorting algorithms, so let's move to our code editor, that is VS Code, to do some examples on these sorting algorithms. Alright, so this is our code editor and here we will do some examples of sorting techniques. So let's first of all create a new file and let's name it sort1.cpp. So let's add first of all the header file #include iostream, then the namespace standard, so first of all we will do an example of bubble sort algorithm, and now we'll create the main function. Inside the main function we will create some variables
let's say int I, int j, and a temporary variable temp. After that we will declare an array arr, and let's say the size of the array is 8, and the elements of array are 12, let's say 3, 1, 5, 18, and 10, 7, and 35. So these are the elements of the array. Now we will display these elements. So we'll display a message unsorted array, as we know that these array elements are unsorted. So we'll print the message unsorted with /n. Alright, now we'll write the for loop int I equals 0 that runs from I0 to I8, because we want to print the array I less than equal to 8, I less than 8, I plus plus. Now here we will print the array arr I. So one by one all the elements will get printed, and we'll add the /t to add the horizontal space between each element. Alright, now for space we can write endl. Now we will write the logic for bubble sort. As we know, in bubble sort the swapping is done starting from the first two elements, and if the element on the left is greater than the element on the right, then the swapping is done. So we'll do that. We'll write a for loop which runs from I0 to 8, int I equals 0, I less than 8, I plus plus, and the second for loop would be int j equals I plus 1, j less than 8, j plus plus. Now I'll explain both of these loops, but before that let us just write the if condition for swapping. If arr I is less than arr j, oh, I write the opposite of that, which I have to write. Let's make it I. Yeah, if arr of j is less than arr of I, then we'll do the swap. So now I'll explain this part. Here when I is at 0, then j is at 0 plus 1, that is at index 1. So now comparison will take place between element at index 1 and element at index 0. If the right element, that is index 1 element, is smaller than the left element, that is index 0 element, then swapping will take place. And similarly, one by one, each element is compared with the next element, and it will proceed till the end of the array. So now here we will write the swapping logic. We will store the first variable into the temporary variable, and then we will store the second variable into array of I. Then we'll again store into array of j the value holded by the temporary variable. Alright, so this is how swapping is done. Now all we need to do is to just print the array elements, because we have to show the sorted elements of the array. So we'll first display a message sorted elements, right, and then we'll use /n as well. Now here again we will use the for loop, and which runs from I0 to I8, e less than 8, I plus plus. And now we will print the elements of the array, of sorted array. Just to add the horizontal space, we can write /t, and now after that return 0. Let's save it and let's hope it will work. So as we can see, this is the unsorted array 12, 3, 1, 5, 18, 10, 7, 35, and this is our sorted elements of the array 1, 3, 5, 7, 10, 12, 18, 35. So as you can see, these elements are sorted, and using the /t we have added the space between each of these elements. Alright, now let's do another example. So now let's do an example of insertion sort. First of all, let's save it and let's name it as sort2.cpp. Now let's add the header files, #include iostream, then write the namespace standard, then we'll start with the main function int main. Now we'll write the variables like int I, int j, and num variable, then the temp variable, temporary variable, and we'll also initialize the array. Let's make it 30 size. Now we'll take the input from the user. So write enter the elements, enter the number of elements first of all. Alright, we'll take the input as num, and then we'll ask the user to enter the elements. Alright, now using for loop I equals to 0 till I less than num I plus plus, we will take the input of the elements of the array one by one. So num is the size of the array, so one by one all the elements the user will enter all the elements. Alright, after that, now we'll write the code for insertion sort. Please keep in mind, in insertion sort we start by comparing the second element with the first element. If the second element is smaller than the first element, then we will swap it. After that, we will compare the third element with all the elements that are before it. Similarly, it goes for the fourth element and so on. We can see this figure for reference, and now we'll start doing the code. We'll start by writing the for loop, which starts from 0 till num minus 1, I less than num I plus plus. Alright, after that we will store the array in the temporary variable. Once it's done, then we'll write ji minus 1. First of all, we have copied the elements of array to the temp variable, then we have set j equals to I minus 1 because we have to compare it with the previous element. And alright, now we'll write the while loop. Okay, so
temp is less than ARR of j plus 1, no, only j, and for termination j must be greater than 0. Alright, let's make them inside the brackets. Alright, now first of all let's write the code, then I'll explain the part. Array of j plus 1, array of j. We will move this element forward and then we'll write j minus 1, will decrement it. Then we have to insert the element in this place. Alright, I'll explain this part. In this part we have copied the elements of array to the temp variable first of all, and then we have set j equals to I minus 1 because we have to compare it with one previous element. And while in while loop we are checking if the value of element prior to array of j is more or less. If it is less, then we move the element in order to set it to the right position. Using array of j plus 1 equals to temp, we are actually inserting the element in a proper place or the right position. We are validating that j remains greater than equal to 0. So this is how it's done, and now we have to print the elements. So now we have to print the sorted elements, so we'll write the message, we'll display the message sorted elements, and then using the for loop we'll display all the elements one by one. I plus plus ARR, inside it will write I, and we'll add some space. Once it's done, then all is left is to write return 0. Return 0. Now let's save it. Once it is saved, then now let's check if it is running fine or not. As we can see, enter the number of elements in the array. Let's say there are 5 elements, right? 8, 1, 4, 9, 2. Alright, 8, 1, 4, 9, 2. So our output is wrong. Let's check where it is. I less than equal to. This is the problem. Let's save it and let's check it once more. 5. Now 8, 5, 7, 2, 6. 8, 2, 5, 6, 7. Alright, now I get it. Actually we are checking from the first element, so we have to start with the first index. Now let's save it and try one more time. 5, 9, 5, 8, 2, and let's say 12. 2, 5, 8, 9, 12. So finally our output is correct. Because of some logical mistakes, our output was getting wrong, but now we finally can see that 2, 5, 8, 9, 12, the elements of the array are finally sorted, and this is how you can do insertion sort. Now after this we'll do another example. Alright, now let's do an example of selection sort. Let's name it as sort3.cpp. So let's understand this selection sorting technique one more time. In this technique, the smallest element is fetched by comparing itself with the rest of the element and is sorted at the first position of the array. After the first element is positioned, the search for the second element begins from the rest of the array and is positioned at the second place. Similarly, all other elements are positioned like this, as we can see in the figure. Now, let's do its practical implementation. So let's start by adding the header files. Hash include iostream. Then we'll write the using namespace standard. Now we'll start with the main function. Alright, so first of all we'll declare some variables like int I, int j, int num variable, then a variable p, and a temporary variable temp, and we also need a minimum variable. We'll name it min, and now we will declare the array. Let's make it of size 10, and yeah, now we will display a message saying that enter the number of elements. We'll write enter the number of elements. Alright, now we will take the input C in num. Now we'll ask them to enter the elements. So we'll write /n enter the elements. Alright, now again we will use /n. Once it's done, now we can take the input of the array. So we'll start with int I equals 0, I less than num, I plus plus, and now C in array arr index I. So yeah, now we can take the input from the user, and now we have to do the actual part, that is the selection sort. We have to sort the array using the selection sort technique. So let's start. We'll write a for loop int I equals 0, I less than num minus 1, I plus plus. Inside this loop we will store the value of the first element of the array. Min equals arr of I. We are storing the first element of array into this min variable. So here we are storing the value. Now we have to store the index. So the p variable which we have declared, and we are storing the index I to this p variable. Alright, after that we have to use another for loop where the actual comparisons begins. Now we will write j equals to I plus 1 and j less than num, j plus plus. Now I'll explain you this for loop. In this for loop we are doing I plus 1 because here the comparison will take place and the comparison will occur with the preceding elements. So we have to do j equals to I plus 1. Now we have to do inside this for loop, we'll use a if condition. So we'll write if minimum is greater than array of j, that if any element is smaller than the minimum element, then that particular element will be set as minimum element. So we'll do that. We'll write min equals array of j, and we also have to change the index. So we'll assign the index of j to the p. Earlier we have assigned the index I to p, but if that particular element is smaller than the minimum element, then we also have to assign the index to p. Now all we need to do is to swap. So now let's do the swapping part as well. Alright, so first of all, the temporary variable temp, we will assign arr of I. We have to swap arr of I and arr of p because the index j is assigned to p, and we all know how to do the swapping. Of I. Now we will put the value of arr of p into arr of I. Now the value at temp goes to arr of p. So the swapping is done here, and now we have to just print the sorted array. So now let's first of all display a message saying that the sorted elements are, write /n sorted elements are /n again. Now using for loop, we will print all those elements equals 0, I less than n, I plus plus. Alright, now we will just print the array, and now in order to give some space, we'll use the double quotes. Now it's done. Now return 0 will write. Now everything is done. Now let's check if it is working or not. It's done by our end, so let's save it and let's try to run. Enter the number of elements. Okay, so let's add 5. Now 5 elements are 8, 1, 5, 1, 5, 3, 7. 1, 3, 5, 7, 8. As you can see, these are the sorted elements, and this is correct. So this is how we can do the selection sort. This is our logic behind the selection sort. You can try this example as well. Alright, now we'll do an example of quick sort. So first of all, let's create a new file and name it as sort4.cpp. Now as we know, in quick sort follows the divide and conquer algorithm. So let's have a look at it. As we know, in quick sort, a pivot element is selected. Like here we have selected 6 as a pivot element, and then the elements which are smaller than 6 are put on the left side, and elements which are greater than 6 are shifted to the right side. And similarly, same thing is done with the partitions or the subarrays, and in the end when we combine, we get a sorted array. So now practical implementation. So first of all, we'll start by creating a main function, and before that we'll add the header files #include iostream and the namespace standard. Alright, now we'll start with the main function. Inside the main function, we will declare a variable num and another variable I, and declare an array arr of size, let's say 10. Now we'll display a message saying that enter the number of elements. enter the number of elements. Alright, now here it is. Now we will take the input from the user, num. Now we'll display another message saying that enter the elements. And now we'll use for loop to take the input from the user. I equals 0, I less than num I plus plus. So inside this loop, cin and arri will take the input from the user. User enters all the digits or the elements. Now we will call a function quick. And we'll pass the arguments array and the starting index and the ending index. The starting index would be 0 and ending index would be num minus 1, that is size minus 1. So this is where we are calling the quick function, and after that we can display a message saying that after sorting the elements are. And now using for loop again, we can display the sorted array afterwards. We'll add some space. Yes, and we'll write return 0. So our main function is done. Now all we need to do is to make the quick function. Alright, so let's create this quick function. Quick, and its data type would be void quick, and we'll pass the arguments or the parameters are array and the starting index and the ending index. Start, int, end. So these are the parameters, and inside this quick function we'll write the if condition, that is if start of the index is less than end, that is if the array element is more than 1, then here we will find the point of division D, and then there would be recursive calls for the divided subarrays or the partitions. So now we will make the division point D, and now we will call the function divide, and we'll pass the parameters array and the starting index and the ending index to this function as well. So here D is the division point, and by calling this function we'll find this division point. After that we will do the recursive call for the left subarray and the right subarray. So let's do that. Quick array and starting index and ending index, but here ending index would be, as it is a subarray, as it is the left subarray, so the division point is the point of division, so the ending index for the left subarray would be D minus 1. And similarly now again we'll call for the right subarray. Here the starting index would be D plus 1 and the ending index would be end. let me explain this part again. The first recursive call would be from start to d-1, and the second recursive call is from d+1 to the end. So these are the two subarrays. This is the right subarray and this one is the left subarray. So d-1 is this element and d+1 is this element. Alright, now we'll make this divide function, and we have to make this divide function above the quick function, otherwise it will show an error. Or if you don't want to do that, then you can do the forward declaration, but I'll prefer doing this only. So int is the data type, divide is the name, and now int arr, as we have passed the starting index and the starting index and the ending index. Alright, now inside this divide function, first of all we will set a pivot element. So we'll do that arr. We usually select the last element as pivot element, or you can select the first element as well, or any random element. Now we'll create another variable int index, and we'll assign it start index. Now this variable will keep the track of elements in the array, starting from all first element and all these elements. So now we'll use a for loop, and now we will do the comparison with the pivot element. So inside the for loop, int I equals start, because we'll start from the first element. So I equals start, I less than, and we will not use less than equal to, we'll use I less than n, because we don't want to include the pivot element. So that is why we'll use I less than n, and now I plus plus. Alright, now inside this for loop we will create if condition. Now in this condition, if the array of I is less than the pivot element, then we will shift it towards the left. Then we'll do the swapping. And arr I is less than pivot, then temporary variable temp, and we all know how to do the swapping, so we'll do that. arr I index. Please note that index is storing the start and pivot is storing the end, so keep in mind that. Now arr index, this temporary variable. Now we will increment this index plus plus, because this index plus plus will do the further comparison with pivot element. So if that particular element is smaller than the pivot element, then it will move to the left side, otherwise on the right side. Alright, now it's done. Now the only thing left is the positioning of the pivot element, and to do that, because we have to find the partitioning point, so we have to position the pivot element at its proper place. So for that we'll use the temporary variable again, and arr and index, then we'll swap it with index. So here we are done with the swapping. Now we have found the partitioning point, so we'll return the index. Now the pivot is at its proper position. Now all the elements on the left side of the pivot element are smaller than that, and all the elements on the right side of it are greater than that. Now let's try to save it and run it. I hope it works. There are some errors. Let's check. Alright, let's do it. And this one is extra. Alright, now let's save it and run it. Enter the number of elements. Let's say we have entered 5, not that place. 5 elements. 3, 1, 9, 5, 7. 1, 3, 5, 7, 9. So this is our sorted elements of the array, and we have done it using the quicksort method or the algorithm. And this is our code, and this is our logic behind the quicksort method. You can also practice this quicksort algorithm. It is one of the most efficient sorting algorithm. And we have done the examples of bubble sort, selection sort, insertion sort, and quicksort. You can practice them all.
Today's topic is pointers in C++. And in today's session, we will learn about what is a pointer, reference and dereference operator, then declaration and initialization of a pointer, then there is pointer arithmetic, and after that we'll go through pointers and functions, pointers and arrays, and at last we have arrays of pointers. So let's go to our first topic, that is, what is a pointer? A pointer can be defined as a variable that contains the address of another variable. It basically stores the memory address, which means it points to an address of a particular value. And like a regular variable, pointers have a data type also. Now coming to reference and dereference operators. Reference operator or address of operator is defined as that operator which is used to get the address of the variable. It can be easily obtained by preceding the name of the variable with an ampersand sign. Now, dereference operator. Dereference operator basically returns the content stored in the variable pointed by the specified pointer. For example, if we write *a, then it will return the value of variable pointed by a. Now, let's see how to declare and initialize a pointer. To declare a pointer, first of all, we will write the data type. After that, we will write the name of the variable with an asterisk sign. For example, int asterisk sign a, float asterisk b, char asterisk c. Suppose if we want to store the address into a pointer, then we will write int, that is the data type, then ptr, that is the name of the pointer, with an asterisk sign equals to a variable a with ampersand sign, which means ptr will contain the address of the variable a. Now, moving to a pointer arithmetic. C++ allows us to perform addition and subtraction operations on pointers. A pointer is basically an address, that is, it's a numeric value. Therefore, operations like addition, subtraction can easily be done on pointers. There are 4 types of arithmetic operations that can be used in pointers, that is, increment operator, decrement operator, addition, and subtraction. Each time a pointer is incremented by 1, it points to the memory location of the next element. But if the pointer is an integer pointer, its value on ptr++ would increment by 4 bytes because of the size of int data type. For example, assume an integer pointer with current value of 10. Now after the increment, its value would be 14 instead of 11 because int is of 4 bytes. Now let's learn about pointers and functions. Like a normal variable has an address, similarly every function has an address also. And we can easily access the function using its reference or address, only if we know the address of the function. Function pointers are similar to that of normal pointers. When pointers are passed to the function, the address of actual arguments in the calling function is copied into the formal arguments of the called function. And this is the syntax for a declaration of function pointer. Here int is the return type, and parentheses around function pointer tells the compiler that it is a pointer to function. And after this, they are argument lists. Now, let's discuss pointers and arrays. Arrays and pointers are very closely related to each other, and both of them are objects. When an array gets declared, the compiler assigns a continuous block of memory so that all the elements of an array can be stored in the memory. And C++ treats the name of the array as a pointer that contains the address of first element, which is known as base address. So basically, array name is the base address of the array. And if we have to assign the address of first element of array in a variable x, then instead of writing x equal to ampersand array of 0, we can simply write the name of the array only. Now, moving to the last topic, that is array of pointers. Like in array, we can store similar type of elements. It is same in case of array of pointers. But the only difference is, instead of storing the elements, the address of similar type of element is stored. In other words, it stores the pointers which point to the similar data type. And this is the syntax. First is data type, then name of array with an asterisk sign, then in the brackets it is the size of array. Now let's do some examples in our code editor, that is VS Code.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Here we will do one example of pointer to understand reference and dereference operator. We will print the values of variable and the address of that variable also, and it will give us an idea about reference and dereference operator. Let's start. First of all, we'll make a new file and name this file as pointer1.cpp. So first of all, we will import the header file #include iostream. Now we will include namespace standard. After that, we'll make int main, and now we will declare a variable val and assign it a value, let's say 105. Now we will declare a pointer variable ptr. Now we will store the address of the variable val into the pointer variable. So we will write ptr equals ampersand val. Now we'll display a message. Before printing val variable, we'll display a message saying value of val is. Now let's see what is the value of ptr. For that we will have to print ptr also, and we'll write value of ptr is. Now we will print the pointer variable ptr also. Although the value of val and ptr would be same, but in order to check, we will print that also. So we'll write cout value of specific ptr is. Now as we have printed variable val, ptr and asterisk ptr, so now let's check all these values. Let's first of all we'll write return 0. Now let's check all these values. Here we can see value of variable val is 105 and the value of ptr is this. This is actually the address, and the value of pointer variable ptr is 105. As we know that the value of val and the pointer variable is same because we have assigned this value, the address of variable val, to ptr, and then the dereference operator, as we know, returns the actual content of the variable. So that is why the value of variable val gets printed when we print the pointer variable ptr, and the address over here is the address of the val variable which we are assigning to the ptr. So that is why this address is getting printed. Now we'll do another example. Let's name it pointer2.cpp. Now we'll include the header files, hash include iostream. After that, using namespace standard. So here we have an example of arithmetic operations in C++. So first of all, we'll write int main. Now here we will take 4 variables and 2 pointers. So let's do it. Int num1, num2, int sum equals 0, and int sub equals 0. We'll initialize it with 0. Now we will declare the pointers ptr1, ptr2. So let's take input of the required variables num1 and num2, and after that we'll do some arithmetic operations on them. So let's just write. First we'll display a message. Enter 2 numbers. Enter 2 numbers. Now we'll take the input. After this, we will store the address of num1 and num2 into ptr1 and ptr2 respectively. So let's do it. ptr1 ampersand num1, ptr2 ampersand num2. Now we will increment pointer ptr1 and ptr2. We'll do in a bracket, and we'll use dereference operator also. ptr1 plus plus dereference operator ptr2 plus plus. Here we are using dereference operator because we want to increment the value only. And as we can see, we have used increment operator. So by incrementing ptr1 and ptr2, the values of num1 and num2 will increment, and after that we will print those values. So let's do it. Before printing, we'll just print a message after increment. Now we will print ptr1 and line. Now ptr2. Now we will do the sum of these incremented values. So we will write sum equals dereference operator ptr1 plus dereference operator ptr2. Now we will simply print it. We'll write addition and we'll print some variable which we have already initialized as 0 earlier, and we'll write endline. So this will give us the sum of the incremented values of num1 and num2. Now let's talk about decrementing the value of pointers using decrement operator. Here, by using this operator, the value of the ptr1 and ptr2 gets decremented. So let's start. We'll write decrement ptr1 minus minus. That is the decrement operator. Now ptr2 minus minus. Now we will write after decrement the values of ptr1 and ptr2. So we'll display a message saying after decrement now we will print ptr1 and ptr2. This will display the values of ptr1 and ptr2 after decrement. And at last we will find the subtraction of 2. So we'll write sub decrement operator ptr1 minus decrement operator ptr2 and cout will display first subtraction. We'll write subtraction, then we'll write the variable sub. Let's see how it. Before that, I think we forgot to mention the dereference operator while printing. We have to mention this because we want to print the values. Dereference operator. And let's put some space over here. Now let's try. Enter two numbers. So let's say we'll enter 4 and 5. As we can see, we have entered 4 and 5. After increment, it becomes 5 and 6. And on addition, it becomes 11. After decrement, it becomes 4 and 5 again. Then 4 minus 5, that is equal to minus 1. So this is the right answer. And this is how it's done. This was the basic example of arithmetic operations in pointers. Now let's do another example. Name this file as pointer3.cpp. Now we will include the header files hash include iostream using namespace standard. Now we'll write int main. Now we will do an example of pointer and arrays in which all we have to do is to print an array with the help of pointers. So let's start. First of all, we'll declare a pointer. Now we'll declare an array named RRAY. And let's add some elements inside it. 5, 17, 20, 7, 9, 4, 6. I think these are 7 elements. Now we will assign array ARR to pointer PTR. So we'll write PTR equals ARR. After that, we'll run a loop from I equal to 0 to I less than 7 because we want to iterate array elements. So let's write for loop int I equals 0, I less than 7, I plus plus. Now we'll display using dereference operator with pointer because we want to display the values, that is why we have used dereference operator. Now we'll do ptr plus plus. We have used ptr++ because we want the pointer to move to the next position after each iteration, and endl will help to print the output in the next line after each iteration. So after this we'll write return 0 and let's try to run it. I think there is some error. Yeah, namespace. Now let's again try to run it. Instead of array we have used arr. Hope it works now. Here it is, 27946, 27946. So these are our array elements which we want to print. So this is how we can print the array elements with the help of pointer. So these were some basic examples of pointers in C++.
In this session, we will learn about this pointer in C++. So let's go ahead and have a look at what we'll be covering today. So in this session, we will cover topics like what is this pointer, then we will have a look at the syntax of this pointer, then we will understand the working of this pointer, and after that, we will learn how to access the executing object using this keyword. And we will also learn about the features of this pointer. But before we begin, make sure to subscribe to our channel and hit the bell icon to never miss an update. So our first topic is, what is this pointer? In C++, this is a keyword that is used to represent an object that invokes the member functions. It automatically points to the object for which the object is being called. Or, in other words, this keyword points to the current instance or object of the class. For example, let us suppose we have a local variable of same name as that of the data member, and we want to assign the value of a local variable to the data member, but having the same name would create a problem. So in this type of case, we use this pointer. This keyword tells the compiler that we are referring to object's data members. Now let's learn about the syntax of this pointer. The syntax for referring class variable or instance variable would be this keyword, then arrow operator with class variable equal to local variable value. And the syntax for referring to current object of class would be this with asterisk sign or dereference operator sign. Now let's understand working of this pointer. This keyword represents the address of current instance of the class. This pointer acts as an implicit parameter to all the member functions. Now implicit parameters are similar to normal parameters. The only difference is these parameters are passed silently to the functions. That is, it is passed as a hidden argument and is automatically passed to the member function when it is called. Now let's learn how to access the executing object. As we can see in the example, we have created an object obj of class O, and with the help of this object we have called this function display, in which we are printing the address of the object, and we are also printing this pointer, and this is the executing object. So by printing this, we will get the address of object in the memory. Along with this, we can also access the data members using this keyword. Alright, now let's move to features of this pointer. The first feature would be to distinguish the data members from local variables, which means it helps in making the class members more readable by differentiating the members of the class and the parameters which have the same name. This keyword helps in differentiating between the class variable and the parameters. As we can see in the example, we are assigning the var variable, which is a parameter, to the class member var, and this can only be done with the help of this pointer. Now let's move to the next feature, that is method chaining in C++. Method chaining in C++ is a very useful feature of this pointer. It helps to chain methods together for ease and cleaner code. In this, each method returns an object and allows the code to be chained together into a single statement. It helps in invoking multiple methods that are chained together. As we can see in the example, set method, replace method, and inc method are chained together in a single statement, and arguments are also passed.
If getting your learning started is half the battle, what if you could do that for free? Visit Skill.Up by Simplilearn. Click on the link in the description to know more.
So now let's go ahead and do some examples of this pointer in our code editor, that is VS Code. Alright, so here we will do an example of this pointer in which we will show that how this pointer differentiates between the class member and the parameters having the same name. So let's go ahead and first of all let's create a new file and let's name it this one.cpp. Alright, now we can write the header files #include iostream. Now we'll write the namespace standard. Now we'll start with the main function. We'll write int main. Inside int main, first of all, we will write the class name and then the object of that class, let's say obj. Now let's write return 0 first of all, and now we can make some calls with this object, but before that let's create class. So alright, now we have to create a class which has the name A. As we know, the class name is A, we have already defined, and the name of the object is obj. So let's create class A, and inside that class we will, inside the private scope, we will declare some variables. Let's say int x, y, and z. So these three are the variables. Now I'm sorry, spelling is wrong, int z. So these three are the variables. Now inside the public scope we will create a function. Let's say the name of the function is set. So data type is void, name of the function is set, and from the main function we will call this set function. So all we need to do is we'll write the name of the object obj dot operators set, which is the name of the function, and we will pass the arguments, let's say 20, 54 and 65. These are random numbers. Now here we will write int x, int y, int z. As we can see, the parameters and the class members have the same name. So variables are of same name. So for that we know that we have to write this pointer. So we will write this x. So here this x is the parameter 1 and this x is the class variable. So this pointer differentiates between both of them, as the name is same, so this will help in differentiating. We'll do the same for y and we'll do same for x. This arrow operator z equals to z. So here we are assigning the values to these class members. Now after that we will display these values. So let's create another function. Let's say the name of the function is void print. Alright, so inside this function we will simply display these variables. So we'll write x value is the small one x value is the variable x, and after that we will write and l. Right, y value is y and l. We'll do same for z. We can copy it and just paste it. It will save some time. Alright, as we have displayed or printed all of these three variables, so as the class ends, so we need to add the semicolon in the end. Now this print function, we need to call this one. So with obj object we will call this print function. Alright, so after calling this we have already added return 0. So let's save this one and try to run it. Alright, let's check. Here it is. X value is 20, y value is 54 and z value is 65. So arrow operator helped us in differentiating between the class members and the parameters. What if we don't use this? Let's have a look at that as well. If we do not use this pointer, then let's save it and let's try to run this. Let's check the output. As we can see, x value is 0, y value is 0, z value is 0. It is not correct. So this one is right and this is our output, correct output. Now let's do another example. So here we will do an example and see that this pointer can be used for calling the member function as well. So we'll do an example regarding that. So first of all, let's name this 2.cpp. Let's save it and we'll start with hash include iostream. Now the namespace standard. We'll start with int main. Inside int main we will name the class and create the object obj. The class name is king and the object name is obj. So from here we will call a function. Let's say obj dot, let's say the name of the function is text. Here we are calling and let's say return 0 after this. Now we have to create this class. So let's create this class king, and inside this class king inside the public scope, we will declare the functions. First of all, we'll declare a function call, and now we will define a function that is text. So inside this text function, all we need to do is to print a message and call another function. So first of all, we will print a text or a message. Let's say hello brother. So after that, we'll write endl. Now we will call another, not cout. We will call this function call, which we have declared and not defined yet. So we will write this arrow operator cal call. This is how you can call using this pointer, and here we are calling this call function. So we'll close the class using semicolon, and now inside the class scope, let's say void king scope resolution operator. This means that this function is of class king. So now we will print whatsoever we want. Let's say a is, we'll display a text, let's say a, and that's it. Then we'll do the same for B and C. Here we will print B, and now we will print C. Alright, now all we need to do, and everything is done, yeah, because we have created this function outside, so we don't have to use this semicolon. Now we can save this and we can try to run this. Here we can see hello brother and ABC. So this is what we want to print. Here we can see we have used this pointer to call this call function, and after printing this hello brother, A, B and C is getting printed, so this means this is the correct output. Now let's do another example. Let's make a new file and save this one. Let's name it this3.cpp. Alright, so here now we will do an example of method chaining. As we know, we use method chaining when we want to return the reference of the object, and method chaining helps us in writing a clean code as it chains up the calling together into a single statement. So let's start. First of all, we'll include the header file #include iostream. Now we'll write the namespace standard. Now we'll write the main function. By mistake we have. Alright. Now inside the main function, first of all we'll write the name of the class, that is test, and we'll create the object. The name of the object would be n1. Now we will chain up the calls. Let's say the name of the object n1, and the name of the function, let's say, is assign, and we are passing 100. And now we'll chain up display function with it. So this is method chaining. Now we'll write return 0, and now we'll start with the class. So class name is test, and inside the class we'll declare a variable, let's say num, and now under public scope we will write the function. and we'll not define the function in a usual way. We'll write the data type. First of all, let's say test is the data type, address of operator, assign, which is the name of the function, and argument would be num. The parameter would be num, and inside this function we'll use this arrow operator, and now we will assign the value of parameter num to the class variable. After that, we can return reference to the object. We'll use the dereference operator and this pointer. Now we'll make another function, that is display, and inside this display function we'll print a message, and we'll print the variable, that is num. So first of all, we'll print the message saying that the value of num is alright. After the class, we'll put a semicolon, and we'll try to run this one after saving it. So as we can see, the value of num is 100. So let's do some modifications in that. Let's say we want to add 1000, so it will get added, but we need to save it first. Now we'll try to run. As you can see, the value of num is now 1100. So these are chain function calls, and when the reference is returned, this reference is returned, then this reference can be used to chain the function calls from a single object, that is n1 in this case. So this is the data type and this is the address of operator. When we are doing the method chain, we must do it like this, and then we will return the reference to the object. So these were some examples of this pointer in C++. You can try some more examples if you want to learn this topic in a much better way. In this video, we will learn about references in C++. So let's go ahead and have a look at what we'll be covering today. So we will learn what are references in C++, then the creation of references. After that, we will learn about reference in the function and returning the reference from the function. Next, we will have a look at the applications of references and understand the difference between reference and pointer. But before we begin, make sure to subscribe to our channel and press the bell icon to never miss an update. So first is, what are references in C++? A reference can be defined as an alternative name of the variable. As the name suggests, it is used to refer to an existing variable. It is basically used to store the reference of the variable and is stored using an ampersand sign. Although the reference and address are the same thing, but their context is different. When we are talking about reference variable, then we will call it reference rather than address. The variable can either be accessed with the help of variable name or by the reference name. So as we have understood about references in C++, so now let's learn how to create reference in C++. Let's suppose we have a variable named data, and we know how to declare a variable. First, its data type, then the variable name, and then we will assign the value to the variable. Here int is the data type, data is the variable name, and 10 is the value that is assigned to the variable. If we want to declare a reference variable for the variable data, then it would be like this. First is the data type with ampersand sign, then the name of the reference variable equals to the variable name of which we are storing the reference of. As you can see, int ampersand ref, which is the name of the reference variable, equals to data, which is the name of the variable. So we can say ref is the reference variable for the data variable and it can be used instead of the variable name. Now coming to reference in the function. We can pass the reference to the function as a parameter. It is similar to passing the pointers to the function, but it is safer. While passing the reference to the function, the changes made inside the function will also be reflected outside, because after passing the reference to the function, the passed reference will access the actual argument. So the changes that are done to the parameter inside the function will affect the arguments. In addition, it is safer and provides a cleaner code. To pass the value as reference, all we need to do is to change the function parameter as reference type. As we can see in the calculation function int %a. Now let's learn about returning the reference in C++. Similar to pointers, references can also be returned. While returning the reference, an implicit pointer is also returned. In return by reference, no local variable is returned and no constant is returned. Only the global variable is returned. In return by reference, function calling is done on the left hand side of the assignment operator. As you can see in the example, n is returned from the function, but it is not the value that we are returning, but the address of the variable. When this variable is returned, then the value 15 is assigned to it, which is then printed as we can see in the example. Now coming to applications of references in C++. So first is, references helps in modifying or changing the values inside the function without actually passing the actual arguments, because we can easily pass the reference instead of variable, and if we pass the reference to the function, then also it can modify or change the values. Second is, references helps with operator overloading, because unlike pointers, they work with references and values rather than pointer variables. Third is, references helps with writing less error-prone code, and by replacing values with references while calling avoids the unnecessary copy of data. So these were some applications of references in C++. Now let's understand the difference between reference and pointer. The reference can be defined as an alias of the variable. Here the word alias means additional name, or we can say also known for the name. On the other hand, a pointer is used to store the memory address of the variable. Reference cannot have a null value, whereas pointers can have a null value. References cannot be reassigned to other values, whereas pointers can be reassigned to other values. It returns the reference of the variable. On the other hand, pointer returns the value located at the address of the variable. Reference can be initialized during its creation only. It cannot be reinitialized, whereas pointer can be initialized as many times as required. So these were some differences between reference and pointer. Now let's go ahead and do some examples of reference in C++ in our code editor, that is VS Code. Alright, so here we will do an example of return by reference in C++. We all know how to return a value from a function. So now we will understand how can we return a reference from the function. Alright, so let's start. First of all, create a new folder and let's save it and name it as ref1.cpp. Now we will save it. Alright, so first of all we'll include the header files and then we'll start with the main function. Hash include iostream, then the namespace standard. Now let's start with the main function. Inside the main function, first of all, like normally we'll do for the functions, we'll call, let's name the function as club. So this is how we normally call a function, and after that we create a function like this, like int club, and then this is how normal calling works. But in this case, we want this function to return the reference, and for that we have to use the ampersand sign. So we have used this ampersand sign, and this is the syntax: int, which is the data type, then the ampersand sign, then the name of the function, and if we want to pass any arguments, then we can do that. And keep in mind that inside this function we cannot return any local variable or any constant. Like we cannot create a variable inside this function, assign it some value and then return it. We can't do that, and we can only return the global variable. Let me show you that we cannot return this, return 8, as this is a constant, and we can't do like this, like int p equals to 9, and then we will return it, return p. We can't do like this as well. All we need to do is to create a global variable and then we will return. Alright, so let's create a global variable. Let's say the global variable is n, and so we'll return n. Now if we want to assign some value to this global variable, we have to call this club function, and we have to make this calling on the left hand side of the assignment operator, like this. And now we have to assign the value, like let's say the value is 75. So here we are assigning the value and calling this reference operator. We are assigning the value to this global variable, this n global variable, and in this part we are actually assigning this 75 value to this global variable n. Now we can print this n variable, which is global, and check if its value is 75 or not. Alright, so let's save it and let's try to run this. As you can see, 75. So this is an example of return by reference in C++. Now let's move on to another example. Alright, now we know a reference cannot be reassigned. That also means a single reference cannot refer to two different values. But two different references can have a single value, or in other words, a value can have two different references. So in this example, we'll show how a value can have two different references. So let's start doing this example. First of all, we'll include the header files, hash include iostream. Now the namespace standard. Alright, now inside the main function we will create a variable and two different references. The variable is num and we will assign it a value, let's say 70, and we will create two different references, int num1 n1, and we will assign it to num and n2, which is also assigning to the same variable. So there are two references, n1 and n2, which are referring to the same variable num. So now we will print this variable num and both of these reference variables, that is n1 and n2, to check if they are pointing to the same value. So let's do this. We will write cout value of num is alright. Now again, value of reference n1 is n1 and L. Similarly, value of reference N2 is N2 and L. Alright, so we have printed all of these variables and references, and now return 0, and let's check if they are running fine or not. As you can see, value of num is 70, value of reference n1 is 70, and n2 reference is 70. So we can say all of these references and variables are pointing to the same value, and the value of num can also be accessed by these reference variable n1 and n2. Alright, now let's do another example. Let's name it ref2.cpp. So here we will do an example of references in C++ in which we will pass the reference into the function to swap the actual values. Basically, we don't pass the actual arguments, we only pass the references and swap the values. So let's start. So let's include the header files. Now we will create the main function, and inside the main function we will declare two variables and assign the values. Int y 17, let's say. Now we'll print, first of all we'll print before swapping, right? Alright, so now we will call the function swap. We will create a function swap afterwards, and we'll pass not the values but the references, and then we can similarly copy this one and just paste it again, and we'll do that after swapping. Here we have to do before swapping, right? So first of all we'll print the value of x and y before swapping, then we will print the values of x and y after swapping. So now we have to create the definition or write the definition of swap function. So let's write void swap, and do remember that here we are passing the references, not the values, so we have to write like this: int ampersand n1. This is how, when we are passing the values, we have to write like this, and int ampersand n2. Here this n1 is referring to x and this n2 is referring to y, and inside this swap function we'll simply swap as we know how to swap. Int temp equals n1, then we'll do n1 equals n2. We all know how to swap. Here we haven't passed the values, actually we have passed the reference, and using those references we are swapping the values. So now let's try to run this, save it, and let's run this. As you can see, before swapping x value is 12 and y value was 17, after swapping 17 and 12. So as we can see clearly that the value is swapped. So we can say using the references, or by passing the references to a function, we can actually swap the values. So this also proves that references can access the values. So these were some examples of references in C++. References in C++ is a very simple topic, and there are very limited examples on this topic. And if you find some more examples, please do try them. In today's session, we are going to learn about C++ memory management. And do check out our other videos on the C++ series. So let's go ahead and have a look at what's in it for us. First is, what is memory management? Then we will understand why we need memory management in C++. Then we will learn memory allocation and deallocation in C++ using new operator and delete operator. And at last, we will understand the advantages of new operator in C++. So without further ado, let's get started. What is memory management? Memory management can be defined as a process in which management of a computer's memory occurs. For example, assigning memory to programs, variables, etc. in such a way that it doesn't affect the overall performance. Sometimes the computer's data can range up to terabytes. So efficient use of memory is necessary so that we can minimize the memory wastage and boost up the performance. Now, let's understand why we need memory management in C++. Memory management is required so that there will be no wastage of memory, and to make sure that allocation takes place efficiently. During the declaration of an array, there are times when the correct memory is not determined until runtime. And to avoid such cases, we usually declare array of maximum size. And because of this maximum size, some memory remains unused. For example, let us suppose we have declared an array of size 30. And after declaring the array, it turns out that we only need space of 10 size. So the rest of the space is of no use, or we can say it will get wasted. To avoid such cases, we use memory allocation. So let's understand memory allocation and deallocation in C++. Other programming languages like Java, Python, etc., they don't need to allocate memory dynamically. In C language, we use the malloc or calloc functions to allocate the memory dynamically at runtime. And these functions are also supported by C++. But in C++, allocation and deallocation is done manually. In C++, there are two operators that are used for the allocation and deallocation of memory. That is new operator and delete operator. So let's understand this new operator in C++. The new operator in C++ is used for the dynamic memory allocation. It is used to allocate the memory at runtime. The general syntax of new operator is pointer variable, which is the name of the pointer, equal to new, which is a keyword, and data type is the type of the pointer. The syntax for arrays is almost the same, but after the data type, we have to write the size inside the brackets, which specifies the number of elements in an array. And here in the example, we first of all are declaring a pointer ptr of int data type. After that, we are dynamically allocating the memory using new keyword, and at last we are assigning the value 75 to the allocated memory. Coming to the delete operator. The delete operator in C++ is used for the deallocation of memory. When we no longer need to use the variable, that means the memory is no longer required, then we have to deallocate or release the memory using the delete operator. Syntax for delete operator is delete keyword with the name of the pointer variable. The syntax for arrays is delete keyword following the empty brackets and then name of pointer variable. As we can see in the example, once the printing of value is done, we have deallocated the memory using the delete operator. Moving on to the advantages of new operator. The new operator and delete operator can be overloaded unlike the malloc function. Next is, return type of the new operator is of the same type for which the memory was allocated. We don't need to use the typecasting. Third is, the new operator automatically computes the size of data object. We don't need to use the size of operator. Next is new operator in C++ allows us to initialize object while creating memory space for them. So these were some advantages of the new operator. So now let's move on to our code editor, that is VS Code, to do some examples on the new operator and delete operator. Here we will do an example using new and delete operator in C++ that will allocate the memory location for 3 values and find their average. So first of all, let's create a file and name this file as mm1.cpp. mm means memory management. So now first of all we'll include the header files, hash include iostream, now using namespace standard, now we'll start with int main. Okay, so first of all we'll create 3 pointer variables. So we'll start int star ptr1, int star ptr2. We are creating 3 pointer variables because we have to find the sum of 3 variables, so that is why we have to create 3 pointers also. And now we have to store the sum of 3 variables into some another variable, so now we'll create the variable average. Okay, now we will allocate the memory dynamically using the new keyword. So we'll write ptr1 equals new int, which is the data type. Same we will do for ptr2 equals new keyword int. Here we are allocating the memory dynamically with the help of new keyword, new int. Sorry, m is there. Now we will print the value that is stored in the memory. But before doing that, as we have allocated the memory, so now we will take the input from the users of those 3 variables of which we have to find the average of. So we'll display enter first number. After displaying this, we'll take the input from the user, we'll write C in, and using the dereference operator, we'll write ptr1. Here we are taking the input from the user for the first memory location. Now we'll take the input of the second number from the user. For that we have to print the message again. Enter the second number. Yeah. Now we'll take the input using the dereference operator with the pointer. Now same goes for the third one. Enter the third number. Dereference operator ptr3. As we have taken all the 3 numbers from the user, now all we have to do is to find the average of these three numbers, as we know that dereference operator will point to the variable. So that is how we'll get the access for the variable. Now we'll write the variable avg, that is average. We know that dereference operator will display the value that is pointer pointing at. So we are actually adding the values ptr1 plus dereference operator ptr2 plus dereference operator ptr3 divided by 3. This is how we can find the average. After that, all we have to do is to print the average. So we'll write average is avg, that is the variable, as the result is getting stored in this variable avg. So we'll print that variable, and once everything is done, once the printing is, then we have to deallocate the memory, and we will deallocate the memory by writing delete ptr1. We have to do this for all of these three pointers. Delete ptr2, because we have allocated the memory for all of these three pointers, so that is why we have to deallocate for each one of them. Okay, now everything is done, and let's try to run this. Here we can see enter the first number. So let's say 5. We have to find the average of three numbers, so we'll select the easy number to check whether it is right or wrong. Then we'll write 5 again. Now we'll write 2. As we know that 5 plus 5 equals 10 plus 2 equals 12, and the average of 12 is 4. Yeah, 3 4s are 12. So this is the correct output. So first of all, we have allocated the memory over here dynamically, then we have deallocated the memory using delete ptr1, ptr2 and ptr3. So this is how it's done. So let's do one another example. Let's name this as mm2.cpp. Okay, we'll write mm4.cpp. I think 2 and 3 are already taken, so we'll start with hash include iostream. Hash include iostream. Then we'll write using namespace standard. So in this question, we'll simply enter the elements of the array, and then we will display those elements. But we will use new operator and delete operator in this question. So let's start. First of all, we'll write int main. Now inside int main, first of all, we'll write the variable size. We have declared the variable size, and this variable size is the size of the array which we will take as an input from the user. So first of all, we'll display enter the size. Enter the size. Now we'll take the input size. After that, we will declare a pointer variable ptr. Alright, now here we will allocate the memory for the complete array. So we'll write ptr new keyword int, which is the data type, and here size. Okay, here we are allocating the memory for the complete array of size that we will enter. Okay, now we will display the message saying that enter the elements. as we have allocated the memory. Now all we have to do is to enter the elements. We'll use a for loop. So we'll start with int I equals 0, I less than size, I plus plus. Now we'll write element, and after this we'll take the input from the user for the elements of the array. So we'll write cin. Now just like arrays, we can do it for the pointer as well. We can write ptr, and just like arrays, inside the bracket I, and we can do it for the output as well. So here we are taking the input of the elements from the users. Now we have to display those elements. So for that, first of all, we'll display a message, elements that you have entered. Now we'll use for loop again. Int I equals 0, I less than size, I plus plus. Now we'll print those elements. So first of all, we'll write element now ptr, like just we did earlier, ptri, and end line, so that the output looks good. Now everything is done. We have allocated the memory, then we have taken the input from the user and displayed the output. Now all we have to do is to delete the operator. So we'll write delete, then empty brackets, ptr. Alright, now everything is done. We have allocated the memory, and here we are deleting the allocated memory. Okay, now let's try to run this. Here we can see enter the size, let's say 4. Now enter the elements 3, 6, 5, 7, and here is the output, elements that you have entered 3, 6, 5, 7. That is right, but it is not looking good. Let's use /n over here, and now let's again try to run this. Enter the size 4. Now 2, 4, 7, 9. Here is the space between them. Now it is looking good. Enter elements that you have entered are 2, 4, 7, 9. So this is how it's done. We have allocated the memory to an array of size variable. Then we have entered the elements. Then we have displayed those elements, and at last we have deallocated the memory using delete operator. So these were few examples on memory management, C++ memory management. You can try some more examples on them. In this video, we will learn about classes in C++. First, we will learn about why do we need classes. Then we will learn what is a class. Then we'll go through access modifiers and object of a class. After that, member functions. And at last, we will learn about constructors and destructors. So first is, why do we need classes? To understand this, we need to know that C++ is an object-oriented language, and it also introduces the concept of real-world entities. So in order to describe the real-world entities, we need two things, that is characteristics and functions. and a class is a mechanism of binding these two methods together in a single unit. Also, class has its own members like functions, variables, constructors, destructors, etc., which are commonly used in C++. And class has an important role in the concept of inheritance as well. Now, let's understand what is a class. Classes are one of the most important features of C++ that leads to object-oriented programming. It represents the set of properties that are common among all the objects of same type. A class basically represents a group of similar objects which holds its own data members and member function together. And this is the basic syntax of a class. First is class keyword, which is used to create class. Then after that we will write the name of the class. Then inside the name of the class there is access specifier that can be private, public or protected. After that there is data members, that is the variables, and then the member functions, and also class body must be surrounded with braces. Now let's discuss access modifiers. It basically grants permission or set the restriction for data members of the class. Access modifiers in a class are used to provide accessibility to the class member. For example, in a school, teachers are allowed to see the question papers before the exams, but the students are not allowed to do so. Anyone other than teachers cannot access those questions. Now, we can relate these teachers to data members of class which have access, and students are outside functions that do not have the access. So there are three types of access modifiers: private, public and protected. Private members can only be accessed from within the class. That means outside data members and member functions cannot access it. Public, as the name suggests, it can be accessed from within the class and from outside the class as well. Protected members can be accessed from within the class but cannot be accessed from outside the class. But with the help of friend function, it can be accessed from outside the class as well. Now let's learn about object of a class. An object is an instance of a class. It is a real world entity that contains state and behavior. When we create an object of a class, then the memory is allocated and no memory allocation occurs when class is defined. And we can create as many objects of a class as we need. In this example, state is the class and st is the object name or reference variable. So this is how an object is created. Now coming to member functions. Member functions are also known as methods. These are as much as part of the class as the member variables. These member functions can be invoked by sending messages through an instance of a class with the help of dot operator. For example, if the name of the object is obj and we want to access a function named sum, then it will be obj.sum. Here obj is the name of the object and sum is the name of the function. What is a constructor in C++? In C++, constructors are special functions that are different from normal functions. They are used to initialize objects of a class. Whenever an object is created, the constructor is invoked or called automatically. Even if we do not create a constructor, the compiler automatically creates a default constructor. Now, let's move to the declaration of the constructor. Constructors are the member functions of a class that has the same name as that of the class and it doesn't have any return type. A constructor can be defined inside the class and outside the class as well using the scope resolution operator. The syntax of a constructor is as mentioned. Inside the class cons, we can see there is a constructor which has the same name as that of class, that is cons, and we can initialize variables inside it. This constructor will be invoked automatically when the object is created. Now let's understand how the constructor is different from functions. There are some differences between constructors and functions. So the first is constructor doesn't have a return type unlike function which has a return type. Next is the name of the constructor must be the same as that of the class and it is not so in case of function. Third is whenever an object is created then a constructor is invoked. And the last one is function can be a virtual function but it is not so in case of constructors. So these are some differences between constructor and a function. Now, coming to types of constructors. There are actually three types of constructors in C++. That is default constructor, parameterized constructor, and a copy constructor. So let's start with the default constructor. A default constructor is a constructor that doesn't have any arguments inside it. It can either be declared explicitly or can be generated automatically, which means even if we do not define the constructor, then also it is generated by the compiler. For example, here cons is the default constructor. In this case, the name of the class would have been cons. That is why the name of the constructor is cons. Now, coming to the parameterized constructor. A parameterized constructor is similar to that of the default constructor. The only difference is we can pass the arguments to the parameterized constructor. The constructor can be overloaded and also be used to initialize elements. Here is an example of the parameterized constructor. Cons is the name of the constructor and n1 and 2 are the parameters of the constructor. Now, coming to the copy constructor. A copy constructor is a type of constructor which initializes an object using another object of the class. In this constructor, properties of one object is copied to another object. This copy constructor is invoked when an object is passed as a parameter. If a class has pointers or there is some dynamic memory allocation, then it is necessary to have a copy constructor. Its syntax is as follows. Here cons is the name of the constructor and &obj is the reference of the object. As we have understood all of these three constructors, so let's go ahead to our next topic, that is constructor overloading. Like functions, constructor can also be overloaded, and it is pretty much the same as function overloading. The constructor must have the same names, and the difference in the number or the type of arguments will decide which constructor should be called. Here in the example, we can see two constructors with the same names as that of the class are being overloaded. Here the difference in the number of parameters will determine which constructor will be called. Now coming to the last topic, that is destructors in C++. Just like the constructor, the destructor is also a special function which deletes or destructs the object as soon as the object goes out of scope. It basically deallocates the memory that has been assigned to the variables. The name of the destructor is same as that of the class name with a tilde sign. The destructor doesn't have a return type and it also doesn't take any arguments. And here is the syntax of the destructor. Now here we will make a new file and let's name this file as class.cpp. Now here we will do a program in which we will make a class, and inside that class we will make some functions, and with the help of objects of that class we will call those functions. So let's start. First of all, we'll mention the header files #include iostream. Now using namespace standard. Now let's make a class, and with a class keyword, and name this class as, let's say, franchise. Now here don't forget to mention the semicolon. Now here we will write the access modifier, that is public Now we'll mention those functions. Let's say void, let's name this function as KFC.
Now inside this function we will print something like, let's say, we have the best chicken. After this we'll write endl. Now we'll make another function named Burger King. As we know that these two are famous franchise, so that is why we have put this under class for franchise. Now let's print here we have the best burgers. Now we'll try to print these two functions with the help of objects that are made from the class franchise. So what we'll do is we'll write int main. After the franchise class we'll write int main, and inside this class we'll make an object of class franchise. Franchise is the class name, fran is the object name. Now all we have to do is the calling. We'll call the function KFC and we'll call the function Burger King with the help of fran object. So let's do this. Fran dot operator KFC, that is the function name. After that we'll write fran dot Burger King, return 0. Now let's try to run this one. Here it is. Actually I have run it twice, so that is why it is getting printed twice. We have the best chicken, we have the best burgers, that is what we want to print. First here friend.kfc, call this void KFC inside this class franchise. After that friend.Burger King, call this function Burger King. So that is why they have printed serial wise. We have the best chicken, we have the best burgers. After this we'll do another example. So let's do this. First of all we'll name this file class2.cpp. Okay, I think it already exists. We have to name it something else. 3. Okay, now we will write the header files. Hash include iostream. Now using namespace standard. In this example we will try to access a private variable, as we know that it can only be accessed from within the class, but it can be done with the help of setter getter methods. So let's start. First of all we'll write int main. Now we'll make an object. For that we have to write the class name, which is billboard. We'll make this class afterwards. First of all we'll write the class name, after that we'll write object. Let's name the object bill. Billboard is class name, bill is the object name. Now we will call a particular method or a function which we call setter method. So we'll write bill dot, we'll name that setter method as set title. Basically, this function will access or assign the value to the private variable which we were talking about. So we'll write here, let's say top 5 songs of 2020. We want this title to be written on the billboard. Now we'll write the getter method. Basically, the setter method or set title method will set or assign the value of to the private variable, and get method or get title method will return that value from there. So we'll write bill dot get title. Now because we want to print it, so that is why we'll write it in cout. Okay, now after that we'll write return 0. Now we will make the class billboard. Class keyword billboard. After that, bracket starts. Now we will write private because we want the variable to private. So the data type string and the variable is title. Now this variable is private and we want to assign the value to this variable, which is not possible because they are not of the same class, but we will do that with the help of setter getter method. So let's do that. Now we will write public because we want our functions to be public. Now void, that is the data type, set title, and inside the bracket we'll write the variable. Now this method is taking this parameter x, so we'll assign this parameter x to the private variable. Let's do that. Title, that is the private variable, x. Now we will write another method named get title. There are no parentheses in get title method because this method is only returning the value. So we'll write return title. Now get title function or method is returning the value of private variable title. So here what happening is, here the function set title, which is public, is taking a parameter x and is assigning to the title variable. So the message will get assigned to the title variable. Now get title function is returning the value of private variable title, which is getting called in the main function. One more thing, we forgot to put semicolon over here, and we get title cannot be void because it is returning. It would be string because it is returning some value. Now, so basically build.setTitle in the main function will set the value or assign the value to the private variable, and build.getTitle will return the value of that private variable, which will get printed. So now let's try to run this. top 5 songs of 2020. Here we can see it is getting printed. So this is how we can do that. We can access the private variable using setter and getter method.
Now let's do another example. Let's name this as class 4.cpp. Now here we will do the same example, but we will do it with the help of constructors. So let's continue. First of all, we'll write hash include iostream. After that, using namespace standard. Now here first of all we'll write int main. Now we'll name the class, we'll write the name of the class, that is billboard, and we'll make the object of it as we have done previously, like bill. Now we'll make a constructor of this object and we'll pass the parameters. We'll pass the string as top 3 songs of 2020. As we are passing this string to the constructor, that means the constructor is parameterized constructor. And now we'll write bill dot get title. Here we are writing this because this function is returning the value of private variable title, so that is why we have to write it. And we'll print it actually cout. Return 0. Now let's do the other thing. As we have done previously, we'll write class billboard. We are making this class, and inside this class we are making the variable private. String title is private. Now we'll write public access modifier. Now here we will write the constructor in which we were passing the string from the main function. So we'll write the name of the constructor. As we all know, the name of the constructor is same as that of the class, so it would be billboard, and the parameter is b. That parameters which we are passing from the main function is getting stored in b. Now inside this constructor we'll call the method setTitle. So we'll write setTitle. We are passing the same string to the setTitle method. Now we'll make this method setTitle. We'll write void setTitle string a. So actually what is happening, we have passed a string named top 3 songs of 2020 to the constructor. The constructor is further calling to the method or function named setTitle and is passing that string to the same function. Now that function is setTitle, and now we will assign that string to the private variable title. So let's write title equals a. A is that string. Now as we have done previously, we'll write void get title. Now get title function is used for returning the value of private variable, as we know. So we'll write string actually. String get title, return title. Semicolon. Now let's try to run it. I think something is wrong. Here capital S we have written. Let's make it correct. Now let's try to run again. Here we can see top 3 songs of 2020. So this is how we can print with the help of constructor. This was the same example as that of the previous one, but to understand constructors we have done this with the help of constructors and we get the right output. So after this we'll do the example of destructors. Okay, let's name this as class 6.cpp. Now let's write the header files. Hash include iostream using namespace standard. Now we'll start with int main. So first of all we will write the class name, that is Gambit. To access the class we need to have an instance or object of class. Here the name of the object is Gam. After this we will call a function display, so we will write gam.display. Return 0. Now let me tell you what is happening. So as we declared this object, constructor will be called, that is Gambit, and the message inside the constructor will be printed. After the constructor gets completed, we will return back to the main. Now we have gam.display, which is used to call display function inside the Gambit class. So after this we will write the class. Let's make it class keyword Gambit. Now we'll write public access modifier. Now we'll write the constructor, and inside the constructor we'll display the message. We'll write hello there, I'm a constructor, I'm in constructor. Now here we will write the destructor. Gambit, and inside the destructor we will print the message just to indicate that we are in the destructor. Hello there, I am in destructor. semicolon. But before that we have to write the function display also. So we'll write void display, and we'll print the message, let's say hello. And L. Now let's try to understand this again. As the object is declared, constructor will be called, that is Gambit, and the message inside the constructor will be printed. After the constructor gets completed, we will return back to the main. Now we have gam.display, which is used to call display function inside the Gambit class. So hello will be printed. Now as we can see, the program has finished the execution. Now the destructor will be called and hello I am destructor will be printed. As we know, destructor destroys the object as the scope of the object ends. So after the scope of the object ends, hello I am in destructor gets printed in the last. So now let's try to run this. Here we can see hello there I am in constructor, then hello is printed, then hello there I am in destructor is printed. As we have thought, destructor is getting printed in the last because as we know that when the scope ends, the destructor is called. So these were some basic examples of classes in C++. In order to understand them better, you must practice some more examples on them. In today's session, we will learn why we need OOPS, then what is object-oriented programming, then we will discuss the difference between OOPS and procedural programming, then we'll go through basic concepts of OOPS, and at last we will learn about the benefits of OOPS. There were some limitations in earlier approaches to programming, and OOPS help to fill those gaps. In object-oriented programming, it is easy to maintain the code with the help of classes and objects. And with the help of inheritance, there is code reusability. That is, we don't have to write the same code again and again, which increases the simplicity of the program. Now, let's understand what is object-oriented programming. Object-oriented programming is a programming pattern where the programs are structured around objects rather than logic and functions. In other words, OOP basically focus on objects that are required to be manipulated instead of logic. For example, let us suppose we have made blueprint of a mall. Then that blueprint will be a plan that explains what properties the mall should have and how it should look like, etc. But it is just a blueprint of the mall. We cannot go inside it physically as of now. Now the constructors will go through the blueprint and they will construct the mall, and they can make as many malls as they want with the help of that blueprint, and each mall can have its own different shops and showrooms. In this case, blueprint is the class, the mall is the object, and the shops and showrooms inside the malls are data stored in the object's properties. And these are some basic concepts of OOPS. First is classes, then objects, then data abstraction and encapsulation, then there is inheritance, polymorphism, dynamic binding, and message passing. We will learn about these concepts later. First, we will discuss the difference between OOPS versus procedural programming. Procedural programming follows top-down approach. Here top-down approach means fragmenting a bigger complication into smaller chunks. OOPS follows bottom-up approach, and bottom-up approach means piecing together smaller tasks to give rise to complex tasks. In procedural programming, overloading is not possible. In OOPS, overloading can be done. In procedural oriented programming, there are no access specifiers. In OOP, they have access specifiers like private, protected, public. Procedural oriented programming is less secure. OOPS is more secure because of the concepts like abstraction and encapsulation, which are used for data hiding. Now, let's learn the basic concepts of OOPS. First is class. Class can be defined as collection of objects. It is a logical entity. Then there is object. It is defined as an entity that has state and behavior, or in other words, anything that exists physically in the world is called an object. Inheritance can be defined as when one object acquires properties and behavior from its parent class. It provides code usability. Polymorphism. Polymorphism is a combination of two words, poly, which means many, and morphs, which means forms. It is basically an ability to exist in more than one form. Next is abstraction. Hiding the internal details and showing the functionality to the user is called abstraction. Then encapsulation. Encapsulation is the binding of code and data together into a single unit. Dynamic binding. Dynamic binding is the method call at runtime that means which code will execute is unknown until the program runs. Then there is message passing. It is basically a communication that exists between the objects. As we have gone through some concepts of OOPs, now let's discuss some benefits of OOPs. In OOPs, code can easily be reused with the help of inheritance and object. We don't need to write the same code over and over. Second is, with the help of abstraction and encapsulation, certain parts of program can be hidden and it helps to make a secure system. Third is, maintaining and modification of code is easy in object-oriented programming. Now, to do some examples on concepts of OOPs, let's move on to a code editor, that is VS Code. Now here we will do a program of inheritance in which we will make a parent class and a child class, and we will call the attributes using object of child class. So let's get started. First of all, let's name the file. oop.cpp. Okay, so first of all we'll add the header files #include iostream. Now adding namespace standard. Now we will write int main. So we want to create the object of child class. So first of all we'll write the name of class child, that is child. Let's put C capital, child, and now the name of the object ch. So now we will call the attributes using this object. So we'll write first of all display it. So we'll write cout ch dot name1, which is the attribute. We will declare it later. So basically we want to write both the names of both the classes together, so that is why we are doing like this. We'll write name2. Name1 will be the attribute of the parent class and name2 will be the attribute of child class. So after that we'll write return 0. Now we'll make the parent class and the child class. So first of all let's write class parent. We'll name it as parent. Then we'll write public access specifier. String is the data type. Name1. Let's write Harley. Okay, now it is mandatory to write the semicolon at the end of the class. Now we'll write the derived class, that is child. We will write the colon symbol Then we will write public name of the parent class, that is parent. So here we are writing the child class is derived from the parent class. Now within the bracket we'll write public, then string the data type, name 2, we'll write Davidson. It's a popular bike brand, Harley Davidson. So now we'll write the semicolon over here. Now we'll try to run this. As we can see, Harley Davidson. Here Harley is from the parent class and Davidson is from the child class. So as we can see that we are calling from the object of child class and still we are able to access the attribute of parent class. So this shows that the child class inherits attributes or properties from the parent class. Now as we have done one example of inheritance, so now let's do one example of polymorphism also. Let's name it oop1.cpp. First of all, we'll include the header files. #include iostream stream. Now we'll write using namespace standard. After that we'll write int main. Now here we will do an example of polymorphism in which we will make a base class and its derived classes, and inside these classes we will override a function which is common in all of these classes. So let's start. First of all, we'll write the name of the parent class or base class, animal, and we'll make an object A. After that we'll write the name of the child class cheetah and its object name is seal, let's say. Now another derived class dolphin, and we'll name the object as D. Now while making these classes, we'll write a function named speed in all of these classes, inside all of these classes, and now in order to override that function we'll call them. So first of all we'll call it by the object of animal, that is A dot speed. Now C dot speed, this is the object of cheetah class. Now D dot speed. After that we'll write return 0. Now let's make these classes. First of all we'll make the animal class, that is the base class. Animal. Now we'll write the access specifier public. Now we'll write the function void, that is the data type speed. Now we will display a message inside this function. Let's say it displays who is more faster. Who is more faster. Okay, now we'll put a semicolon in the end. Now we will make a derived class, that is dolphin. We'll write class dolphin child of animal class. Okay, so now inside this class we'll write public and we'll make the same function speed. And we'll display a message saying, as this class is of dolphin, so we'll write I'm faster in water. We'll put semicolon. Now we'll make another child class cheetah. Okay, C is capital, cheetah. Public animal. Now here we will write public access specifier and we'll write the same function void speed. And over here we'll display a message saying that I am faster on the ground. Semicolon. So now as we can see that a.speed is calling this speed function in animal class. C.speed is calling this cheetah function in cheetah class, and D.speed is calling the dolphin speed function in dolphin class. Okay, so now let's try to run this. Okay, the output is here, but it is not in very good form, so let's put /n in the end. Okay, /n. /n. Okay. Here it is. So first who is faster is displayed, then I'm faster on the ground, then I'm faster in water is displayed. So as we know that first of all we have called the animal class, so that is why who is more faster is displayed. After that we have called the cheetah class and cheetah says that I'm faster on the ground. Then dolphin class, then dolphin says I am faster in water. So here we can see that each of the class have its different implementation for the same function, that is speed, and this is how polymorphism allows us to do a single action in variety of ways. Okay, now let's do one example of abstraction. Let's name it as oop3.cpp. First of all, we'll include the header files. We'll write hash include iostream. Now we'll write the namespace standard using namespace std. Now as we know, abstraction helps in data hiding, so in this program we will make a variable named coupon as private, and with the help of setCoupon function we will try to assign some value to the coupon variable, and after that we will display it. So let's start. First of all we'll write int main. Now we'll write the name of the class, that is trade fair, and now the name of the object t. Now with the help of this object, we will call a function named setCoupon. I would say coupons. And we will pass 50 as an argument to this function. Now we'll display a message coupon, and after that we will call getCoupon method in order to display the number of coupons. So we'll write t dot get coupons and brackets, done. After that we'll write return 0. Now let's make the class and the functions. So let's start. First of all, we'll write class trade fair. Now we'll write an access specifier private and private. Now we will declare a variable coupon, and as I've already told you, we will make this variable as private, so that is why we have used this access specifier as private. Now after that we will write public access specifier to write a function that is setCoupons. setCoupons, and the parameter is C. As we know that we have passed 50 to this parameter, so now we will write the private variable coupon equals C. So here we are basically assigning the value of C to the coupon, that is we are assigning 50 to coupon variable. Now after that we will make another function and we'll put its data type as int because it is returning something. So we'll write int get coupon and we will return variable coupon. Now as the class ends, we will write semicolon. Now let's try to run this code. There is some error. Okay, we haven't tried S over here. Now let's again try to run it. Coupon 50, as I've told you. So here we have assigned 50 to this function and the variable C is assigning 50 to the variable coupon. Now after that we have used getCoupon function to return the value of coupon, and that is why it is getting displayed over here. So we got our answer, that is coupon 50. And as you can see that in this example we are not allowed to access the variable coupon, but still somehow we have managed to do that with the help of some functions. So this is an example of abstraction and it helps to increase the security of the program. So these were some basic examples of OOPS in C++. In order to understand it better, we must practice some more examples on it. Today we will learn about C++ inheritance. So without further ado, let's get started. So in this session, we will learn about what is C++ inheritance, why do we use inheritance in C++, then we will understand different modes of inheritance, and after that we will learn about types of inheritance, that is single inheritance, multiple inheritance, multi-level inheritance and hybrid inheritance in C++. But before we begin, make sure to subscribe to our channel and hit the bell icon to never miss an update. So, what is inheritance in C++? Just like a child inherits the behavior and characteristics from his or her parents, similarly, inheritance in C++ is a process in which the derived class acquires all the properties and characteristics from the parent class, that is the base class. Derived class is also known as child class, and base class is also known as parent class. Inheritance is one of the most important feature of C++ OOPS, that is object-oriented programming. In inheritance, there are two types of classes. The class which inherits the properties and behavior from the base class is known as derived class, and the class whose properties or characteristics are inherited is called a base class. Now, let's understand why we use inheritance in C++. Inheritance is used in C++ because it increases the reusability of the code and it helps in removing the redundancy. To understand it, let's suppose there are two classes, two-wheeler and four-wheeler. Both of the classes contain similar functions like color, brand and mileage. Now, if we create these classes, we have to create all the three functions in both of the classes. Or in other words, we have to write the same code two times in both of the classes. So instead of writing that code again and again, we can use inheritance and create a parent class named class vehicle. And both of the two-wheeler and the four-wheeler classes will be inherited from this parent or base class. Now with inheritance, we have inherited both the classes from one base class, that is class vehicle. Now we no longer have to write the code again and again, and we can simply write the functions once in the base class, as both of these classes are inherited from the base class vehicle. So as we have understood about inheritance in C++ and why we use inheritance in C++, so now let's go ahead and learn about modes of inheritance. There are three modes of inheritance in C++, that is public mode, protected mode and private mode of inheritance. So let's start with the public mode. In this mode of inheritance, the public members of base class remains public in derived class, and same goes for the protected members. That means inside the base class, the class members that are public will remain public in the derived class, and similarly protected class members will remain protected in derived class. Now protected mode. In the protected mode, the public and protected members of the base class will become protected in the derived class. That means the class members which are public or protected in the base class will all become protected in the derived class. In the private mode of inheritance, protected and public members of class will become private in the derived class. So now let's go ahead to the types of inheritance. So there are various types of inheritance in C++, that is single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance and hybrid inheritance. So let's start with the single inheritance. In this type of inheritance, a single derived class is inherited from the single base class. It allows the derived class to inherit properties and behavior from the parent class. The derived class objects can access the members of the base class, but the base class objects cannot access the members of the derived class. So now let's have a look at the syntax. As we know, this is single inheritance, so there will be only a single derived class and a single base class, and this is how we derive a child class from a parent class. Class keyword, then the name of the derived class, then the colon operator. After that there is an access modifier with the base class. Now as we have understood about single inheritance and its syntax, now let's move on to multiple inheritance. Multiple inheritance. When a class inherits from more than one base class or multiple base classes, then it is known as multiple inheritance. It allows us to inherit properties and characteristics from more than one base class. Syntax for multiple inheritance is class keyword with the name of derived class, then the colon operator and access modifier. with the name of the base class separated with comma and the name of another base class. Here we have shown only two base classes, but we can make more than two base classes depending upon our requirement. Now, coming to multi-level inheritance. In this type of inheritance, the derived class is inherited from another derived class. That means when a class extends a class that further extends another class is known as multi-level inheritance. For example, if there are three classes A, B, C, and class C is inherited from class B and class B is inherited from class A, then it can be called as a multi-level inheritance. Syntax of multi-level inheritance is as follows. Base class 2 is derived from base class 1 and the derived class is derived from base class 2. These base class 1, base class 2 and derived class are just the names, not a syntax. You can write whichsoever name you want with the class. Now let's learn about hierarchical inheritance. In this type of inheritance, more than one class is inherited from a single base class. That is, there would be a single base class and multiple derived classes, which have the properties and features same as that of the base class. As we can see in the figure and in the syntax, the derived class 1 is derived from base class, and similarly derived class 2 and derived class 3 are also derived from the base class. So this was hierarchical inheritance, and our next type of inheritance would be hybrid inheritance. The hybrid inheritance is the combination of more than one type of inheritance, and it can be said that it is a combination of multi-level and hierarchical inheritance. In the figure we can see the base class 1 is the parent class of derived class 1 and derived class 1 is the parent class of derived class 3, which makes it multi-level inheritance. But if you look at it in this way, that the base class 1 is the parent class of derived class 1, derived class 2 and derived class 3, then it is hierarchical inheritance, as multiple classes are inherited from a common base class. So we can say it is a combination of more than one type of inheritance or a hybrid inheritance. So as we have understood about inheritance in C++, so now let's go to its practical aspect and do some examples on our code editor, that is VS Code. So this is our Visual Studio Code, and now we will do an example of inheritance. We'll start by doing the single inheritance example, in which we will make a parent class and a child class. And let's start. First of all, we'll create a file, and let's name this file as, let's name it inherit.cpp. So here we will do an example in which we will create two classes, a base class and a derived class, and we'll create functions in those classes. Like we'll create one function in base class and one function in derived class, and using the object of derived class we will access the member of parent class or base class. So let's start. First of all, we'll include the header files, hash include iostream. Now the namespace standard using namespace std. Now we'll create a base class first, then afterwards we'll create the main function. Alright, so let's create the base class. Let's say the name of the base class or the parent class would be beverage, and inside this class let's make the scope public, and now let's create a function, as we have said, drinks. So this is a function and we will print something inside this function. So let's say we are printing all drinks are available. All drinks are available. Now we'll write endl. Now we will use semicolon in the end of the class. So this is our base class and we have created a function drinks and we have printed a message, all drinks are available. Alright, now we will create another class which is derived class or child class. We will write class coffee is the name of the derived class, and use the colon operator, public access specifier, and the name of the base class, that is beverage. Alright, now we'll write public access specifier inside this class, and we will create a function in this class also. Like let's say the name of the function would be mocha. It is a kind of a coffee, so mocha, and we will print that mocha tastes good, tastes the best, I would say. Okay, now let's use the colon operator in the end of the class. So here we have created the parent class or base class and this derived class or child class. So now we will create the main function where we'll do the calling. So now we will create the object of child class. So our child class is coffee, and now we will create the object that is C, the name of the class and the object. Okay, now we will use the object with dot operator and call this function that is drinks. And now using the same object we will call the mocha. The spelling is wrong. Yeah, now it is right. Mocha. So using the object of child class, here we are calling the drinks function, which is of the parent class. So let's see if it works or not. Let's save it and now run it. As you can see, all drinks are available and mocha tastes the best. Both of these are getting printed. That means the object of child class is able to access the member of the parent class. So this is inheritance, when the child class acquires or inherits the behavior or characteristics from a parent class or access the members of the parent class. This is an example of single inheritance. So now let's do another example of multiple inheritance. So let's create a new file and name it as inherit2.cpp. Alright, now here we will do an example of multiple inheritance in which we will create two base classes and a derived class. As we know that in multiple inheritance there are more than one base classes to a single derived class. So let's start. First of all, we'll include the header file. Now we'll use the namespace standard, and now we will create a class that is the base class and we'll name it as party. So class party. Inside this base class we will first of all declare the public scope, and now we will declare a variable, let's say meals. So now we will create a function, and in this function we will take the input from the user about the number of meals to enter the number of meals. So let's start void food. This is the function name, and first of all we'll display the message saying that enter number of meals. Alright, now we will take the input and meals is the variable. Now we will use the semicolon at the end of this class. So in this function we are taking the input of the number of meals. Now in the other class, that is another base class, we will take the input of number of drinks from the users, and then in the derived class we figure out the total bill of the party. Alright, now we will create another base class that is drinks, not drinks, drinks. Alright, now we'll write the public scope, and similarly we will create or declare another variable drink, and then now we will create a function. Let's say the name of the function is liquor. Alright, now inside this function we will take the input from the user regarding the number of drinks. So we will display the message enter the number of drinks. So the user will enter the total number of drinks used in the party or consumed in the party. Similarly goes for the meals. Now we will take the input and we'll write drink. Alright, now we have created this liquor function. Now we will use the semicolon at the end of the class. So here we have created both the base classes, that is class party and class drinks. Now we have to create the derived class. So this is an example of multiple inheritance. So we will create the derived class and use the colon operator. Now we will write the public specifier, and the name of the base class, first base class would be party, separated with comma. The second base class would be drinks. Alright, so this is how we can do that. Now inside this class we will first of all create three variables. Let's say int total meals, int total drinks, and int total bill. because in the end we have to find out the total bill. Alright, now inside the public scope we will create a function named as total. Now inside this total function we will write the logic to calculate the total bill. So what we'll do is, first of all, write the total meals equals meals into the price of a single meal. Let's say the price of a single meal is 90. So the total product would be stored in total meals. Alright, now we'll do same for total drinks. Total drinks, not frinks, equals drink into, let's say the price of a single drink is 60. Yes. Alright, now after that we have to compute or calculate the total bill. Total bill would be the addition of both of these, total meals plus total drinks. So we'll simply do the addition over here. Total drinks. So once it's calculated, we'll simply display a message saying that the total bill for the party is, and we'll write the variable that is total bill, where the total bill is actually getting stored. Alright, after this we will use the semicolon. So this is the derived class. Here we have calculated the total money spent in the party. So now we have to write the main function where it all started. Inside the main function, first of all we will create the object of child class. So we know that our child class or the derived class is bill. So bill is the derived class and b would be the object. So using this b, we will first of all call a function that is food function. So by calling this, we will take the input of number of meals. Now we will call another function named liquor. Alright, using this function, calling this function, we will take the number of drinks from the user. Now we will call this total function. So this will calculate the total money spent in the party, and after that let's say return 0. We are calling all of these functions using the object of derived class, and this is where multiple inheritance is going on. So let's see whether it works or not. We will save it and we'll try to run this. Enter number of meals, as we can see. Enter number of meals. Let's say the number of meals would be 20. It was a short party. Then enter number of drinks. 17 would be. So our total bill for the party is 3270, which is the correct answer. So this is how we can do multiple inheritance, and this is a fine example of multiple inheritance. Now let's do another example. So let's name this one as inherit3.cpp. Alright, so here we will do an example of multi-level inheritance, and we know that in multi-level inheritance a single derived class is inherited from another derived class, or in other words we can say a class extends a class which further extends another class. Then it is called a multi-level inheritance, as the name suggests. So we will do example of that. In this example we will calculate the marks of a student scored by him in 3 subjects. We will calculate the total marks scored by him using multi-level inheritance. So let's do this. So first of all we will include the header file #include iostream. Then we will write the namespace standard. Now we will create the class, base class chemistry. Alright, in this class first of all we will make the public scope and marks1. So here we will take the input of marks scored by that particular child in this chemistry subject. So we'll create the chemistry function, void chemistry. It is of same name as that of class. So let's say chemistry marks. Alright, now we will display the marks scored in chemistry. Enter the marks scored in chemistry. Spelling is wrong. Okay, now we'll take the input marks1. So the student will enter the marks. After that let's put semicolon in the end. Now we'll create another class named physics, which is inherited from chemistry class. That is, chemistry class is its base class, chemistry. Alright, So in this class we will do the same. Public int marks2, now we'll write void physics marks. We'll do the same as we have done in the previous class. So now we will display a message saying that enter the marks scored in physics. Alright, now we will take the input C in marks2. Alright, so now we will put semicolon in the end of this class as well. So now we know that this physics class is inherited from this chemistry class. That is, the chemistry class is the base class of physics class. Now we'll do same for maths, like class maths, which is inherited from the physics class. We will write physics. Inside this class as well we'll do the same, and as you can see, this physics class is the base class of maths and the base class of physics class is chemistry. So this is a multi-level inheritance. So in this class we'll do the same, public scope, and now after public scope int marks3 is the variable we have declared, and we will declare another variable in this one like total, because we have to find out the total marks. Now function maths marks, inside this one we will display the message that enter the marks scored in maths. Alright, now we'll take the input marks3 and we'll write the semicolon in the end. So here we have created all of these three classes, which is of multi-level inheritance. As you can see, we have taken the input from the user of its maths, physics and chemistry marks. Now we'll do the total. So we have to do the total inside this class only. So the name would be result function. So the total variable that we have declared is equal to marks1, marks2 plus marks3. So physics, chemistry and maths marks, we will add all of them and then we will display the total. Alright, now this is done. Now we have to go to the main function. Now first of all we will create the object of child class maths. Once this object is created, now we can call the functions, as it can access the base classes. So chemistry marks first of all, then m dot physics marks, m dot maths marks, and then the total, that is result function, m dot result. Then we'll write return 0. So return 0. So here first of all m dot chemistry marks will call this function in the chemistry class. So the user will enter the marks scored by him in chemistry. Then this will call physics marks, so the user will enter the marks scored by him in physics subject. Then similarly we will maths marks, they will enter the marks of maths. Then we will call the result function. We will do the total of all the marks scored by the student. We will do the total and then we will display that total. So pretty much it's done. Now we can save it, and now let's try to run this one. There are some errors. Alright, that's a silly one. By mistake we have done this. Alright, now let's save it and run it again. Hope it works now. Yeah, another error, marks. Now let's try again. Now it's working fine. Enter the marks scored in chemistry. Let's say 80. Physics 80. My maths is weak. Let's say 75. 235. Which is the right answer? 80 plus 75 is equal to 235. And using the object of child class, we have called the functions of all of these base classes. Like we have called this chemistry marks function and this physics marks function, which is of base class. And this was a fine example of multi-level inheritance, and this is how we can do multi-level inheritance. So these were some examples of C++ inheritance. You can try some more examples on it, and these were some decent examples. To understand it better, you can start with some basic level examples, then go to the intermediate level. Hey everyone, welcome back to another video session by Simplilearn. In this session, we will learn about C++ polymorphism. So let's go ahead and have a look at what we'll be covering today. So we'll start with what is polymorphism in C++, then types of polymorphism in C++, that is compile time and runtime. We'll also study function overloading and operator overloading under compile time polymorphism. And under runtime polymorphism, we will learn about function overriding and virtual function in C++. But before we begin, make sure to subscribe to our channel and press the bell icon to never miss an update from Simplilearn. So what is polymorphism in C++? Polymorphism is an important topic of C++ OOPS concept. The word polymorphism is derived from two words, that is poly, which means many, and morphs, which means forms. So basically it means many forms. Polymorphism in C++ can be defined as when the member function or the object behaves differently in different situations or circumstances. Then it can be called as polymorphism. For example, a mother has different relationships with different family members inside the house. For example, she is a parent to her child, she is a wife to her husband, she is a sister to her brother, and she is also a daughter to her parents. So we can say a mother as a single entity has different behavior among different members. And same goes for polymorphism, where functions behave differently in different situations. Now, let's understand the types of polymorphism. There are two types of polymorphism in C++, that is compile time polymorphism and runtime polymorphism. So let's start with compile time polymorphism. As the name suggests, this type of polymorphism occurs during the compile time and it is achieved by overloading the function or overloading the operator, that is, by function overloading or operator overloading. So what is this function overloading? Function overloading is a feature in C++ where the functions having the same name but different in terms of parameters or type of parameters can be overloaded. For example, as we can see, two functions with same name func differ in the type of arguments. One data type is double, another data type is integer. So when we make a call to the function with arguments of type double, it will invoke the suitable function, and the same goes for the other one. In example 2, there is a difference in number of parameters among functions. So while calling the function, if we pass two arguments, it will invoke the first function, and if we will pass three arguments, then it will invoke the second function. Then next is operator overloading. Like functions, operators can also be overloaded. In operator overloading, we can redefine the functionality of the operator. It helps us in redefining the already existing operator. For example, instead of writing sum equals s1.add s2, we can easily write sum equals s1 plus s2. That is, we can redefine the plus operator and use it to add the numbers in the operator function. And we will discuss the syntax of operator overloading in the examples. Now, coming to runtime polymorphism. In this type of polymorphism, the functions are invoked during the execution of program, that is, during runtime. This runtime polymorphism can be achieved through function overriding. So let's understand this function overriding. In function overriding, the function of the base class gets a new definition in the derived class. In this, more than one function has the same name and same type of parameters. The only difference is in the definition of both the functions. That is, functions have different definitions in the parent class and the child class. As you can see in the example, void message function has a different definition in the parent class and in the child class. Both have the same name, but in parent class it is printing hello there, and in child class it is printing nice to meet you. By using the object of the base class or derived class, we can invoke the suitable function. So let's move on to our next topic, that is virtual function. Virtual function is also used to achieve runtime polymorphism. It is a function that is defined in the base class and then is redefined in the derived class. The function is defined using the word virtual in the base class, and the name of the function is same as that of the derived class, having different definitions as shown. It tells the compiler to perform the late binding on the function in derived class. The function call is resolved at runtime and in late binding, and the compiler determines the object type at runtime. With the help of virtual function, we can invoke the derived version of the function in the derived class. So as we have covered the theoretical aspect of C++ polymorphism, so let's go ahead and cover the practical aspect of this topic in our code editor, that is VS Code.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So here we will make a new file and let's name it as poly1.cpp. Alright, poly1.cpp. So let's save it. So here we will do an example of function overloading, which is used to achieve compile time polymorphism. And we know function overloading is a feature in C++ in which two functions have same name but differ in terms of parameters or number of parameters, or the type of parameters can be overloaded. So let's start. First of all, we'll write the header file #include iostream. Now using namespace standard. Alright, so now we will create a class king, and inside that class we'll do the overloading. So the class name is king, and inside the class, first of all, let's make public scope. Now we'll create a function. Return type is void and the name of the function would be pro. Inside this function, let's say we are passing two arguments, int a and b. Alright, now we'll print both of these arguments or variables inside this function. Alright, and we'll use endl in the end. Okay, after that we'll create another function, and the name of the function is same, that is pro, but in this case we'll make the arguments like int a, int b, int c, int d, and int e. So there are 5 arguments in this function, second function pro, as we know that the name of the function is same. And now inside this function we'll simply add all of these. So a plus b plus c plus d plus e. Alright, once we are done with this, we'll use semicolon in the end of the class. Alright, now we'll start with the main function. Inside the main function, we will create the object of king class, king, and the object would be k. With the help of this object k, we will call these functions. As we know, the name of the functions are same, the only difference is in the number of arguments. So I'll call the pro function, which accepts only 2 arguments. So the first pro function will be invoked. So I'll pass 10 and 20. So these 2 arguments will be passed over here. Alright, similarly, now we'll call the pro function again, but now we'll pass 5 arguments so that the second pro function would be invoked. So let's say I'm passing 12, 23, 20 and 62, 6. These are some random numbers. Alright, now return 0
in the end. Now let's try to run this. I think we are done with this. First of all, let's save it, and now let's try to run this. So this is our output, 10, 20. Let's multiply both of them. It will look good. Let's save it and run it again. As you can see, 200 and 123. So this is our output. 10 into 20 would become 200, and if we add all of these, we'll get 123. So this is our correct output. So this was the example of function overloading, and let's start with another example. So now let's create a new file and name this file as poly2.cpp. Alright, we have saved it. Now here we will do an example of operator overloading. As we know that in operator overloading we give definition to already existing operators, or we can say we can redefine the functionality of already existing operators. So let's start. First of all, we'll include the header files as we have done previously. Hash include iostream, then the namespace standard. So first of all, we'll start with the main function, and inside the main function we will write the name of the class that we will create and the object. Let's say the name of the object is O1, and we'll pass the arguments to the constructor. Let's say the argument is 6 and 8. Alright, then I think we can write return 0, and we'll do the rest afterwards. First of all, we will create the class. So as we know that the name of the class is overload, so let's create it, class overload. And inside this class, inside the private scope, we'll start with the variables. Let's say the first variable is n1, and let's declare another variable n2. Then we will create the public scope. Inside this we will create the parameterized constructor, so it is of same name as that of the class, that is overload. And now as the constructor is parameterized, so int num1 and num2 are the parameters. So when we'll create this object O1 and we'll pass these arguments, so it will go here. And alright, inside this, in the definition of this constructor, we will declare the variable res, and we will assign num to n1, we'll assign num2 to n2, and let's say we'll do the subtraction. Alright, n1 minus n2. Alright, now we will display the result, that is res. So res, and then the variable res. After that we'll use endl. Alright, so once we are done with this parameterized constructor, then we will create a operator function. So void is the return type, then we will write operator keyword. This is the syntax of operator function. Then after writing the keyword, we'll write the symbol. Let's say minus is the symbol. Then the arguments, if there are any arguments, then we can put those. Then inside the function, that is in the definition, we can perform whatever the functionality we want to perform. So let's say in this case we'll just make the numbers negative, so we'll do that. Alright, now we'll do the calling part of this. We'll simply use the symbol and the operator. and this is how we'll call the operator function. This is very simple, and after that we have to display the digits as well, as we have made them negative in this part. So we'll create a function display, and inside this function we will display those digits or numbers. So we'll write n1 alright. After this we'll do same for n2, so we'll write n2, then there is ndl in the end. Alright, so here we are displaying this. So once we are done with this, the class is finished, so we can use the semicolon in the end, and we have to call this void function as well. So we will write o1.display, o1.display. Alright, we are done. Let's see whether it works or not. Let's save it and check it. So as we can see, the result is -2, that is 6 minus 8 equals -2, that is correct, and n1 is -6 and n2 is -8 because we have made them negative inside this operator function. We forgot to add some space in n2 and n1, so that is why it is looking like this, but the answer is correct, and this is how we can do the operator overloading. In this part we have used the return type, then the operator keyword, then the symbol, and if there are any arguments then we can pass those arguments, and if there are not we can put it like this. So this is our example of operator overloading. Let's do another example. So now we'll do an example of function overriding. So let's name this poly3.cpp. So in function overriding, the function of base class gets a new definition in the child class, and when we call the function of the child class using the object of child class, then the function of base class gets overridden. So now let's do the example of this function overriding. I think we have named it wrong. poly3.cpp. Alright, let's name it 4. poly4.cpp. Alright, now let's save it. Now include the header files. Using namespace standard. Now we'll start with the class parent. So this is the base class and we have named it parent. Inside the parent class we will create a function. For that we'll create the public scope. Inside the public scope we will create the function print, and we will display the message, this is the function of parent class or base class whatsoever. Alright, so this is class parent and semicolon in the end of the class. Now we'll create the child class, child derived from parent class. Name of the class is parent. Similarly we'll do the public scope and create the function void print. So it is same function as that of the above class, and inside this function we will display, this is the function of child class, derived class, let's say. Alright, once we are done with this, semicolon in the end and semicolon in the end of the class as well. Then we can create a main function, and inside the main function we will create the object of child class, child obj. So as we have created the object of child class or derived class, so with the help of this we will override the function of the base class. So we'll write obj dot print, which is the name of the function. So as we have created the object of child class, so it will call the derived class or child class function, and in the end let's say return 0. Now save it and try to run this. This is the function of derived class. So as we have expected, so it is calling the child class function. So this function of the parent class gets overridden as we have used the object of child class and call this function print, which is of same name. So this function which is in the child class gets to print derived class. So this is our output. So now let's do an example of virtual function in C++. Virtual functions are defined in the base class to ensure that the functions gets overridden, and when we use the base class pointer to hold the derived class object or the child class object, the base class pointer will always call the base version of the function and not the derived version. So to solve this problem we use the virtual keyword in C++. So now let's start with it. First of all we'll write hash include iostream. Now the namespace standard. Now we will create the base class base, and then we'll use the public scope. Inside the public scope we will create the virtual function. We'll use the virtual, the return type, then the name of the function, that is print. And we have created this virtual function inside the base class. Now we'll print. This is the function inside the base class as we have done previously in the previous question. This function, this is the function of base class. Yeah, it would be right. Alright, once we are done with this, we'll close the class by using semicolon. Now we'll create the derived class and we'll name it derived from the base class, whose name is base itself. Now here we will use the public scope and we'll create the function of derived class, print function, and we'll print this is the function of derived class. Alright, now we'll use the semicolon to end the class. Now inside the int function, int main function, first of all we will create the pointer of base class, base dereference operator b. So we have created the pointer of base class. Now we will create the object of derived class, derived d. So now we will store the address of derived class object to the pointer of base class. So let's do that. B, which is a pointer of base class, address of operator, the object of derived class. So now we will call the print function using the pointer of base class, and it will print the derived class function because the pointer of base class which we are using to call the functions points to the derived class object. So now let's do the calling part. All we need to do is
the pointer and the arrow operator and the name of the function, that is print. After that we can write return 0. Now everything is done. Let's save this and run it. As we can see, this is the function of derived class. Here we can see, so the derived class function is getting called, which we wanted. So this is an example of virtual function in C++. We have used this virtual keyword over here, and using the base class pointer we have called this function, and these were some examples of different topics in polymorphism in C++. You can try some more examples on these topics. It will help you in understanding this topic in a better way. In today's session we will learn about C++ operator overloading. So without further ado, let's get started. So we will be covering today what is operator overloading, then we will discuss non-overloadable operators. After that we will learn types of operator overloading in C++, that is unary operator overloading and binary operator overloading. So first is, what is operator overloading? Operator overloading is a special case of polymorphism in which the operator is overloaded to provide special meaning to the user-defined data type. Basically, it adds some features or redefines the functionality of already existing operators. For example, let us suppose we have three objects of same class, namely A, B, C, and C equals A minus B. Now here we can redefine how minus operator works, and we can write C equals A minus B instead of writing C equals to A dot subtract B. And this is the general syntax of operator overloading. First is the return type of the function. After that, operator is the keyword, then symbol is the operator we want to overload, then the arguments are those which are passed to the function. Now let's move on to the non-overloadable operators. There are some operators in C++ that cannot be overloaded because it is not syntactically possible to overload them. First is the dot operator. Then next is scope resolution operator, and third is pointer to member operator, and at last we have ternary operator. Coming to the next topic, that is types of operator overloading in C++. So there are two types of operator overloading, that is unary operator overloading and binary operator overloading. First is unary operator overloading. It is defined as an operator which contains only one operand or works on only one operand. Increment operator and decrement operator are examples of it. There are two ways to do operator overloading, that is from the class function and the friend function. Its syntax using class function is the return type, operator keyword, then the symbol and the brackets. But if we are doing postfix in the function, then we have to write the data type inside the brackets. Syntax using friend function is friend keyword, return type, then operator keyword, after that symbol, and in case of friend function we have to pass an argument. Next is binary operator overloading. An operator which contains two operands or works with two operands is called binary operator overloading. Addition, subtraction, multiplication are examples of binary operator overloading. Syntax using class function is return type, then operator keyword, then the symbol, and then we have to pass an argument inside the brackets. And syntax using friend function is friend keyword, then the return type, after that operator keyword, and then the symbol, and in case of friend function we can pass two arguments. Now we will do one example of unary operator overloading in which we will increment the value of the variable with the help of operator overloading. So now let's move on to our code editor, that is VS Code. So here first of all we'll make a new file and name that file as operator.cpp. Now first of all we'll write the header files #include iostream. Now we'll write the namespace standard. Now we'll start with int main, and inside int main first of all we'll write the name of the class, that is increase, and its object inc. Now we will call the void operator increment function, so we will write plus plus inc. Here when we write plus plus inc, then function void operator plus plus will be called, which we will make later. So as of now, first of all we write inc dot display in order to display the output. We are calling the display function over here. Now after that we'll write return 0. Now we'll make the class. So we'll write class increase, which is the name of the class. Now we'll use the access specifier private, and we'll write the variable int value. Now we'll write another access specifier public, and now we will make the constructor because we have created the object inc, so that is why a constructor is called, and we are making it increase. And inside the constructor we have given the value 10 to the variable. Now plus plus inc is calling the void operator plus plus function, so we'll write that function void operator increment, which is the symbol. Now value equals value plus 5, because we are incrementing the variable with 5, so we'll write value equals value plus 5. Now after that we have to display the value variable, so we will write void display, because we have already called over here inc.display. So now we will write inside cout, we'll write the message value is now the variable value and endl. After the class we have to use the semicolon. Now let's try to run this. Here is our output. Value is 15. Previously the value was 10, then on increment its value gets 15, which is the right output. So here first of all we have created an object and constructor is called, and inside the constructor we have initialized value with 10. Then with the help of object inc, that is when we are using plus plus inc, then we are calling the void operator function, which is increasing the value of the variable by 5, and then we are displaying it with the help of display function. And one more thing guys, in case of postfix, that is in case of inc++, we have to write the data type inside the void operator function, that is over here. Now let's do another example for binary operator overloading. So let's name this operator 2.cpp. Now here we will do one example of binary operator overloading, in which we will add two complex numbers. So let's start. First of all, let's make the header files #include iostream. Now using namespace standard,
Now we'll write int main. Okay, now first of all we will write the name of the class, that is complex. So we'll write complex, and then the objects like com1, com2, res. We have created 3 objects. Now we will write a message because we have to take the input from the user. So first of all we'll write a message. Enter first complex number, because we have to add 2 complex numbers. So first of all we'll take the input of the first one, that is /n. Okay, now we have to write com1 dot input. Input is the name of the function which we will be creating afterwards. Then cout enter second complex number. That is, now we'll write /n. Okay, now after this we have to write the semicolon, and we'll write com2 dot input. These input function will take the input of complex numbers from the user. We will declare them later, we will make them later. Okay, now here we will do an operation with the help of plus operator function. So we will write res equals com1 plus com2. This function call from com1 will go to the complex of operator plus function, and com2 will be passed to the argument obj, and the result will be stored in variable res. Okay, now we will call another function output in order to display the output, res.output. After that we'll write return 0. Now we will make the class complex. We'll write class complex. We'll write the access specifier private, and the variables int real and int imag, that is imaginary, because we know in complex number there is a real part and imaginary part. Okay, now we'll write public access specifier, and now we will write the function input. In order to take the input from the user, void input. Now first of all we have to display a message. We will write enter real and imaginary parts respectively. Okay, now we will write cin, because we have to take the input, and the variable name real and imaginary. Now we will write the overloading function. We'll write the return type, that is the complex, then operator keyword, then symbol, then argument,
complex obj. Okay, now we will write complex temp. So here we have created the data type temp of complex class. We'll make it a capital C. Okay, now we will write temp.real equals to real plus obj.real. So we'll write temp.real equals to real plus obj.real. The plus operator over here will add the real part of the number to the real part of another number. And similarly we'll do it for the imaginary part. We'll write temp.imaginary equals imaginary plus obj.imaginary. And then the value of the variable temp is returned. So we'll write return temp. The value was stored in temp, so that is why we have returned temp. Now we will make the output function. We'll write void output. We'll write output is variable real, then we'll write plus, then imaginary, and then I, because this is the syntax for complex number. Okay, now we have to put the semicolon over here. As the value of temp is returned, now the result is stored in variable res, and then we will print the output using the output function. This is the output function, and the value is stored in res, and then we are printing the output using the output function. Com1 over here is getting passed to the complex of operator plus function, and com2 is getting passed to the argument obj, and the result is getting stored in res. Now let's try to run this code. The first complex number, let's say 2 plus 2 iota, so we will write 2 and 2. And then enter second complex number, that is enter real and imaginary parts respectively. Now we have to write the real and imaginary parts of the second complex number. So we'll write 4 plus 6 iota. So the output is 6 plus 8 iota. 2 plus 4 equals 6 and 2 plus 6 equals to 8. So this is our correct output. We are basically adding two complex numbers with the help of binary operator overloading. So this is how it is done. So these were some important examples of operator overloading. You can try some more examples on it in order to practice them well.
Hey everyone, welcome back to another video by Simplilearn. In this session, we will learn about encapsulation in C++. So let's go ahead and have a look at what we'll be covering today. So we'll start by understanding what is encapsulation in C++. Why do we need encapsulation in C++? Then we will learn about access modifiers. After that, we will understand the benefits of encapsulation and also the difference between encapsulation and abstraction. So let's start with encapsulation in C++. Encapsulation is a very important concept of object-oriented programming. It can be defined as wrapping up of data and functions together into a single unit. Just like a capsule, the data members and functions are wrapped together. Wrapping them into a single unit helps in keeping them secure from the outside access. For example, inside a class, the variables and functions are declared and then bind together with the help of class, which also implements encapsulation. Next is
Why do we need encapsulation? Hiding the details or attributes is also an important thing that one should focus on. Encapsulation helps with that part. It keeps the details of the object hidden or safe from the users by securing them from the outside access. There are many implementation details that the users are not supposed to see. So these details, like the details of the object, are kept secure from the direct access from outside the class with the help of encapsulation. The data hiding is done with the help of access modifiers. So let's understand these access modifiers. The access modifiers helps in data hiding part. The access modifiers provides or grant the access to the members of the class, or it prevents them from the direct access to the class members from outside the class. So there are generally three types of access modifiers, that is public, private and protected. So let's understand them. In public access modifier, other classes and function can access the data members and member functions of the public class. For example, park is a public property. Anybody can go to the park or access the park because it's a public. Nobody has to take the allowance of anybody to go to the park. Now coming to the private. In private access modifiers, only the member functions inside the class have the access to the class members. Functions outside the class cannot access them. For example, a house is a private property. Any member outside the family cannot access the house without permission. Only members inside the family can access it because it's a private property. Now let's understand protected. In protected access modifier, similar to private scope, it cannot be accessed from the outside class, but it can be accessed from the derived class. The derived class is also called the child class. Also, the protected member of a class can be accessed from the friend function. So as we have understood about these access modifiers, now let's understand the benefits of encapsulation. Encapsulation helps in reducing the complexity of code by hiding the irrelevant data or information, and by doing so, it reduces the complexity. Second is, encapsulation helps in hiding and protecting the data by wrapping the data and functions together, which are generally complex, and by doing so, provides a simpler view to the user. With the help of encapsulation, the variables of the class can be hidden from other classes. Third is, encapsulated classes can easily be altered using the access modifiers. That is, we don't need to change the entire program. All we need to do is to change the access scope of the variables that can be private, protected or public. So these were some benefits of encapsulation. Now let's go ahead and understand the difference between encapsulation and abstraction. Both of these concepts are similar in some ways, but now we will discuss their differences. So let's start with encapsulation. Encapsulation helps in combining the data and functions together in a single unit, whereas in abstraction, the unwanted information is kept hidden. Encapsulation helps in hiding the data and helps in providing an easier view. Abstraction helps in hiding the implementation details. Encapsulation can be implemented using an access modifiers, whereas abstraction can be implemented using abstract class and interfaces. In encapsulation, problems are solved at implementation level, and in abstraction, problems are solved at design level. So these were some differences between encapsulation and abstraction. Let's go ahead and do some practical examples on this topic.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So this is our code editor, that is Visual Studio Code, and now let's create a new file and let's name it encapsulation.cpp. So first of all, we know in encapsulation we can make variables inaccessible by making their scope as private. So in this example we will do that. We'll make the salary of an employee as private, and then using the setter and getter methods, we will set the value of salary and return it as well. The setter getter methods are generally used in these kind of situations where the variable we want to access is private. So now let's start. First of all, we will create the main function, but before that let's add the header files. Now using namespace standard. Now we'll start with the main function, and inside the main function, first of all, we'll create an object by declaring the class name. Let's say the class name is company and the object name is obj. Now using this object, we will call the set function, or we can say the setter function. We will name it as set salary, let's say, and we will pass two values, 30,000 and 6,000. One would be the full-time salary and one would be the overtime. Alright, now after that we can display those, and we can write total salary and after that we can call the get function to return the salary, as the getter function is used to return the output and set function is used to set the values. So we'll write obj.get salary. So the salary we will display over here, and after that we can write the return 0. Now the main function is done. Now let's start with company, class company, and inside this class, first of all, inside the private scope, this is the private scope and this is the variable salary. Now this variable salary is private, so no member outside the class can access it. But using the setter and getter methods, we will access this variable and we will set the salary and then we will return it. Alright, now public scope, inside the public scope we will write the setter methods, void set salary and int full time, int overtime. So these are two variables. This 30,000 that we are passing is a full-time salary and this 6,000 is an overtime salary. So we need to add both of these salaries in this part. So we'll write salary equals full-time plus overtime. So this would be the total salary, and let's just do this. Alright, so this set salary function is done. This is the setter function. Now we have to return using the getter function, so we'll write the data type int get salary. Now inside this function we will simply return the variable salary, as we can see, and once the class we'll use this semicolon. Alright, pretty much everything is done, and now we can save it and let's try. As you can see, total salary is 36,000 as 30,000 plus 6,000, so it is working fine. So this is how we can access these private variables using these setter and getter methods. Now let's do another example. This example of encapsulation will also be pretty much the same. We'll do the setter getter methods in this one as well, but in this example we'll find the area of circle. Alright, let's start then. First of all, we'll include the header files, that is hash include iostream, and the namespace standard. We also forgot to save this. Let's name this one as, first of all, the location is work. Now let's name it as encapsulation2.cpp. Alright, now the header files are added. Now we'll start with the main function first of all. Now inside this main function we'll create an object. First of all, we'll write the name of the class, that is ball. Now the name of the object is obj. Now using this obj object we will call the setter function, that is the set area function, and we will pass the radius. Alright, obj dot set area, this is the setter function. Now we will pass the radius. Now we can display the area by calling that getter function, but before that we will display a message. We'll write area of ball is alright. Now we will call that getter function, get area. Alright, the main function is done. Now we need to create the class. Class ball. Inside this class, private scope, inside the private scope we'll create that variable area, and let's make its data type as float, because we know that there are chances that the answer could be in decimal form, because we have to use pi in that, because the area of circle is pi r square, so 3.14 is the value, so that is why we are using float as the data type. Alright, now in the public scope we'll set the radius inside this function, set area and int radius. This is the radius, that is 6 that we are passing. This is the parameter, and inside this function area equals, we know that pi r square is the formula, so we'll write 3.14, that is the value of pi, into radius again into radius r square. Alright, so this is the area of circle or ball, we can say. After that, float is the data type. Now we have to return the area using the getter function, float getter. Its name is get area, and we'll simply return the area variable. Alright, after that we can use semicolon in the end, and pretty much everything is done. So let's save it and let's check it if it is running fine or not. As you can see, area of ball is 113.04. So if we multiply 3.14, that is the value of pi, with 36, that is 6 into 6, it will give you 113.04. So this is the right answer, and this is how we can find the area of ball or something like that. And as we can see here, the area is private, and using these set area and get area methods, that is the setter and getter methods, we are accessing this private variable, that is area. So these were two examples of encapsulation. You can try these examples as well. Hello everyone, welcome back to another video by Simplilearn. In this session we will discuss an interesting topic, that is exception handling in C++. So let's go ahead and have a look at what we will be covering today. So we will start with what are exceptions, then why do we need exception handling in C++, and what exception handling is. Then we will understand exception handling keywords, that is try, catch and throw. and we will understand each keyword in detail. So first, we will start with what are exceptions. Exceptions are the unexpected events or the situations that arise during the smooth execution of the program. So there are times during the runtime when some errors or situations arises which create issues in the program. These issues are called exceptions. For example, let us suppose we want to divide two numbers, one is 7 and other one is 0. Now if we divide 7 with 0, it will show an error because we cannot divide any number by 0 because it is undefined. So exception handling provides a way to take care of problems like these. So now let's learn about exception handling, but before that we must understand why we need exception handling. So why do we need exception handling in C++? One of its reasons includes handling the exceptions that arise during the execution of the program. Along with that, exception handling provides a mechanism through which we can handle the error generating part separately from the rest of the code. Exception handling provides information to the user about the problem so that he or she can detect the mistake and correct it. Now, let's go ahead and understand what exception handling is. As we have discussed, exception handling helps in dealing or handling the exceptions that disrupts the flow of execution of a program. So how does it deal with the exception? So when an exception is encountered, it transfers the control from one part of the program to the other, known as handlers, and makes the code more readable and maintainable, and takes care of the exception by providing certain code. These exceptions are handled with the help of exception handling keywords. Now let's understand these exception handling keywords. So there are three exception handling keywords named try, catch and throw. As we can see in the example, first there is try block, then followed by three catch blocks, and each catch block contains the name of the exception. The try block can have more than one catch block. Inside the try block, those statements are enclosed which may cause the exception. Or we can say, in this block, that particular code is kept which will throw the exception. Each try block is followed by one or more than one catch block. The try block throws an exception which is caught by the catch block. Taking care or handling the exception is the actual job of catch block. This block catches the exception thrown from the try block. Inside the catch block, a message or some code is written to handle the exception. It can be a message for the user or a default code for a particular condition. Both the try block and catch block work together, and every try block has at least one catch block for it. Now next is throw keyword. Whenever an exception is encountered, it helps in throwing the exception. It is used to throw an exception and its value to the consecutive exception handler. So as we have discussed this topic theoretically, now let's go ahead and do its practical implementation in our code editor, that is VS Code. So this is our code editor. Here we will do an example in which we will make sure a person who is less than 24 years of age is not allowed to drink in the club. So we will create an exception in that part, and with the help of try, catch and throw blocks, we will handle those exceptions. Alright, so first of all, we'll create a new file and let's name it as exception1.cpp. Alright, now we'll start with the header files, that is hash include iostream. Now the namespace standard. Now we'll start with the main function. And inside the main function, first of all we will declare a variable named age. So we'll write int age equals to, let's assign it as 20. So this person is 20 years of age, and now we will create the try block. So inside this try block, we'll write an if condition, that is, if the age of the person is greater than equal to 24, then only he is allowed to drink. So inside this we will print a message saying that you have the access to drink the alcohol. Alright, so after this, inside the else block, all we need to do is to throw and the exception, that is, if the age of the person is not greater than 24, that is, age is less than 24. So in that condition, or in that situation, we will throw the exception, that is, we will throw age to the catch block, and for that we have to create the catch block. So the catch block will catch the exception, that is age, as you can see. Now inside this catch block, first of all we will write a message. We'll write you don't have the access to drink alcohol. You don't have because your age is less than 24. Alright, so after this message, we will print the age of the person. So we'll write your age is so and so, and then the variable age. Now after that we'll write return 0. So in this example, as we can see, the person age is 20 as we have assigned, and inside the try block we have set a condition that if the age of person is greater than 24, greater than equal to 24, then he or she have the access to drink the alcohol, and if not, if his or her age is not greater than 24, then we'll throw the exception, and the catch block will catch the exception and will print this message that you don't have the access to drink alcohol because your age is less than 24, and then his age will be printed. So now let's try to run this. I hope it works. As you can see, you don't have the access to drink alcohol because your age is less than 24 and your age is 20. And now let's try to, if we assign, let's say 25. The program is working fine, but we want to check the other condition as well. Okay, so it is happening because we forgot to save this 25. As we have now saved it, now let's try to run this. As you can see, you have the access to drink alcohol because now our age is 25. So this is how exception handling works. This try block, inside this try block we kept those code or statements which will throw the exception, and then it is thrown with the help of this throw keyword, and then the catch block solves or prints a message with respect to that exception. So now let's do another example. So let's create a new file and name it, let's say, exception2.cpp. Alright, so here we will do an example in which we will try to divide a number by 0, and as we know that we cannot divide a number by 0, so it will throw an exception. So let's do this example. So first of all, our hash include iostream, the header file, then the namespace standard. Now inside the main function we will create three variables. Main. So inside the main function we will create three variables. One is for the numerator, then denominator, and then in which we will store the output, that is the output variable. So let's name numerator as num and denominator as denum because it is sounding familiar. Then we will store the output in the output variable. Alright, so we have created three variables, num, denum and output. Now first of all, here we will display a message to enter the numerator and denominators. So we'll write please enter the numbers to do the division. Alright, after that endl. Now we'll take the input C in num and C in denum. So the numerator and denominator we have taken the input from the user. Now after that we'll make the try block. So inside this try block we will create an if condition and we'll write if denum, that is the denominator, is equal to 0. If it is equal to 0, then we will throw the exception, and the exception would be denum because denominator cannot be 0. And if the denum is not 0, then in else condition we will simply divide. Output equals to num divided by denum. Alright, so now after this we have to create the catch block also because we have thrown the exception. Now we want the catch to catch the exception. So we can write D for denum here. Now we'll print a message saying that you cannot enter 0 in the denominator. So we'll write you cannot enter 0 in denominator while doing the division operation. Alright, now after that we'll use endl. So this is our catch block. After this catch block we will again write a message that the output of the division is, that is, if the denominator is not 0, then we have to print that result. So for that we will do this, the output after the division is, and here we will write the variable output. So this will print the result of this one where the denominator is not 0. So after that we can write return 0. So there is one extra bracket, as you can see, of try block. Alright, now it's done. We can save this one and let's try to run this. But before running this one, let's go through this code. That first of all we have declared these three variables. Then we ask the user to enter the numerator and denominator. So then we have used this try block, and inside the try block we have set the condition that if denominator is 0, then we will throw the exception, and if it is not, then we'll simply divide both of the numerator and denominator. So the denominator which is thrown is caught by this catch block, this, and it will display a message that you cannot enter 0 in the denominator while doing the division operation because it is undefined. And if the denominator is not 0, then it will simply print the message and the output. So now let's try to run this. So as we can see, please enter the numbers to do the division. So let's say the first number is 8 and second number is 0, that is denominator is 0. Then you cannot enter 0 in the denominator while doing the division operation. The output after division is 0. So it will show this output only and our output is correct. Now let's try to run this and do the simple division operation in which the denominator is not 0. So let's say now again we'll write 8 and the denominator would be 2. Then as we can see, the output after the division is 4. So our code is correct and our output is also correct. So this is how we can do the exception handling and handle the exceptions using this try, catch and throw blocks. Welcome to this tutorial on C++ vectors. So let's jump in and see what's in it for us. So we will be covering today why we use vectors in C++, what is a vector in C++ and its syntax. Then we will go through the member functions of vectors like modifiers, iterators, capacity, and we will understand each of their functions also. So first is why we use vectors in C++. Vectors are used when we are not sure about the size of data. Like in case of arrays, we have to guess the size of the data first because it is not possible to resize it later. But in case of vectors, we don't have to set the size of vector and it is resizable. That is why it is more preferable for dynamic elements. And it also has some inbuilt functions like pushback, size, empty, etc., which helps in dealing with data values. Now let's understand what is a vector. Vectors are array-like containers that is used to store data, and the data is stored in contiguous storage locations. But unlike arrays, its size can be changed automatically depending on the number of elements, and it is not necessary to mention the size of vector while declaring it. Now let's have a look at the syntax here. Inside the angle brackets, this is the data type of the vector. It can be string, int, float, etc. and v2, v1, v3 are the names of the vectors respectively. Now let's understand the member functions of vectors. A vector container has three types of member functions, that is modifiers, iterators and capacity. So let's understand these functions in detail. First is modifiers. These are those functions that are used to modify data elements. For example, first is pushback function. This function is used to add a new element to the end of the vector. Next is popback. This function deletes the last element of the vector. Then there is insert function. It is used to insert a new element at a specified position. In this function there are two parameters. First parameter specifies the position and second specifies the value. After that, erase function. Erase function is used to remove the elements at a certain position or to remove a range of elements. Either you can write the position of the element you want to remove inside the bracket, or you can write starting position and ending position of the range of elements inside it. Next is swap function. This function is used to swap the contents or elements between two vectors. And if there are two vectors named v1 and v2 that we want to swap, then its syntax would be v1.swap v2. Then there is assign function. This function is used to assign values to the vector. In this function there are two parameters. First one specifies number of values to be assigned and second represents the value that is to be assigned. Last is clear function. This function is used to remove all the elements from the vector. Now moving on to iterator functions. These are those functions that helps in iterating across the elements. First is begin function. It basically returns the iterator pointing to the beginning of the vector. The next is end function. This function returns the iterator pointing to the end of the vector. Now coming to capacity functions. These functions that lie under capacity are associated with size. So first is size function. This function returns the number of elements in the vector. Next is max size function. This function returns the maximum size that a vector can hold. Then there is resize function. This function changes the size of the container, and inside the brackets a number n is mentioned. If n is less than the size of container, then content is reduced by removing extra elements. But if n is greater than the size of the container, then extra elements are added at the end, so that it reaches the size of n. After that, capacity function. This function returns the size that is currently allocated to the vector container. At last, there is empty function, which checks whether the vector is empty or not. If it returns true, then it is empty, and if false, then it is not empty. Now, to understand these vector functions in a better way, let's do some examples of these vector functions in our code editor, that is VS Code. So first of all, let's make a new file and name this file vector.cpp. Now first of all, we will write the header file, that is hash include iostream. Now we will write the header file hash include vector. This is the header file for vector because we are doing some examples on vectors, so that is why we have to use it. Now we'll write the namespace standard using namespace std. Now we'll start with int main. Now first of all, we'll define the vector, so we'll write vector, and inside the angle bracket we will write int, which is the data type. Now the name of the vector, we'll write n. Now first of all, we'll see the functionality of assign function. As we know that assign basically puts the value at positions, so we will write n dot assign. Now first of all, we'll write the number of values, like 9 is the number of values. After that, in the second parameter, we'll write the value. Here it means that we are putting 1 to 9 positions in the vector. That is, we are assigning 1 to 9 positions. Now in order to print this, first of all, we'll display a message saying the contents are. Now in order to print these contents, basically we have to write a for loop. We'll write int a equals 0. We'll initialize it from 0. Then a less than n dot size. This is the size function. It basically returns the number of elements. Now a++ will increment. We have to now print this. We have to write like an array in order to print all the elements. We'll write n and inside the bracket a. Now we'll leave some space. We'll write end l. we wrote endl over here in order to insert a new line. Now after that we'll see the functionality of another function, that is pushback. And we know that pushback functions adds an element at the end of the vector. So we will write end dot pushback and then the element which we want to add, like let's say 2. Now we have to display this last element also. So in order to display this, we will store the size of vector in some variable and then we will print the last element. So we will write int no, this is the variable name, then we will write n dot size. Here we are storing the size of the vector in some variable no. Now we'll display last element. We'll display the message saying last element, and then we will print the last element. And as we know, in order to print the last element we have to print the n-1th element. So we will write n bracket no minus 1. Here we are writing n bracket no minus 1. This will print the last element. After that we'll write endl. Now after that we will see another function, that is pop back. It basically removes the last element. So we'll write n pop underscore back. So this function will remove the last element that we have added, that is 2. So we need to print this also. So we'll write, first of all we'll display a message. Now the contents are now we again write the for loop as we have done previously. We'll write int a equals 0, a less than n dot size a plus plus. Now we'll again print in the form of array. And inside the bracket we will write a. Then in order to give some space we'll write this. After this we'll write endl to add one new line. So firstly we displayed the contents, then we added one element at the end and then displayed that element. After that we have removed that element with the help of popback function. As you have noticed that we are just doing the functions of modifiers yet. So in this example we will cover some functions of modifiers only. Then in the next examples we will do for iterator functions and then for the capacity function. So now let's do the functionality of insert function. As we know that insert function is used to add an element at a specified position. So we will write n dot insert n dot begin. It will point to the first element, then 7. As we know that the first parameter specifies position and the second specifies the value. So n dot begin will point to the first position and 7 is the value. So now we will print it also. We'll write first element is, then we will write display the first element. then we'll write end-l. Now we will use the function clear to remove all the elements. So we'll write end.clear clear, and then in order to check we will write end.size. So first of all we'll write now the size is, and in order to check whether all the elements are removed or not, we'll write end.size. It will display the size. The program is pretty long, but let's just hope it runs. Here it is. Now the contents are last element. Let's have a look whether it is right or not. 1 is displaying 9 times, then last element we have added 2, then we have removed that element. It is also correct. Then the first element we have added using insert, 7 is there, and after using clear function now the size is 0. So this is the correct output. Now after doing this function, let's try another example. Now here we will do the example of iterator functions, in which first of all we will add some elements inside the vector and then we will print them using iterators. So let's start. First of all, name this vectors2.cpp. Now first of all we'll write the header file #include iostream. Then the header file for vectors #include vector. Then we'll use namespace standard. Now we'll start with int main. So here we will write vector, and inside the angle brackets we'll write the data type, that is int, and then the name of the vector, that is num. Now we will write the for loop, and with the help of for loop we'll add the elements inside the vector one by one. So we will write for int I equals 0, I less than, let's say 5, I plus plus. Let's make it 1 over here. Okay, now after that we'll push these elements one by one inside the vector. So we will write the function pushback. We'll write num dot push back, and here I will write I. Okay, now because we want to add the elements from 1 to 5, so that is why we have to use less than equal to, because we want to include 5 also. Okay, now we have to print these elements, right? So we'll write, first of all we'll display that output from the beginning to the end. Okay, now we will write for loop, and with the help of iterators we will print the elements of vector. So we'll write auto, this is the iterator and A is the iterator name. Then we'll write num dot begin. As we know that begin function points to the first element of the vector, so that is why we have written num dot begin. Now we will write A less than, sorry, not equal to num dot end, then a plus plus. Now after that we have written a not equal to num.end, and we know that end function returns the iterator to the end of the vector. And after that we have used increment operator, so this loop will run from beginning till it reaches to the end. And inside for loop we will write the dereference operator with a, so that each element which is getting pointed by a will display one by one with the help of loop. So let's write, we'll write cout dereference operator a, and then we'll give some space. Now let's try to run this. This is the output from the beginning to end, 1 2 3 4 5. This is our right output. This is the message which we want to display, and this is the output 1 2 3 4 5 which we want to display, which we have added in the vector and then we have displayed. So now let's do another example which includes the capacity function. So we'll make another file, vector3.cpp. So in this example we will add some elements in the vector and then we will apply some functions on it. So let's start. First of all we'll include the header file, hash include iostream, then the header file for vectors, hash include vector, then we'll write the namespace standard using name space std. Okay, now we will write int main. So first of all we'll write vector and then the data type and then the name of the vector, let's say v. Now one by one we'll put some elements inside the vector. So we'll write for loop. We'll start with int x equals 0, x less than equal to 10, x plus plus. Because we want to add these elements, so we will write v dot push back and then we will write x inside the brackets, semicolon. Now here one by one all the elements from 0 to 10 will be added. Let's make it 1 to 10. Okay, now we will apply some functions on this vector. So let's first of all try out the size function. So first of all we'll write vector size is, and then we will write the function v dot size, and then we'll write endl. So this function will tell us the size of the vector because we have already added the elements from 1 to 10, so it will display 10. After that we will use the try out the capacity function. We'll write capacity of vector is, and then we will write v dot capacity. After that here also we'll write endl. Now we will use the maximum size or the max size, so we'll write maximum size of vector is. So in order to calculate the maximum size, we write v dot max underscore size and L. As we know that v dot size will give us the size of the vector, and capacity function, this function returns the size that is currently allocated to the vector container, and max size, this function returns the maximum size of the vector. So all of these functions result will be displayed because we have wrote them inside cout. Now let's try another function, that is resize. Now in order to resize the vector, we'll write v dot resize, and then we'll write the number that we want to resize it with, like let's write 5. Now in order to check this also, we will display. So we'll write vector size after resizing. Resizing is, I forgot to put the commas. Okay, now we'll write v dot size, because now we want to find the size after resizing. So we have written v dot size. Now after that we will write and L. Okay, now we'll try the empty function. We'll put empty function inside if. Now inside if we'll write v dot empty equals false. It means if the vector is not empty, because we have written v dot empty equal to false, not true. We have written v dot empty equal to false. That means if it is not empty, then we'll display vector is not empty, and in else condition we will write vector is empty. So here we will write cout again I forgot to put over here. Okay, vector is not empty. And in else condition we'll write vector is empty. So in this question, first of all we have added some elements inside a vector, then we have used v dot size function, then v dot capacity function, then max size function. After that we have resized the vector and then check it for the size of it. After that we use v dot empty function. So now let's try to run this code. Okay, I think we have done something wrong. We haven't put the brackets over here. Okay, now let's try again. Here it is. Vector size is 10 because we have put 1 to 10. Then capacity of vector is 16. Okay, then max size of vector is this. Then vector size after resizing, because we have wrote the number 5 as we can see, so that is why vector size after resizing is 5. And vector is not empty, as we know, because inside the vector there are 5 elements, so it is not empty, which is true. So these were some examples of vectors in C++. You can try some more examples on it, you can practice some more examples. And in today's session, we will learn about C++ STL. In this session, we will learn about what is STL, then we will understand the components of STL like containers, iterators, algorithms, and function objects. So without further delay, let's get started. STL stands for Standard Template Library. It is a set of template classes that provide us data structures and algorithms or containers. It allows the programmer to use predefined functions, which helps them to write the code quickly and in an efficient way. For example, you are solving a problem that needs sorting. Now, instead of writing the code to sort, you can make use of STL. Now, STL mainly consists of 4 components, that is containers, iterators, algorithms, and function objects. So first is containers. These are collection of objects that store data of similar type. In STL, we have different types of containers. Some of them are array, vector, set, map, and these containers are generic in nature. So further, these containers are of 3 types, that is sequence container, associative container, and container adapters. Sequence containers, these are those containers that can be accessed sequentially. For example, vector, dequeue, list are some of the containers that store data in a linear form. Next is associative container. These are those containers that implement sorted data structures. In this, elements are retrieved via keys, and each associative container maintain its keys in sorted order. Example, set, multiset, map, and multimap. After that, container adapters. These containers are like sequential containers, but they are implemented by modifying their interface to provide the desired behavior. For example, stack queue and priority queue are some examples of container adapters. Now coming to iterators. In STL, iterator plays an important role as it links algorithms and containers. Iterators are those entities that helps in traversing through containers. They are used to point at the memory address of the STL containers. Iterators also helps in traversal from one element to the next element in the range using operators like increment operator. Iterator contains 2 functions, that is begin function and end function. The begin function returns the iterator to the first element, and the end function returns the iterator to the last element. Now coming to algorithms. Algorithms in STL can be defined as procedures that are applied to the containers and provide some operations on the content of the container. And because STL algorithms are built in, so that is why they save considerable amount of time. In algorithms, we just have to make a function call and we don't have to write the lines of code to implement it. Now let's have a look at types of algorithms. First is modifying algorithm, non-modifying algorithm, sorting algorithm, searching algorithm, and numeric algorithm. Modifying algorithms are those algorithms that make changes to the sequences. Swap and reverse functions are some examples of it. Then non-modifying algorithm. Non-modifying algorithm are basically read-only functions. They do not modify the data on which they work on. Some examples are count, equal, and search functions. Then sorting algorithms. This algorithm is used to sort the container elements. Its example is sort function. Next is searching algorithm. As the name suggests, this algorithm searches for the element. Binary search algorithm is mostly used search algorithm. Last is numeric algorithm. This algorithm works on numeric values, or we can say it solves some numeric problems. Examples are accumulate function and partial sum functions. Now coming to function objects. Function objects are also known as functors. A function object is an object of template class that implements call operator. This call operator allows the object to be used with same syntax as regular function call. For example, suppose you have declared an object obj of a class in which operator is defined. Then you can use the object obj just like a normal function. Function objects also helps in generating the data, and it also helps in testing purposes. Now, in order to do some examples, let's move to our code editor, that is VS Code. So here we will do an example of vector container. So let's make a new file. And let's name it STIL.CPP. Now we'll add the header files. Now writing namespace standard. Now we will add, before namespace standard, we have to add the header file for vectors, because we are doing the example of vector, so that is why we have to add the header file of vector. Okay, now we'll write int main. Now first of all we'll declare the vector. So we'll write vector int within the angle brackets. Now we will write the name of the vector, that is v. Okay, now we have to push some elements inside the vector. For that we have to use for loop. So we'll write for keyword int I equals, let's say 1, I less than equals 10, I plus plus, that is increment operator. Okay, now we have to push the elements one by one, so we'll write v dot push back, and inside the bracket we'll put I. So the elements will keep on adding one by one at the end of the vector. So now we will check the size of the vector. So we'll write the message size and then the function v dot size. It will tell us the size of the vector, that is the number of elements inside it. As we can see that we have put 10 elements inside the vector one by one, so it must be 10. So in order to check it, we have used this function v dot size. Okay, now we'll use another function, that is v dot resize. It will resize the size of the vector. So whatever we put inside this bracket, like let's say I've put 7, so its size now would be 7. And we need to check this also. So we'll again use the function size. So first of all we'll display the message. After resizing, it becomes v dot size. It will print the size of the vector after resizing. Okay, now we use another function v dot empty. For that we have to use if condition. So we'll write v dot empty brackets. We know that if v dot empty equals true, then it means it is empty, and if it equals false, then it means it is not empty. So we'll simply display the message that it is not empty. We'll write cout, and now we'll write with /n not empty. We forgot to write the commas over here. Okay, now in else we will write it is empty. It is empty. We can also do this the other way around, like we can put v.empty equals to true, and then inside that bracket we can write it is empty, but it's your choice. Okay, now we'll display the elements of the vector. For that we have to first write the message. So we'll write elements of vector. Then after this, using for loop and iterator, we will print those elements. So let's do this. We'll write for, and inside for loop we'll write auto it. Here the auto keyword specifies the type of variable that is being declared will be automatically deducted from the initializer, and it is the iterator. Now we'll write it equals v.begin, and we know that v.begin function will point to the first element of the vector. So after that we'll write it not equal to v.end, and it will point to the last element of the vector. Now we'll write it++. Now we'll print the iterator using dereference operator, and in order to make some space we'll write this. Now return 0. Okay, now let's try to run this. Okay, here is the problem, I think. Now let's try one another time. Here it is, size 10. After that, after resizing, it becomes 7. Firstly, we add the elements by pushing one by one using the pushback function. 10 elements were added, so size is 10. After that we have resized it, so after resizing it becomes 7, and then we have used the function empty. So it was not empty, so that is why the message displays not empty. Then the elements of vector, I forgot to put space over here, and elements of vector 1 2 3 4 5 6 7, and that is correct. Okay, now we'll do one example of iterator. In this example we'll simply print the elements of a vector using iterator. So first of all, let's name this STIL.C. Now we'll write the header files, hash include iostream. In this we'll add 3 header files. Now we'll write hash include iterator, because we have to use iterator, so that is why we are doing this. And we also have to use the vectors, so we'll write hash include vector. Now we'll write namespace standard. Now we'll start with int main. So first of all, we'll declare a vector in which there are some elements. As in previous question, we already learned how to add elements in a vector. So in this question, we'll simply declare those elements inside a vector. So we'll write vector int inside the angle brackets. Now let's say AR is the name of this vector. Now we'll write the elements. Five elements are there. Now we have to declare iterator to a vector. So this is how we'll do it. We'll write vector, then the data type inside the angle brackets. Then after this we'll write the scope resolution operator like this. Now iterator keyword, then the name of the iterator, that is ptr. Now we'll display the vector elements using for loop and using the functions begin and end. So we'll write, first of all we have to display a message. Okay, we'll write the elements of vector are. Okay, now semicolon. Now using for loop we'll write the ptr, that is the iterator, ar dot begin. As we know that ar is the name of the vector. ar dot begin function will point to the first element of the vector. Then ptr less than ar dot end. We know end function will point to the last element of the vector. Okay, now we'll write ptr plus plus. Now we have to display it, and we'll display it using the reference operator and the name of iterator, that is ptr. We'll make some space. Now at last we'll write return 0. Now let's try to run this. The elements of vector are, as you can see, the elements of vector are 1 2 3 4 5. So this is how you can print the elements of a vector using the iterator. Here is the vector, and with the help of iterator we have printed these elements 1 2 3 4 5. Now we'll do one simple example of algorithm. First of all, let's name this STIL.C. Now in this example we'll use swap algorithm to swap two integers, and we know that swap is a template function. So let's do this. First of all we'll write hash include iostream. Now using namespace standard, we'll start with int main. Now first of all we declare a variable, let's say 7, and second variable, let's say 10. First of all we'll display the value of these variables, that before swapping and after swapping. So that is where we'll write value of I. Now here we'll write value of j. And L. Okay, now we'll use the swap algorithm, and here we'll mention the elements we want to swap, I, j. will simply swap the contents of these two elements. Now we'll write after swapping. And we'll do same for J. This is a very basic example, but we have to see the functionality of it. We'll write and okay. Now we'll write return 0. Now we'll run this. Yeah, value of I 7, value of j is 10. After swapping I 10 j 7, it will look better if we have wrote like this. Let's make it look good. Yeah, value of I is 7, value of j is 10. After swapping, I becomes 10 and j becomes 7. So this is how we can swap the elements using swap algorithm. There are some more algorithms, you can try those as well. And now at last we'll do one example of function object. Let's name this as STIL4.cpp. Alright, now we'll add the header file. Hash include iostream. Now we'll write namespace standard. Now in this question, first of all, we'll start with the function. So first of all, we'll make a class function obj. Now we'll write access specifier public int. Here we'll write the call operator. As we know the syntax, operator bracket, then another bracket for the arguments, int x comma int y. So this is the syntax of it. And now whatever we want to do with these two variables, let's say we want to multiply, so we'll write return x into y. Alright, as this is a class, so we have to write the semicolon. Now we'll write int main. Okay, now we'll write int main. After int main, here we will write the name of the class, because we have to define the object of it. Now the object is fo. So here class name is function obj and its object is fo, and as I have explained earlier, here I can use fo object like a normal function because fo is the object of class function obj in which call operator is defined, so it will act like a normal function. So now we'll make a variable, let's say multiply, so we'll write mult equals fo, and because it acts like a normal function, so we'll pass the parameters 4 and 7. Now in order to display, we'll write cout and we'll write multiplication of x and y is, now we'll write the name of the variable mult, because the result is getting stored in mult variable. Now we'll write return 0. Now let's try to run this. Here we can see multiplication of x and y is 28, and that is true. 4 into 7 equals 28. So it is working, and this is the example of functor or function object. So these were some basic examples of components of STL. You can practice some more examples on them in order to learn. In this video, we will learn about C++ enumeration. So let's go ahead and have a look at what we'll be covering today. First is why enumerations are used in C++. Then we'll understand what is enumeration and its syntax, and after that we will learn how to use enums with flags. First is why enums are used in C++. Enums are short for enumerations. These are basically used when we have some set of possible values and we have to select one out of it. For example, suppose you are the shop owner and you have 4 types of coffee in your coffee machine. That is cold coffee, hot coffee, black coffee and mocha. And you don't want the trouble of customer putting any other coffee name in the machine which is not there. Then in situations like these, enumerations are used. Because in enumerations we have to choose from predefined values, and it is also helpful for documentation and readability purpose. Now let's understand what is enumeration. Enum or enumeration is a user-defined data type in which a set of values are specified for the variable, and the variable can take out any value from the set of values. And it is also a way to use integers to represent values. We can assign values to enum, but if we do not assign any value, then the compiler assigns value to them starting from 0. Coming to its syntax, which is enum, that is the keyword for enumerated type, then enumerated type name is written, then under brackets possible values of type enum are written. For example, here enumeration name is player and values are Ronaldo, Salah, Messi, Neymar, which are the names of players. In this example, by default Ronaldo is 0, Salah is 1, Messi is 2 and Neymar is 3. Because we know by default compiler assigns them value which start from 0 and so on. But we can change these default values by assigning values to them. Like here Ronaldo's value is now 4, Salah's value is 2, Messi's value is 8, Neymar's value is 1. Now let's have a look at an example in which we will print the default value of months. So in this example we have enum name as months and enumerated values as January, February, March and so on. And in order to access these values we have written enumeration name and after that the variable. As we can see inside main function, m is the variable and its type is months. Now here we have assigned the month March to the variable m, and then we are printing the variable m plus 1. Here plus 1 will print the value next to the month March, that is 3, and similarly if we write plus 2 then it will print the one next to it, that is 4. These values are default integer values. After printing the output, value is 3 because we have printed m plus 1 where m is 2 and plus 1 makes it 3. Now let's understand how to use enum with flags. In this example we will choose a mobile having any of the 2 features among 3. Here the name of enumeration is mobile and its enumerated values are battery capacity, camera quality, large storage, and we have assigned values to them 1, 2 and 4 respectively. And because we are doing this example of enums with flags, that is why we are using integer values of power 2 because it avoids the overlapping. Inside the main function we are using bitwise OR operator because we want to choose the mobile having both camera quality and large storage capacity. And we know that bitwise operator adds the binary of 2 integers. So the value of camera quality is 2 and value of large storage is 4. When we use a bitwise OR operator in between these 2 features, so it will add up their binary giving the decimal number as 6. So the output 6 is showing both the camera quality and large storage are used. Now let's do some examples of enumeration in our code editor, that is VS Code. Okay, now let's make a new file. and name the file as enum.cpp. In this example, the enumeration name will be captain and the enumerated values will be the team members, out of which we will select one member as captain. And with if condition, we will verify if he is the selected captain or not. It will be a basic example. So first of all, let's write hash include iostream. Now we'll add the namespace standard. Okay, now we'll write enumeration enum captain, which is the name of the enumeration type, and now we will write the enumerated values, which is let's say Avi, Sid, Robbie, Sammy and Jake. These are the team members. Now we'll write int main. Now here we will first of all write captain, which is the name of the enumerated type. Then we'll make the variable out of it, cap, and let's say Avi is the captain, so we'll write Avi. Now here we will write if condition. We'll write if cap equal to Avi, then we'll display our captain is Avi and its value is whatever the value. Avi's value here is 0, so we'll display that. So we'll write our captain is Avi and its value is, then we'll write Avi. As we know that Avi is at first position, then its value would be, default value would be 0. Okay, so here we will write end L. Now in else, here if we put Sid, Robbie, Sammy, Jake as captain, or if we declare them as captain, then this message would be declared, which we will be writing in else. So the message would be he is not our captain. Then over here we will write return 0. Okay, now let's try to run this. Our captain is Avi and its value is 0, because here captain we have declared Avi, so that is why this is printing. If we write, let's say, Sammy over here, then it will print the else part. He is not our captain. And if we write Jake or Sid, then also it will print the same. He is not our captain. Only in case of Avi, it will print our captain is Avi and its value is Avi's value. So this was the basic example of enumeration. Now let's move on to another example. Now let's make a new file and name it as enum2.cpp. Okay, now we will add the header files hash include iostream and using namespace standard. So here we will do an example in which enumeration name will be supercars, and to the values we will assign some integers to them. which will be the speed of those cars, and then we will compare them using comparison operator in terms of speed. So we will write enum, the name of enumeration, that is, let's say, supercars. Okay, now inside the bracket we'll write the name of the cars, which are the values, and we will assign some integers. These integers are actually speed of these cars. $268, then Valkyrie, speed is 240. Now Roadster 250. Okay, now as we have created the enum, now we will start with int main. So we will write the enumerated type name supercars. Now the variable speed 1, because we want to create two variables in order to compare them. So first we will create speed 1. Now again speed 2. Now we will assign the two cars that we want to compare to these variables. So speed 1 will be Valkyrie, and speed 2 would be Roadster. Okay, now we will write the if condition, and inside the if condition we will compare the speed of these two cars. So we will write speed 1. If speed 1 is less than speed 2, okay, then we will print that it's a win for Roadster, because speed 2 is Roadster and speed 1 is Valkyrie. So we'll write it's a win for Roadster. With the speed, we'll also write the speed with the speed of this speed 2 will display the speed of Roadster, that is 250. Okay, now else condition. So here we will write it's a win for Valkyrie. With the speed of, here we will write speed 1. Okay, now we have to write int main, but before that we will write the bracket which we forgot to mention, return 0. Okay, I think it's done. Now let's try to run this. Here we can see it's a win for Roadster with the speed of 250. As we know that the speed of Roadster here is 250 and the Valkyrie speed is 240. So when we compare it, speed 2, that is Roadster, wins because Roadster is 250. So this was the second example. Now let's do one last example. Let's name this. Okay. enum3.cpp. We'll write hash include iostream. Now namespace standard. Now in this example we will see how to use switch statement with the enumeration. Okay, so first of all, inside int main we will write enum. Color is the name of the enumeration type. Then we'll write the values red, blue, green and yellow. These are the values. Now here we will use switch statement, but before doing that we have to assign one color to a variable. So first of all we have to create that variable, and in order to create the variable we will write the enumeration type name color and then the variable name select. Now we will assign one color from the above colors, let's say yellow. Now in switch statement we will write, first of all we will write switch statement switch, and we will pass here the variable that is select. Basically we are passing yellow because yellow is assigned to the variable select, and that is why it is getting passed. So now case 1, that is case red. First of all we'll write the case red with a colon in the end. Now we will print that it is red. Now we'll write the break statement. Break statement basically ends the case or terminates the case. So after that the second case, that is case blue, colon. Now here we will print it is blue, and similarly break statement. We'll do same for all of these colors, green and yellow also. And switch statement will help us to find which color is passed and will display the message of that color. So here we will write green, it is green, break statement. Now case yellow, now we'll write it is yellow. Now here we'll write break. Okay, now at last we have to write return 0. Now as we know that we have passed a particular color to the variable select, and select is the expression, and switch statement will help us in comparing the variable select value to the value of different blocks, and one which matches that particular block will execute. Okay, now let's try to run this one. Here we can see it is yellow is being printed, which is the right answer, because we have passed the color yellow to the select, and that is why only the case yellow output is being printed. So This is how you can use switch statement with enumeration. So these were some basic examples of C++ enumeration. You can try some more examples on it in order to practice it. In this session, we are going to learn about C++ GUI, that is Graphical User Interface, and how to configure Visual Studio and make a GUI application. So without further ado, let's get started. To develop C++ GUI or C++ Graphical User Interface apps, we must have an IDE that supports C++ GUI applications, and Visual Studio is one of the best IDE for that. Here IDE stands for Integrated Development Environment. There are many versions of Visual Studio for GUI apps, but I suggest you to download Visual Studio 2019. There are 3 editions of Visual Studio 2019, that is Community, Professional and Enterprise. We can download the Community edition. Once the Visual Studio is downloaded and installed, then you need to launch this application. After that, you can select the color theme and change the development settings to Visual C++. Then the Visual Studio will look like this. Then here we will click on this Create a New Project. And now we have to search for a project template named CLR empty project.NET framework. So we'll type CLR empty project.NET framework. Here it is. Make sure that there is .NET framework over here. Now all we have to do is to click on this and select next. Now here we can name our project. Let's say I have named it project 2, and we can select the location, and now we can click on this create button. Now our project is being created. So here it is. So now let's create a form file by going to the project, then add item, add new item. Now here Visual C++. Under Visual C++, we'll click on UI and then Windows Form. We'll click on this Windows Form and click on this Add button. So our file is loading. So it will show you this error, but you don't need to worry about this one. You can simply close it. Now we will go to Project, then into Properties. Then now we'll click on this linker, open this linker. Now we'll go to this system. Then inside this subsystem over here, we'll select Windows. Here it is. Now after doing this, then we go to Advanced, and in Advanced we can change this entry point to main. We'll write main main. This main is the starting function. Now we can press OK over here. Now you need to open this myform.cpp. Here it is. And you have to copy this code and just paste it over here. We will add this code in the description. You can take this code from there and add it. Now make sure to write your project name over here. Like my project name is project 2, so I'll write project 2. Yes. So after doing this, we can save it by pressing Ctrl and S, and now we can go to myform.h. Here we can see there is no form, so we need to save it and close this Visual Studio once. Now we need to open the Visual Studio again. We'll go over here, we'll write Visual Studio 2019, here it is. We'll click on this and this is launching. We can click on this project 2. Now let's go to myform.h. We'll click on this. It is getting loaded. Here we can see the form. Earlier we were only able to see the code, but now we can see this form. Now we can check this by running it by clicking on this local Windows debugger button. We'll click on that and let's see if it is running or not. It will take some time. So here it is running properly. As you can see, this is my form and this is ready to use. So the debugging is going on. So if we have to close the debugging or stop the debugging, we can click on this cross button. So the debugging is closed now and we have verified that the form is running correctly. We can also add some buttons and labels to this form like this. We can click on this toolbox, then we can select this button and we can click this over here. So this is our button and we can select some more labels. Alright, we can click on this toolbox again and select another button like this over here, and now we can select a label, let's say, and click over here, and we can also adjust the size of these buttons like this, and like this we can adjust the size, and this is the label. We have to adjust its size by setting its format. We can do it by clicking on this label and going to properties. Over here we can see, as you have clicked on the label, so we can see the text, that is label 1. Here we can see text label 1. So it is this text which is written. We can change this one by clicking on this. We can select hello there. We can write like this and it will be shown over this side. Now we must click the label first, then only we can access the button or label. So now let's say this is the font, so we can click on this font and adjust this. Here it is. Let's say I have adjusted it to 18 size and made it bold. Now we can click this OK over this side. So here we can see hello there, it is bold now. Similarly we can do this for button as well. As we have clicked on this button, as you can see, now I can go to this properties. Now inside this properties there is text, that is button 1. We can see, we can change this, like we can write click here, and we can also adjust its font. Here it is, let's say 12 and bold oblique. We click on this OK, and here it is, click here. We can adjust it over there. And suppose if we want to delete some button or label or something like that, so we can click on this and right click on this side, and here we can see delete. We'll click on this delete and it will be deleted. There are more options in toolbox, like there is text box, list box, list view, picture box, checkbox, etc. We can select as per our choice, and we can adjust its layout or editing by going to the properties column. So now let's make a calculator program. So for that we have to create a calculator layout. So let's just delete all these, delete this one, and we'll delete this one as well. Now we'll go to the toolbox and select a text box. We can search it over here, text box. Here it is. We can click on that and put it over here, Here it is. We have to adjust its formatting. So we'll go to properties and we'll go to font and click on this font. Now let's say adjust it to 22 and make it bold oblique. Yes. Now we'll click on this OK, and we have to create another one. So instead of doing this all, we can copy this one, and to copy this we can go to this side and right click over here, and we can click on this copy, and then we can paste it. Here it is, because we have to enter two numbers, and for that we need to have two text boxes for a calculator. Alright, now in between we can mention the operation or operator whatsoever. For that we have to select the label, and we'll go to toolbox, and here it is, text box, but we have to select label. Alright, label. We'll click on this label and put it over here. Now we have to adjust it. Now here we will write, let's say its font would be 20 and it would be bold oblique. It will look nice. Then click on OK. Now we have to adjust what is written inside it. So we can go to text and click on this label 1. Now we can write operator, but it would be so long, so we can write OP, that means operator. Alright, it gives the idea about the operator. We have to adjust it a bit. Alright, here it is. And okay, now we have to create a buttons for addition, subtraction, multiplication. So we'll go to toolbox, and now we'll search for buttons. We'll click on button and put it over here, and now we'll adjust it by going to properties and going to fonts. Let's adjust it to 22 and make it bold. Now we'll click on OK. And now we have to change the label of it. First of all, let's select its layout like this. It would be big. Now we'll go to properties and we'll go to text, and we'll make an addition sign over here, and now we'll click on this. So here we can see. So now we'll copy this button to create the next 3 buttons. So click on this copy and paste it. We'll do this for the other 2 as well, and we'll change the text by going to properties later onwards. Here it is. So first will be addition, then here let's make it subtraction. We'll go into properties, we'll click on this properties. Now let's make this text as minus. Alright, now we can also change the color of this text. Let's say we can make this color. Here it is, blue in color. Now we'll change this one. We'll go to properties and make this as sign of multiplication, but we'll press X so that it'll look nice. Alright, now this one, we'll go to properties and change this to division sign, and we can change this one as well. It will look nice. Let's make it this similar color to the subtraction. Alright, here it is. Here are 4 buttons: addition, subtraction, multiplication and division. Now we have to display the result as well, so we'll go to toolbox and we'll search for label. We'll click on this label and put it over here. Alright, let's make it like this, and let's put it over this side. It will look nice over here. Properties, now we have to adjust it. Let's make it 22, bold oblique. Okay, here is our result, and let's name it as result as well. We'll go to text. Here it is, label 2 written. We'll write result. Now whatsoever operation is done, its result or output is displayed over this side. Now all we need to do is to add the functionality to these buttons. So let's do that. We'll click on this 2 times on this button, and the button name, actual name of that button is button 1. So here it is. So this part is for button 1, and we know that button 1 is addition. So we need to do addition over here. So let's start. First of all, we'll have to declare a variable int result or output or answer, whatsoever we want. Let's write output. Now to add those, we need the names of those 2 text boxes. So we'll go to format design, and we need these names, both of these text box names. So we'll click on this first, and we'll go to properties. So here it is, text box 1, we can see, and we click on this and properties. This is text box 2, and this is similarly, this is button 1, button 2, button 3, button 4. We can check this by going to properties and by clicking them and going to properties. So this is text box 1 and this is text box 2. So now we know the names. Now all we have to do is to write text box where B is capital. We have to write the exact name. We can check it over here that this is text box. We can check the spelling. This is text box 2, this is label 1, this is button 1, this is button 2. We can check the spellings from there. Now we have to use the arrow operator. We'll write like this. This is the arrow operator. This will give us the access to the members of the object. Alright, so we have to change the text. So we'll write text with T capital. Alright, now we have to add the text box 2. And we'll do it same. We'll write this arrow operator and text. Now this addition which we have written over here is wrong, because we are actually adding the strings. As you can see, when we type any number over here, it is a string, and same goes for this part. So we have to convert it. First we will convert both of these text to integer, and then we will again convert the result into string, because we have to display it over here, and for that we need a string. So then again we have to convert it to the string, and let's do it. So what we gonna do is we'll write system, then the scope resolution operator, convert, again scope resolution inverter operator, to int 16. I must be capital, keep in mind, to int 16. Alright, now here we'll write text box with B capital and then this arrow operator, and we'll write text. Alright, after that sign of addition. Again we'll do the same, system scope resolution operator, convert scope resolution operator to int 16 and text box 2. Here we have to write text box 2, arrow operator, text. Alright, here is the addition part. Now we have to display the result. Now to do that, first check the name of the result. Like this is the result. We'll click on this and go to properties. Its name is label 2. So we have to make the changes into label 2. We'll go to this form H. Now we'll have to change the text, that is we have to change the result that is written into the output. So for that we will write label 2, which is the name, then this arrow operator. After that we'll write text because we have to change it, and then we'll write system scope resolution operator, convert scope resolution operator to string, because we have to display the output into string, as I have already told you. Alright, now over here we have to write output, this output. Okay, so let's check if it is working or not. We'll go to local Windows debugger and click on this. Hope it works. Here it is, my form. So let's try to add, let's say 5 plus 9, and we'll click on this add button, 14, and we know that 5 plus 9 equal to 14, so it is working fine, we can see. And now we have to do this for all the buttons, that is subtraction, multiplication and division. So let's go ahead and do that. Let's first close this debugging. We have stopped the debugging and we'll go to this. Now we have to do that for the next 3 buttons. So alright, now we'll click on this subtraction button 2 times. Here we can see now the code is same for all of these, and so we can copy the code from here, and we have just copied it and we'll paste it, and we'll make the changes in the sign. Like I have used here minus sign for the subtraction, and the rest is good. Yeah. Alright, now we'll do it for the next one, that is multiplication. I'll double click on that, and here it is. We'll copy the code from here and paste it. We'll change the sign, the subtraction, not the multiplication sign. This is the multiplication sign, And now the next one, that is division. Here we go. We'll again select, copy and paste. Let's change the sign of this as well. Okay, as we have done the changes, so let's save it by pressing Ctrl and S, and it is saved. Now let's try to run this. Hope it works. We'll click on this local Windows debugger. It usually takes some time, and here it is. So let's try now. 5 plus 6, let's do this first of all, addition. 11. Now we'll do 20 minus 6, so we'll click on this minus, and 20 minus 6 equals to 14. That's right. And now we'll do 20 into 3, that is 60. We'll click on this multiply sign. 20 into 3, that is 60. It is right. Now let's say 15 and 3, yeah. We'll click on divide, and this is 5. So all of our buttons is working fine. So this is how we can create a calculator in Visual Studio 2019. You can also create this calculator program in your PC. All you need to do is to download Visual Studio 2019 and install it, and you can follow the steps and you can create this calculator application. In this session, we'll make a project in C++. This project will be a hotel management project in which we will have the information of the items or rooms that we have in the hotel and what are the food items ordered by the customer. Also, we have the information that how many rooms are allotted to them. Also, this project will tell us about the sales and the remaining food stocks we have and the total collection of the day. We will make this project in 3 parts. Firstly, we will discuss the first part, in which we will declare some variables and then initialize them. After that, we will enter the quantities of items that we have in the hotel. Then, we'll make a list of items or menu of items and rooms that we have in the hotel. So let's start. Now we'll switch to our code editor, that is dev.c++. So this is our code editor. So here first of all, let's make a new file. We'll click on file, and now we'll create a new file. So now let's start with the project. So first of all, inside the main function, we have to declare some variables. But before that, we will write the header files, that is hash include iostream, and then the namespace standard. Alright, so we have included the header files. Now we'll start with the main function. Inside the main function, we will declare the variable. So first variable that we'll declare would be quant, which stands for quantity. And the second variable would be choice. Now we will declare those variables that store the quantity of food items or rooms. So let's say the variable which will store the quantity of rooms would be q rooms, and we have to initialize it also. Alright, so similarly we have to do it with the food items as well. So let us suppose one of our food item is pasta, so we'll write q pasta, that is quantity pasta. We'll initialize it with 0. Similarly we'll do with the rest of the food items, that is burger, noodles, and shake, and chicken. Here chicken would be, let's say, chicken roll. So these are our food items. So these variables will hold the quantity of these food items. So now we will declare those variables which will hold the value of the number of food items that have been sold. So for example, Q pasta holds the value of number of pastas we had in our hotel, and S pasta will hold the value of number of pastas that have been sold. So let's start. Similarly, we'll write S rooms, that is sold rooms. We have to initialize it with 0 as well, and S pasta. Similarly, S burger, S noodles, S chicken. Alright. Now we will create some more variables that will store the price of the total price of each of these food items or rooms. So let's do that. Let's say int total underscore rooms. This is the variable name. It will store the total price of the rooms. We'll initialize it with 0. Similarly, total pasta equals 0. Total burger Alright, so these variables holds the quantity of food we have, these variables holds the quantity of food we sold, and these variables will hold the price, the total price of each of the food items or rooms. So let's comment it. These holds quantity so that it's easy for you guys. Alright, so here we have declared these variables. Now we will make a list kind of a structure in which we will ask the user to enter the number or quantities of food items or rooms that we have in the hotel. So alright, now let's do this. First of all, we have to display a message, but before that we'll use /n and /t. So /n means the next line and /t will add a horizontal space in the output. So we need that horizontal space. So we'll write quantity of food, let's say items only, quantity of items we have in a hotel. Alright, now we'll write rooms available. So we'll add /n and rooms available. Alright, so after this we'll write cin and take the input of quantity of rooms we have, because here we are asking to enter the number of rooms we have. So we'll write cin q rooms because it holds the quantity of rooms we have. We have initialized it with 0. Similarly, we'll do it for the rest, like quantity of pasta, like this we'll do. Inside the /n, now we'll write the quantity of pasta. cin q pasta. Alright. Now similarly, let's copy paste and save some time. So this first was the pasta, then burger, and then Q burger. Then there was noodles. Q noodles. Similarly, we'll do it for shake. And then here chicken is the chicken roll. So quantity of chicken roll. Q chicken. Alright. So one by one, Q room, the quantity of rooms we have to add, Q pasta, the quantity of pasta we have to add, then quantity of burger we have. Alright, now we have to create a menu to select the pasta, burger, room, all the items. We have to create a menu like that. And for that, let's do this. We'll write C out. Again, we'll use /n, then again /t because we want some horizontal space in that. We'll display a message saying that please select from the given menu options. Alright, so it's a message for the users or the customers, I would say. Now again we'll use /n because I want to add some new lines. So I'll use 2/n. Now first is rooms. Secondly, we'll use only one /n, and here we are creating the menu to select the food items or rooms. So now we'll write pasta, and similarly we'll copy paste. So pasta, then there was burger, then noodles, then there was shake, then there was chicken. Chicken roll. We also have to change the numbering, that this is 1, this is 2, then this is 3. We are doing the numbering because the customer will press the number and then he can order. 5, 6, and now again we'll in 7th position we'll add the details or information regarding the collection and sales. So we'll write press 7 if you want to see the information regarding sales and collection. This option would be used by the owner of the hotel to check the total collection for the day. Alright, now again the 8th number is for if we want to exit. Yeah, so this is done. Now after that we'll display a message saying that please enter your choice. So we'll use /n and write please enter your choice. Now we'll write C in choice. We have already declared this variable. Now based on this choice your order is selected. Like if you press 2, then this pasta would be selected. Like let's say if you want to order noodles, then you have to select 4, and if you want to order chicken roll, then you have to select 6. And if you want to check the total sales and collection of today, that is for a particular day, then you have to click 7 and 8 for the exit. So our first part is done. Now in the second part, we have to add the functionality to the choice part. That is, if a user enters the first number, that is number 1, then rooms is selected, and then he or she have to add the numbers of rooms they want. Similarly for the other food items as well. Like if they want to take 2 burgers or 3 burgers instead of 1, and we only have 1 burger left, then also we have to display a message saying that only so and so burgers are left. So now let's start with it. So now we'll write switch case statements. So when the user will select a particular number, so that particular case would be executed. So now let's do that. We'll write switch, and inside the switch statement we'll write choice. Now the choice can be 1, 2, 3, 4, 5, 6, 7, 8. Alright, so now we have to create 8 cases for that. So case 1 would be, we'll start with it, there's a space between case and 1. Alright, so case 1 would be, first of all, inside the case 1, that is the case when rooms have to be selected. So first of all, we'll display a message saying that enter the number of rooms you want. So let's do that. We use /n. Now enter the number of rooms you want. Alright, now after that the user will enter the number of rooms, that is the quantity of rooms. So now we'll take the quantity in the quantity variable, that is quant variable. So the user will enter the number of rooms, that is the quantity of rooms he or she wants. Now we'll use a if statement, an if statement. Inside this if statement, we'll check, do we actually have that many rooms in our hotel, or do we actually have that many pastas or burgers in our hotel right now. So for that we have to write down a condition, that is q rooms minus s rooms is greater than equal to quant. That is, q rooms is the quantity of rooms that we have, and s rooms the number of rooms that we have sold. So if we minus both of these, that is if we subtract the quantity of room we have minus the rooms we have sold, we'll get the remaining rooms. Now if the remaining rooms is greater than equal to the quantity of rooms that have been ordered by the customer, then we can give the room to them. Otherwise we have to display a message saying that we don't have that many rooms or something like that. So let's do that. So we'll write s rooms, that is the rooms that we have sold. So initially its value is 0. So we have to add the values of quantity that have been entered by the user. So we'll add the quant variable, that is if the user have entered 2 rooms he or she wants, then we'll add those 2 values to this sold rooms. Alright, after adding the quantity to the sold rooms, now we will do the total price of the room or rooms, and for that we have the variable total room. So we'll add this quant into the price of a one room to this total room. So we are simply adding total room plus quant into the price of a single room, that is, let's say 1200 is the price of a single room. If a person orders 2 rooms, then it would be like quant, that is 2 into 1200, 2400 will be added to this total room. This total room is the total price of a room. Alright, now we also have to display a message saying that these many rooms have been allotted to you. So for that, let's display a message. First of all, we'll use /n like 2 times. Now we'll add some horizontal space as well.
Alright, now we'll display this quant variable and we'll write a message that these many rooms have been allotted to you. Let's make it room or rooms. Room or rooms have been allotted to you. So this message will be displayed. Alright, now this is the if block. Now we'll have to make the else block, that if the amount or quantity of room entered by the user is more than the remaining rooms, then we'll display a message saying that only so and so rooms are left in the hotel. So we'll use /n, then again /t. Now we'll write only q rooms minus s rooms. That is, here q rooms minus s room is the remaining rooms, are the remaining rooms. So subtracting both of these variables will give us the remaining rooms. So these were the remaining rooms remaining in hotel. Alright, and let's not add these as there's a single statement. Also we have to use break, so we'll use break statement. Now similarly we have to create case 2. This case was for the room, so whenever a user click on this one, then this case will be executed. So similarly we'll create a case 2. So we'll copy it, now we'll paste it. So I will case 2. So in this case enters the number of rooms you want. We can't write that, so we'll write pasta quantity. So let's do that. We'll write enter pasta quantity. Alright, so in this case the cin would be same, that is quantity variable we have. So now in this case the different thing would be the q rooms. Instead of q rooms we'll use the q pasta, that is the quantity of pasta minus sold pastas. It must be greater than quantity of pasta we have. Then only if block will execute, otherwise similarly as that of this block will display a message. So now the s rooms, instead of s rooms here we'll use s pasta, which is initially 0. So we'll add the quantity of pasta to this variable, that is we'll add the quantity of pasta that is ordered by the customer to this variable. Now total pasta, that is the total price of the pasta. So the number of pastas ordered by the customer into the price of a single pasta. Let's say the price of a single pasta is around 250. So quantity into 250. Now rooms, instead of rooms let's do here pasta is the order. So quant will display the quantity. So it will display, like if you have ordered 2 pastas, it will display 2 pasta is the order. And q rooms, here we have to display the remaining, so we'll do the q pasta minus s pasta. And here we'll do is pasta remaining in hotel or stock, pasta remaining in hotel. So it will display the remaining pasta remained in the hotel now. So else everything is fine. Now similarly we'll do for the next. We'll copy it, it will save some time. and paste it. Now this is case 3. The case 3 is of burger. So here we'll write burger, quantity of burger minus sold burgers. Similarly, S burger. Now the total price of burger. So let's say the price of a burger is around 120, and so the remaining burgers, Q burger minus S burger. The fourth case now, that is the noodles case. So enter noodles quantity. Now case 5. Now case 5 is of shakes. So we'll write enter shakes quantity. Now case 6 we have to create. In the case 6 there was chicken roll. So let's do that. Q chicken minus S chicken. Also we have to change the price of each meal, like chicken roll would be of around 150 and this shake would be 120, noodles 140, let's say. Burger is okay, then pasta is also okay. So we have created 6 cases as of now. So our second part of the program is done. Now we'll start with the third part of the program. So the third part will contain the case 7, case 8 and the default case. That is, if the user enters any other number which is not in the list, that will come under default case. In case 7, we have to display the information of sales and collection. That is, how many money we have collected for the day and the remaining food items, etc. So now let's start with the case 7. So when the user will enter 7, that is case 7, then he want to see the details of the information of sales and collection. So we'll display a message saying that details of sales and collection. Alright, so after this message let's add /n /t/t. Alright, so after this message we have to display the number of rooms we had, the number of rooms we gave for rent, and then the remaining rooms, that is minus the quantity of rooms minus the sold rooms, then the total rooms collection for the day. So similarly we'll do for all the meals like pasta, burger, noodles, etc. So let's do it. So we'll start display. First of all we'll add /n. Now number of rooms we had. We'll display q rooms, that is the quantity of rooms we had. Now similarly number of rooms we gave for rent. Alright, so we'll write s rooms. Now we have to display a message. Similarly we'll write /n remaining rooms. So for that we have to simply subtract q rooms with s rooms, that will give us the remaining rooms. After that, the total price that the room has collected or number of rooms have collected. So we'll write total rooms collection for the day. Now it is stored at total rooms. This variable is storing the total types of rooms. This is the complete information of rooms. Similarly we have to do it for the burger, noodle, pasta, etc. So we can copy, we'll copy this part and we'll do copy and paste. I'll paste, again we'll paste. Now number of rooms we had, instead of this we'll simply write number of pastas we had. Number of pastas, we have to change that. Number of pastas we sold. Yeah, that would be right. Now remaining pastas. There are few minor changes that we have to do. Total pasta collection. Also make sure to change the variables. Total pasta, then q pasta, alright. Now after pasta it was burger. Burgers we have, number of burgers we sold. Alright, so it would be q burger and s burger. Remaining burgers. Total burger collection for the day. Alright, now we'll do same for noodles. Alright, now shakes. Number of shakes we had. Number of shakes we gave. We sold. Remaining shakes. Now there is chicken roll. Number of chicken roll we had. Alright, now the case 8. The case 8 we have used for, this was the case 7, and the case 8 we have used for exit, as you can see here. This is the exit case, and for that we'll simply use the exit statement. The exit statement is used to terminate the program, to shift the control out of the program or exit the program. So here we'll use that. So case 8 would be exit, and inside that we'll use 0. 0 here will mean that 0 millisecond, and now after that we'll have to use the default case, that if the user enters any other number that is not present in the menu list, then this default case will be executed. So in this default case we'll display a message saying that please select from the numbers that are mentioned above. So we'll use /n, please select the numbers mentioned above. So this message will be printed. And also one more thing is there, we have to use a goto statement, and we'll have to label a part with M. Now I'll explain to you that why have we used this jump statement, that is goto statement. So after making a choice, we again want to choose another option. That is, if I have ordered 2 pastas, then I also want to order 2 burgers as well. So we will mark or label menu with M. So this is our menu, please select from the menu options. So here we will label M, and in the last we have used the goto statements. So the goto statement here will transfer the control to the menu after making a choice. So again, M is the label we have used for the menu, and we will use a goto statement to transfer the control to the menu after making the choice, so that we can make more choices. Goto is a jump statement basically, that is used to jump from one part to another part having a specified label. So we have labeled menu with M, and this goto jump statement will help us in jumping to the menu after every choice. Alright, so our code is done. We have done all the things that we need. Now we need to run it, and for that firstly we need to save it. Alright, so let's go to files and save it, and now let's select the destination folder. Let's name it as Management.cpp. Alright, so the program is saved. Now let's try to compile and run this program. So there are some errors I can see. Okay, so we have used the semicolon. Now this will take care of many errors. Now let's try to again compile and run. Let's check Q noodles. Alright, I think
Q noodles. So we have to backspace S. Now let's try to compile and run again. Hope it works now. So quantity of items we have, as we can see. So rooms available, let's say we have 10 rooms. And quantity of pasta, we have 25 pastas in our hotel, and around 50 burgers and 30 noodles and 30 shakes. Chicken roll we have 40. So this is the menu. Please select from the menu options. As we can see, first rooms, then pasta, burger, noodles, shake, chicken roll, information regarding sales and collection, and then 8 to exit. So first of all, let's say I want to order 2 rooms, so I'll click 1. Please enter your choice. I have clicked 1 and I'll press enter. Now enter the number of rooms you want, and let us suppose I want 2 rooms. So as we can see, 2 rooms have been allotted to you. Now again the menu is displayed on the screen. Now let's say I want burgers, so I'll click on 3 and I want 2 burgers, and 2 burgers is the order, it is displayed. Now again I want pasta. Let's say I want 6 pastas, and 6 pasta is the order. I want to order now shakes. Let's have something to drink. I want to order 9 shakes. 9 shakes is the order. And let's say, so as we know that we have only 10 rooms. Now let's try to enter 11. So first of all we'll enter 1, that is rooms. Now let's try to order 11 rooms. As you can see, only 8 rooms available or remaining in hotel. So we forgot to add some space over this part, but we can easily read it now as of now. So it is displaying the message that only 8 rooms are available, because already we have ordered 2. Earlier it was 10, then now only 8 rooms are available. So this is showing that if we order more than the quantity, then it will display this message. Now let's say I want to check the information regarding sales and collection of today's rooms and as well as meals. So I'll simply click on 7. Now as we can see, it will simply display all the sales and collection of rooms and meals. As you can see, number of rooms we had 10, number of rooms we gave for rent 2, remaining rooms are 8. So total rooms collection for the day is 2400, as one room is of 1200. So similarly, number of pastas we had 25, number of pastas we sold 6, remaining pastas we had 19. So the total pasta collection is 1500. So and so the burger, and then noodles, and then shakes and chicken roll. So this is the total chicken roll collection for the day. That is we haven't ordered a single chicken roll. Also we can do one more thing. We can simply display the total result of all the collections of rooms and meals. So let's do that. So to display the total collection of the day, all we need to do is to add all the totals of pastas, burgers and rooms. So for that we have to go to case 7. Now we'll write /n/n/n 3 times. So here we'll write total collection for the day. And after that, total rooms plus total burgers, total pasta plus total burger total chicken. Alright, after this we will use the break statement. Now let's run the program. So here it is, rooms available. Let's write 10. Quantity of pasta 30. Quantity of burger 50. Quantity of noodles 30. Shakes 30. Chicken roll 40. So first of all I'll book 2 rooms. We'll click on 1 and now 2 rooms. And again if I'll click on rooms and then if I try to click 10 rooms, because already we have we sold 2 rooms, then it will display that only 8 rooms remaining in hotel. Now I'll click on 2 to order pasta. Let's say I have ordered 5 pastas and 5 pasta is the order. Now let's say if we click on 9, although we know that only 1 to 8 numbers are available, but if we click on 9, so it will display a message, please select the numbers mentioned above. Alright, now let's say I want to order chicken roll, 10 chicken rolls I want. So 10 chicken roll is the order. Now I want to check information regarding sales and collection for the day. So I click on 7 and then here I can see number of rooms we had, number of rooms we gave for rent, remaining rooms, and total collection for the day. Similarly for the pasta, similarly for the burger, similarly for noodles, shakes and chicken roll as well. And this is the total collection for the day, 5150. Exit. And if we click on it, we can exit. So as we can see, this is our hotel management project and this is how it's done. The code is a bit long, but it's worth it. You can also try this project on your own. In this tutorial, we will make a project in C++. This project will be a login and registration system in C++, in which a user can register, log in, and also if he or she forgets the password, then also it can be recovered. We will make this project using the fundamentals of C++ like switch case statements and file handling operations, etc. But before that, if you are new to our channel, then consider getting subscribed to our YouTube channel as we have daily updates on multiple technologies. So let's go ahead and understand this C++ project of login and registration system. In this project, first of all, we will make a menu page in which there are options like login, registration, forgot password, and exit. Then we'll ask the user to select any one among those options. Once the user has selected a particular option, then we have to continue with the functionality of that. So now let's switch to our code editor and do its practical implementation. So this is our dev C++ code editor, and now let's create a new file. Now first of all, we will include the header files. The hash include iostream, then there is fstream class for file handling operation, hash include fstream, then there is string.h for string, then we will include the namespace standard. Now we will do the forward declaration for 3 functions, that is login function, registration function, and forgot function. And after that, inside the main function, we will make the menu for the login page. So let's start. First of all, we are doing the forward declaration. This is the login function. This is the registration function. And this is the forgot function. Now inside the int main, first of all we'll make a variable C which stands for choice, C for choice. So now we will make the menu page. So let's create, we'll use /t for adding the horizontal space. Now in the end we will use /n. Alright, similarly we'll do here. Welcome to the login page. Now again we'll do the same, /t /t, and now underscores menu /n. Alright, now we will make the options. So we'll do the /t. Now after /t we'll add vertical bar, then we'll write press 1 to login. Let's make it capital. Press 1 to login, and after making some space, then vertical bracket again, then end L. Similarly we'll copy it and do for option 2. Press 2 to register. Alright, let's maintain the symmetry. Press 3 if you forgot your password. Alright, press 4 to exit. Alright, so this is done. Now after that we will ask the user to enter your choice, and for that we'll display a message saying that please enter your choice. But before that we'll use /n and some /t's. Alright, now we'll ask the user please enter your choice. Alright, now we'll take the input of the choice, that is C, that we have already declared.
next line. Now we'll use switch case statements. For example, if the user selects 2 to register first of all, then inside the switch case statement, in case 2, we will call the registration function. And if the user enters 1, then we will call the login function. So let's do that. Let's create a switch statement and see that is choice. Now inside the switch statement, first of all we'll create a case 1. Inside this case there would be login. We are calling this login function, and then there is break statement. Alright, similarly now we will create case 2. So case 2 would be registration. Here we are calling the registration function, and then there is break statement. In case 3 there is forgot function. That is, if the user forgets the password, then this function will be implemented. Now there is a default case. Now there is a case 4. In case 4 there would be a message saying that thank you, because case 4 would be exit. So we'll display a message saying that now we'll also have to make the default case. That is, if the user selects 5, 6 or any other number that is not in the menu, then we will display a message saying that please select from the options given above. So before that we'll add the /t. Please select from the options given above. After that we'll use /n and endl. After that we'll call the main function so that the control goes back to the main function, and we'll also use system.cls, that is clear screen. It means every time the code is processed, it will clear up the screen. Now all we need to do is to create the login function. So we'll write void login, and inside this function first of all we'll create some variables, and so let's do that. Int count user ID. No, this user ID would be of string. We'll write string user ID, then there would be password, then ID, then pass. Alright, so these are the variables that we have created. Now again we'll use the system.cls, that is clear screen. We have to write CLS inside the double quotes. Alright, now we will display a message that please enter the username and password. So we'll do that. and we'll write /t/t/t and please enter the username and password. Alright, now we'll again display a message saying that username. Now we'll take the input. So here user ID is the username that the user will enter. Now again we will display a message saying that password. Let's make it capital. Again we'll take the input. Now as the user has entered the username and password, now we will check that if that username and password already exist in our records. And for that we will use the file handling operation of ifstream class, because ifstream is used to read the data. So we will use ifstream and ifstream class. This will read the data from the file. Input is the object name and the file name would be records.txt. Alright, we'll have to make it inside the double quotes. Alright, so now this if stream will check inside the file that if that login password exists or not. And to check that we will have to use the while loop. Inside the while loop we'll write input, that is the object name, then there would be ID and then pass. So this is the ID and password, and this is how we read in file handling operations. Here what we are doing is we are reading that if that ID and password is there, and then we will match those ID and passwords with the ID and password that is entered by the user. So for that we will have to use the if condition inside the while loop. So let's do that. We will write if ID equals user ID and pass equals password, then count would be 1, and then we will use systemcls to clear the screen. Here we have assigned 1 to count because in the next part we will use an if condition that if the count is 1, then we will display a message saying that your login is successful, that is the password or username entered by the user matches with the record, that is the user has already registered. So now before that we have to close this file. So let's do that. To close this file we will use the object name, that is input.close. This is how we can close the file. Alright, now we'll use the if condition, and inside this if condition, as I've said, if count equals 1, alright, if count equals 1, then we will first of all display the user ID, that is the username, and then we will display a message that your login is successful. So let's do that. Your login is successful. Now thanks for logging in. Now again we will shift the control to the main, because there is the main menu, and now inside the else block we will display a message, that is, if the user and password is not found inside the file, then it means that the user is not registered, so he can't log in, he has to register first. So we'll display a message saying that login error. Please check your username. Now again main function. Now we have to create another function, that is the registration function. That is, if the user press 2, then this registration function would be called. So let's create this function. Void registration. Now inside this function we will first of all create some variables, then after that we'll ask the user to enter the username and password, pretty much the same as that of the previous function. So first of all, string R for registration user ID, R user ID, then R password, then R ID and R pass. System CLS again, clear screen. Alright, now we will display a message saying that enter the username. Again enter the password. R password. Alright, so in the previous function we have used ifstream class, but in this function we will use offstream class because we want to write inside the file, and offstream helps us with that. So for that we will use offstream, and the object name would be f1, and records is a file, and we will use the app mode. This iOS means the input output stream, and app will open the file and append the output in the end. So this is our app mode. There are different modes, so here we are using this app mode. So after this we'll put the semicolon in the end. Now we have to write inside the file, so we'll do the f1, and this is how we write inside the file. F1 here is the object name, and our user ID is the username, and after that we'll add some space, and then our password, that is the password. We want some space between the username and password, that is why we have used the single quotes,
and this is how we write inside the file. And after that we'll again use the systemcls, that is the clear screen. Alright, now we'll display a message that registration is successful, as we have already written inside the file. So now we can display this message saying that registration is successful. Now again control back to the main function. So now we will create the forgot function. This is the last function, void forgot. So this function would be called when the user forgets the password or username. So first of all we will create a variable option. Now we will ask the user that you forgot your password, no worries. Then we'll ask the user to press 1 to search your ID by your username, and press 2 to go back to the main menu. So let's start. Before that we will use systemcls. Alright, now we'll display the message saying that you forget the password, no worries, and then we'll use /n. Now press 1 to search your ID by username. Alright, now press 2 to go back to the main menu. Alright, now after that we'll use /t. Alright, now enter your choice. Now we'll take the input cin option. After that, using the switch case statement, option. Now inside the switch case we'll create cases. So case 1, that is when the user selects option 1, then int, we'll use bracket over here because there would be multiple lines. Alright, now int count, we'll initialize it with 0. Now some more variables we will declare. The string s user ID and sid, then s pass. So these are some string variables and count is the integer variable. After that we'll display a message that enter the username which you remembered. So let's do it. Enter the username you remembered. Alright, now we will take the input from the user as user ID. So once the user entered the username, then we will check that if that username exists in the file using the ifstream object. As we know, ifstream is used when we want to read from the file or check from the file. So we'll create the ifstream class and the object name would be f2 and records.txt is the file. Alright, now using the while loop we will check that if the username is there inside the file or not. So sid and spass. So now if sid equals s user id, then count equals 1. So we will assign 1 to count, and after that we will close the file, that is f2.close. So here what we are doing is we are checking inside the file using the ifstream object that if that id or password is there, and if that id is there, then we'll assign 1 to the count as initially it was 0, and then again we'll do the same as that we have in the as we have done in the previous function, that if count equals to 1, then we will print a message that your count is found. So let's do that. So as we have closed the file, now after that we'll use an if statement with a condition that if count equals 1, then we will print a message saying that your account is found. Your password is spass. So it will display the password. Again the control will be shifted to the main, where there is the main menu, and inside the else block now, inside the else block will display a message saying that sorry, your account is not found. Sorry, your account is not found. So as the case 1 ends, we will use the break statement. Now we will create case 2. In case 2, as we have said that it will simply call the go back to the main menu, so all we'll do is call the main function so that the control will go back to the main menu. And now also we have to create the default case. In the default case, we'll simply print a message saying that wrong choice, please try again. So we'll use /t/t/t wrong choice, please try again. After that we'll call the forgot function so that the user can try again with the correct option. Alright, so we forgot to save this, so let's name it as register.cpp. and save it. Now let's try to run this. Go to execute and compile and run. There is some error. Alright, so I must be capital as we have declared. Let's try again. So as you can see, welcome to login page. This is the menu, and this is press 1 to login, press 2 to register, press 3 if you forgot your password, press 4 to exit. So now we will enter our choice. First of all, we need to register. So we'll write 2 and our username as sam@email. This is our username, and now our password. Sam123 is our password. So as we can see, the message registration is successful. After that, we will log in. As we have registered, now we'll try to log in. Sam@email is our username, and Sam123 are our password. So as you can see, your login is successful. Thanks for logging in. Now let's say I forgot my password. So I'll press 3, as if you forgot your password, you have to press 3. So there's a message, you forgot the password. No worries, please press 1 to search your ID by your username. So I'll press 1. Now I'll write my username, the last username I remembered, sam@email. So your account is found. Your password is this, as you can see. So let's say again, if I forgot the password and by chance I write sammy@email, then sorry, your account is not found is displayed, as sam@email is the registered customer and not sammy@email. So it will display this message that sorry, your account is not found. And let's say again, if we try to press, let's say 5, then we can see that please select from the options given above. Actually we have to make it below, options given below, but we can do that, else everything is working fine. So now we will click on exit, that is 4, and this is the message, thank you. So as we can see, this is our registration and login system in C++, and this is how we can do it. We have created these 3 functions, that is login function, then there is registration function, after that there is a forgot function if we forgot the password, and the code is pretty easy and not that much long, so you can try this code on your own.
Hey guys, welcome to another tutorial by Simplilearn. I hope you all are doing well. So in this session, we will learn how to create a supermarket billing project in C++. We will create this project in small parts, as there are various functions that we will be creating for this project, like the add function to add the goods and products in the market, and delete function to delete some products, etc. Also, we will create a buyer site where the buyer can buy the products or food items of his choice. So now let's go ahead, but before that, make sure to subscribe to our channel and press the bell icon to never miss an update from Simplilearn. Now we will move to our code editor, that is dev.c++. So now let's create a new file, and we'll start with adding the header files. First of all, we'll add #include iostream. Then we'll include the fstream file. Right, #include fstream, because here we have to do the file handling operations as well. So we'll add the fstream file. Now we'll write the namespace standard. Now let's save this one and name it billing1.cpp. Alright, so we have named this file. Now first of all, we'll create a class and we will declare some variables and functions. So let's create a class and name the class as shopping. Inside the class shopping, first of all, inside the private scope, we will create or declare some variables, p code, then float type price, then another variable discount of float type, then name, which should be string. Alright, let's name it pname. P stands for product. Alright, now inside the public scope we will declare the functions. So let's name this function as menu, because we have to create the menu. Then administrator function, alright, now let's create a buyer function, a buyer or customer whatsoever. Alright, now let's create add function, then the edit function. These definitions of these functions we will create later. First of all, here we are declaring these functions. After that, we have to remove some products. For that, we will create remove function, and then the list function to display the list, and at last receipt function. Alright, so here we have declared the functions and the variables. So now we'll put semicolon in the end of the class, and we'll start with the first function, that is the menu function. So we'll write void class name, then the scope resolution operator, and menu function. So now inside this function, first of all, we will create a variable, that is choice, and some more variables, like let's say email and password, because here we will need email as well as password for the login purpose. So now we have to create this menu, and for that we have to first of all display supermarket main menu, and after that we will display that administrator, buyer, etc. and all that. So now let's start with that. For that we have to display, and you can display in your own style, like I usually do like this, /t, to add some horizontal space. It's just for formatting, and after that same will do. To save some time, let's just copy and just paste it. And but now here we will write supermarket main menu. Reduce some space. Alright, now similarly we'll do here. Now let's just copy and paste this part. Alright, now again some space. Alright, now we'll create a menu in which the user have to select, the customer have to select whether he is an administrator or a buyer. So let's do that, and for that we'll write cout /t/t/t to add some horizontal space. And alright, now administrator, now similarly here we'll add some space over here. Just remove this one. In number 2 we'll write buyer, the person who wants to buy stuff from the market. Alright, now let's format it. We'll add some space over here. Now in number 3 we'll write exit. Alright, it's pretty much done. After that, again, if we want to add some space, we can add some. It's just for formatting purposes, you can do it in your own way. And after that, we have to display a message saying that please select. So we'll display a message. Forgot to use semicolon. Now we'll take an input from the user that whatsoever he wants to click on, like if he is an administrator, he will click on 1. If he is a buyer, then he'll click on 2. And if he wants to exit, he can click on 3. So we will take an input of choice. Now we have to use switch case, and let's create that switch, and inside this we'll write choice. We all know how switch case works. Alright, now for case 1, that is administrator case, we will ask the user to enter the login credentials if he or she is an administrator. So let's just do that. So first of all, we'll display a message saying that please log in. So /t/t. Enter email, and then we'll take the input of email. We already declared this variable email, and now we'll take the password from the user. Now we'll take the input of the password. So as we have taken the email and password from the user, now we will set an email and password that only admin knows and no other person can enter that. And let's say for that we have to use if-else statements. So if email equals, now let's set the email first of all, robbie@email.com. You can write the email and password as of your choice, and I'll set the password now as Robbie@123. Now inside the if block, if the user enters this, that means it is the administrator, and we will call this administrator function. Alright, now in the else block, we'll simply display a message saying that invalid username password, invalid username, invalid email password. Alright, after that we'll use the break to end the case. Now we will create case 2. Case 2 is for the buyer, so we'll write case 2, and in this case we'll simply call the buyer function. So this is the case 2, and now we have to create the case 3. Inside the case 3 is for exit, so we'll do exit 0. It means successful termination of the program. Now default case. So inside the default case, we'll simply display a message saying that please select from the given options. Default case will execute if a person selects any other option rather than 1, 2, 3. So we'll have to instruct him that please select from the given option. Select from the given options. Now after this we'll use a goto statement after the switch statement. So goto is a jump statement, so it will help us in jumping to the main menu again after the completion of this switch case. And this M is a label. We have to put this label at the starting of this menu. So let's do that. We'll write M. Now coming back to the next function. So this function is done. So we'll close this function. Alright, so now we will create an administrator function in which there will be different options inside the administrator menu. So now let's start with that. So we will write void shopping, that is the class name, scope resolution operator, administrator. So our function name is administrator. So inside this function, first of all we will declare a variable choice. Now after that we will create a menu in which there will be different options. So let's do that. First of all we'll write /n, then /t, some horizontal spaces, so that administrator menu. Alright, after that here will be our first option. So first of all we'll write /n, then /t's. Just to make it a bit fancy, we can do this. Add the product. So the user can select this option if he wants to add the product, not user, the administrator. Now we will add some space in this one. Now again same, we'll copy it from here, then paste it. So here we will change it to the modify the product, and we have to adjust it as well. Alright, now again we'll add some space. We can copy this one. Now here will be write delete the product. Now here again three and make this 4. 4 will be of back to main menu. Alright. Now after that we will ask the user to please enter your choice. So we'll display a message saying that please enter your choice. Alright. Now the user will enter the choice. Now again we have to use the switch case statements. Inside this first case, first of all we'll make, and inside this first case we will call the add function. After that we'll use break statement. Now we'll create case 2. In case 2 we will call the modify function or the edit function. So we'll write edit, and again the break. Now we'll create case 3. In case 3 there will be delete function. So we'll name this function as remove. REM stands for remove. Now case 4 would be back to main menu. So for that we'll simply call the menu function. Now after case 4 there would be default case. So we'll write default and we'll print a message saying that invalid choice. Alright, so after the switch case statement, again as we have done in the previous function, we will mark M with a go to statement, which is a jump statement, and label it over here. Alright, so administrator function is done. After this function, now we will create another function, let's say buyer function. So for that, void shopping scope resolution operator buyer. Alright, so inside this buyer function, first of all we'll declare the variables in choice. Now inside this function we'll ask the user that he or she wants to buy the product or go back. So let's create that. First of all here we'll write buy the product. No, first of all we'll write buyer. Yeah. After that
let's give some space. Now First would be by product. Now again we'll add some space. Let's copy it and paste it over here. And alright, slash n. Okay, again now we will, in the second option we'll write go back. So the second option is go back. And over here we'll add some space or a line.
Alright, so these were some options. After that, we will ask the user to enter your choice. Then the user will enter his choice. So we are taking the input. After that, we'll use the switch statement and choice. So inside the switch statement, first of all, we'll create case 1. Inside this case, we will call the receipt function. Inside the receipt function, all the operations of the buyer will take place. So this is the receipt function, and after that we'll use break. Now we'll create case 2. In case 2 we'll write or call the menu function, as 2 would be go back, as we can see. Now default case. We'll write invalid choice. Now after this again we'll use the go to jump statement and mark here M. Alright, so after this function, now we will create the add function. So as we know, if the user over here, the administrator over here, will click on this add the product, that is the first case, then this add function will be called. So now we will create this add function. So we'll write void shopping add. So inside this function we will use some file handling operations. So create an object of fstream class. So data is the name of the object. Now we'll create some variables like int c, int token equals 0, and float p, float d, and string n. So these are the variables that we have declared. Now we have to create a menu kind of a structure in which we will ask the user to enter the product code of product, the name of the product, price, discount, etc. So let's do that. So let's write add new product. Alright, after that we will write the product code of product. We'll ask the user to enter the product code of the product. So we'll write /n and on /t. We'll take the input in P code. We have already declared these variables at the top of our code. Now we will write another message saying that name of the product. For that we'll write name of the product. Now we'll take the input in p name. Now we'll display price of the product. We'll take the input in price. Now we'll ask to enter the discount. So we'll write discount on the product. Alright, so here we are asking the user to enter the product code of the product. Then the user will enter the product code, then the name of the product, then he will enter the name, then the price, and then the discount. So after that, now we will have to open a file, because as this add option is being used by the administrator, so we have to store these product details inside a particular file so that we can display to the user that we have these products in our supermarket. Alright, so for that we'll have to use the file handling operations. Data is the name of the object, as we can see, and with the help of data.open we can open the file, and the name of the file we can write here, database.txt. Alright, after that we want to open this file in reading mode. iOS in will open the file in reading mode and iOS out will open the file in writing mode. So now we will use if statement and we'll write if not data, that is if this file doesn't exist, then inside this function we'll write data.open database.txt. We will open this, basically we will open this file in writing mode if this file doesn't exist, and if this file exists then in else block we'll do that. iOS out, iOS app stands for append mode and iOS out stands for write mode. Now in order to write inside the file we'll give some space, and now we'll write p code. This is how we can write inside a file. After that p name, then again some space. After that there is price, then again some space. After that dis for discount, then we'll use /n. Alright, so after that we have to close the file as well. Write data.close, data.close. After that in else block, that is if the file exists then we will read from the file. So this is how we can read from file. N P D, these are the variables. Here we are initializing the file because after that we have to use the while loop to iterate through the file. So let's do that. First of all I'll write this part and then I'll explain. Inside this we'll use if statement, and if c equals to p code, then token will be incremented, and for initialization or for iteration, we'll again do that. So here what we are doing is, first of all, we are initializing the index of file. Here we are initializing the index because after that we will use the while loop. Inside this while loop, we have written not data.eof. This eof is the end of file function. This while loop will make sure to check every content of the file by iterating it. So one by one, each content of the file is checked. If the code matches with the P code, that is if there is a duplicacy, then the token variable which we can see initialized with 0 will be incremented. It will become 1 basically. After that, for the iteration purpose, we are reading from the file, and after that now we will close the file, data.close. Alright, now we'll use if statement, that if token is 1, as we know, if token gets incremented, that is if there is a duplicacy, then again it will go back to the menu. That is if the product code entered by the administrator already exists, then he have to enter another product code, because if the administrator enters the duplicate code, then it will again go back to this menu. So this go to M, we have to label it over here. Alright, now in the else block, that is if the token value is not incremented, that is the product code entered by the administrator is unique and not duplicate, then we can enter the product, that is its product code, its product name, its price. So for that we can just copy paste this part, it's the same, and we can paste it over here. So here we are writing inside the file. So this is how we can write inside the file, and here we are opening the file in append and writing mode. To write inside the file, we have to open the file in writing mode. So after that, we will display a message saying that record inserted. There's some bracket error. The else block will close over here. Alright, now this add function is done. We have done this part. Now we have to create another function named the edit function. As the add function is used for adding the products in the market based on their price, names, discounts, etc. Now edit function will edit the products. Like if you want to edit some product like juice instead of milk or something like that, you can do it with the help of edit function. So we'll do that functionality in edit function. So let's do that. We'll write void shopping edit, the name of the function. So inside this function we will create two objects of fstream class, that is data1 and data2, that is data and data1. Alright, so these two are the objects of fstream class. Now we will declare some variables. Now string n. Alright,
Now we'll write a message displaying modify the record. So we'll write /n Now we will ask to enter the product code. So we'll write Now we will open the file and check if that file exists or not. Now if that file doesn't exist, then we'll simply display a message saying that file doesn't exist. And in else block we will open the file, but not the same file, the other file. This file would be database1, and we will open this file with the help of this object, that is data1. So we'll write data1.open. The name of the file would be database1.txt, and we will open this file in append mode and writing mode. So here what we are doing is we will save our edited data in this file and we will rename it to the original name, that is database.txt. The name of this file is database1.txt. We will save the edited data in this file and then we will rename this file as database.txt. That is the original name of the file. So now we will write data p code, then p name, price, and then this. So we are initializing this file. Basically we want to iterate this file. So not data dot end of file. It will check each and every content of the file. Alright, now using if statement we will check if p key equals to p code. P key is the code that is entered by the administrator which he wants to edit. So if that matches, then inside the file we'll write /n/t/t, then product of new code, product new code. Here we are asking the administrator to enter the new code for the product. So C in C, he or she will enter the code. Then we will ask to enter the name. So write /n/n name of the product. P name and now the price. So we'll write Now the discount. Now all the updated details of the product will be entered with the help of data1 object. Again some space, then n, again some space, and here p, and here d. Alright, now we'll write a message saying that record edited. Record edited. Alright. After that we'll increment the token, that is token plus plus. Now this was the if block. Now in else block, again data1, that is if the product key or the product code entered by the administrator doesn't matches with any of the product code within the file, then the old variables, that is pcode, pname, price, and after that discount, that is this. Alright, after that, yeah, we'll do that /n. Now outside this else block we'll write that pcode pname, just for increment purpose. We want the while loop to iterate, so that is why we will use this one, so that this while loop can iterate. Alright, after this we will close both the objects, that is data.close, we are closing both the files, and data1 dot close. Now as I already discussed, that we have to rename that database1 back to the original name, that is database. So we will use two functions in C++, that is remove function and rename function. With the help of remove function we will remove the list, that is the database.txt file. We will remove that database.txt file, and then with the help of rename function we will rename database1.txt to database.txt. So let's do that. Remove, inside remove we will write the name of the file. It will basically remove all the list inside the file. Alright, now rename function. Inside the rename function, first of all we have to write the old name, that is database1.txt, then the new name, that is database.txt. So now using this function, this name will be changed to database.txt. Alright, now if token value is not incremented, or we can say is 0, then it will display a message saying that record not found.
And with that we are done with the edit function, and now we will create remove function. So we'll write void shopping rem remove. This remove function will be a bit similar to that of the edit function. So now let's start with that. Fstream will create two objects, data and data1. Now int p key and int token will initialize it with 0. Now we'll display /t delete product. Now we'll display to enter the product code. So we'll write similar to previous function. Now data.open database.txt. We are opening this file in reading mode, and then we will check if this file exists or not. So we'll write here we will write if not data, then inside we will display file doesn't exist. Alright. Now in else block, inside the else block we will open the data1 file, and the file name would be database1.txt, and we will open this file in append and writing mode. Alright, now after that base p code to initialize or iterate the while loop. We will write this. This is how we read from the file, and here we will use data because we will iterate through data.eof, that is data file. Now inside the while loop again we'll do the same as that we have previously done, data.eof end of file. Now use if p code equals to p key, then we'll simply display the message saying that product deleted successfully. Alright, and now we will increment the token. Now in the else block we will write data1 space then p code then p name, then price, then discount. Now p name, then price, then discount. Here the P key entered by the administrator will check for the first product code. If it matches, the if block executes. In the second iteration, it will not match and else block will execute, and database1 file will be displayed. In other words, in else block, all the products will be displayed except the one which you want to remove or delete. So we will show this file database1 and then rename it with the previous one, that is database. Alright, so now let's go ahead. We'll do the same in order to iterate this while loop. Now, as we done previously, data.close, as we have to close the files. Data1.close, and after that again the remove function to remove the database file, and rename function. Firstly we will write the database1, that is the old name. Make sure to put semicolons, then database, then database.txt, the new name. Alright, after that, if token is not incremented, that is if token is 0, then it will simply display a message saying that record cannot found. Or record not found. So as we have created 3 major functions, now we will create another function named list. It will help us in showing the list to the customer or the buyer. Right, shopping. Now we'll write list. Inside this function, we'll write the data, the object of the fstream class, then data.open will open the database file, .txt in the reading mode. Alright, after that we will format it a bit. So after that again we have to write the product number, name, price, etc. So we'll write product number, and then we can use /t, again name, then price, and then we'll use /n. Please put them inside the double quotes, and now again we'll copy this part. You can design it in your own way, and now we can do the reading part, data p code, then p name as we have done previously, price, dis, while loop. Inside the while loop again we'll use not data data.eof. Now inside this file we'll write the product code, product name and the price. We'll start with product code, then product name, that is p name, after that price, for the iteration purpose we'll write again p code, p name, price, discount. Alright, now after that we will close the file by writing data.close. Alright, so we are done with this function as well. After this, now we will create the receipt function in which all the customer operations will take place. So now let's create this receipt function. So we'll write void shopping, RECIPT receipt. And now inside this function, first of all we'll create the object of fstream class. Then we'll declare some arrays because we have to store multiple product keys and multiple quantities of those products. So that is why here we have to use arrays, and then we will declare some variables. So let's start. First of all, fstream class, the object of this class is data. Now after this we'll create array. Array C means array of codes, so I'll declare it in that way. Now after that, now we'll declare another array of Q, that is quantity. Now choice variable, then there would be a counter variable, let's say. Then discount variable, we'll initialize it with 0 and we'll initialize amount with 0 as well. Alright, now total variable, now we will display a message saying that receipt, so that the user will know that this is the receipt. Now after that we will open a file, that is data.open. We'll open the database.txt file and then we'll check if that file or database exists or not. So we have done this previously. Data.open database .txt. We'll open this file in reading mode. Now we'll use if block, and inside this if block we'll write not data. We are checking that if this file or database exists or not. So I'll write if it doesn't exist, if not data, that is if this file doesn't exist or this database doesn't exist, then we will print the message saying that empty database. Empty with a P. Now as this, now in else block we'll write if that file exists, then first of all we'll close the file that we already opened. Now in else block we will call this
list function that we have created, because if the file is created, then we have to call the list function and we'll show the user or the customer that these are the products available in the supermarket. And for that we are calling this list function. Now we will design the structure and ask the user to place the order. So let's do that. Please place the order. Now again we'll copy this part. Alright, so now we'll use do while loop. The purpose of using this do while loop is that we have to run a specific part of the code every time, and the other part of the code we have to run based on the choice. So now let's start with that. Inside the do block, first of all we will ask the user to enter the product code and enter the product quantity. So first of all we'll write product code enter product code we'll take the input in the array. Now we'll ask the user to enter the quantity. Alright, now we'll take the product quantity, that is C in ARRQ C. Now we will check that if the product code entered by the user matches with the product code that is being already entered, then we will display a message saying that duplicate product code, please try again. So for that we have to use the for loop first of all, and inside the for loop we'll initialize I with 0, I less than C, we have already initialized C with 0. Now I++. So inside this for loop use if condition and check if the product key or product code entered by the user matches with the product code that already exists in the file, then we will display a message saying that duplicate product code. So we'll write if array C of C that is entered by the user equals array of C I. So I will keep on iterating as we have used for loop. So inside this if we will display a message saying that duplicate product code, please try again. Alright, now we'll write go to M, again the jump statement as we have already discussed. Now after this we will increment C++, that is if the product key is not duplicate, then C will increment, that is the counter will increment. Alright, now we'll display a message saying that do you want to buy another product or not. we'll write alright. So as we have displayed this, now we will take the input of the user, see in choice, that whether he wants to buy the product or not. So this is our do loop. Now we'll have to use, after this do block, we'll have to use while loop, as we are using the do while loop. Now here is the condition that if the user will press yes, that is Y, then this loop will execute. Alright, now we'll make a design structure. So we'll write cout and /n/t/t/t, and now we'll write receipt. Alright, now after that now we'll write product number. Sorry, by mistake we write capital N. Now we'll write product number. Then now we'll write product quantity, product name, sorry. Now product quantity, then the price, now we'll use the for loop to iterate through the file. So we'll write for int I equals 0, I less than ci++. So now inside this for loop, first of all, because we have to do the iteration, we'll open the file data.open database double quotes database.txt, and we'll open this file in reading mode, so iOS in. Alright, so after that we will kind of initialize this file. We'll write pcode, pname, then price, after that there was discount. Alright, now as we have done previously, while not data dot eof, that is end of file, and inside this while loop we will check we are actually matching if the code entered by the user, that is ARRCI, is equal to the code present in the file, and if so, then we will do the calculations and add those files in the customer basket. So let's do that. pcode equals array of C of I. Here we are checking. If so, then we'll do the amount equals to price of the product into the quantity of the product. Alright, after that we'll have to do the discount part. So in this part we know that the discount is calculated by multiplying amount with discount divided by 100, and then we have to subtract it from the amount. So let's do that. Amount minus amount into discount divided by 100. Alright, Now after that, as we are done, now we'll have to add discount to the total variable, because in this part the total amount after getting discount is stored in this dis variable. Now we will add the dis variable to the total variable. Alright, so as this is done, now we will print this part. So in this part we are just printing, so we'll do the /n, and now then p code, then p name, then array of q of I, array of q I. Alright, now after that price, then amount, and amount after discount, or we'll write discount only because we have to write the variable. Alright, now we'll have to add the /t's in between them, so let's do that part. Alright, so we have added the /t's in between them for the formatting purpose. Now to iterate the file, for the iterating purpose, we'll do the same, that p code, p name, price, discount. Alright, now after this while loop, now we will have to close the data file. So we'll write data.close. So after this data.close, we have to print the total amount. So let's do that. First of all, we'll do some design part, like let's say /n. Now just for design purpose, now we'll simply print the total variable. We'll write first of all total amount. Now the variable total. Alright, so everything is done except the main function. Now in the main function we'll write, so int main. Now inside this main function, as we know, we have created the class shopping class, so we will create the object of that shopping class, and we will call the menu function with the help of that object. As we know, that is the first function that must be called. So we'll write shopping, and let's say the object of this is s, and s dot menu function. So as we know, the menu function is the topmost function. So this menu will display when we run the file. So now everything is done, and now let's run this file. Let's press compile and run. I hope it works. There are some errors. Alright, so 335, okay. So this is the error, and now 57 line. Line number 57. Yeah, we have to use double equal to. And one more error is there, I think. Now let's try to run this. There might be some more errors, as you can see. Alright, after this 386. Okay, so we haven't labeled this one. We have to label M. Now let's try to run this. So here we can see supermarket main menu. First is administrator, then second if you are a buyer, 3 to exit. So first we'll log in as an administrator. So as you can see, please log in. So now we'll enter the admin's email. So we'll write robbie@email.com. Now the password robbie@123. Now this is the administrator menu. As you can see, first is the add product if we want to add the product, second to modify the product, 3 to delete the product, and 4 to back to main menu. So now I'll click on, like, I want to add the product, so I'll write 1, I'll press 1 and enter, add new product. So now I have to add product code of the product. Like, let's say the code of product is 1, name of product, let's say juice, and price is 70, and discount on product is 2%, record inserted. Now again I want to add, so I'll click on 1, product code of product would be 2, now name of product would be, let's say, bread, price 30, discount again 2, record inserted. Now again product now would be, let's say, butter, 3, butter, price of product would be 60, discount would be 4. Now fourth product, sorry, add product, now product would be 4th, and this would be, let's say, eggs, price would be 170, discount 3%, record inserted. So now we will check that these records are inserted or not. So we can cross check it by going here and open this database file. So as we can see, 1 juice, product code 1 is juice, price is 70, 2 is the discount, then second is bread, third is butter, 4 is egg. So first this is the product code, this is the price, and this is the discount on that product. Now let's come back and modify the product. Let's say first product was juice and we want to modify that product. So what we'll do is we'll add the product code 1 and the new product code would be 1 only. Let's say we don't want to change that, and name of the product would be chips, we'll replace it with chips, price would be 20 and discount would be 2%. So record edited, as we can see here, record edited, and now we can check. So now we'll open this database file. So as you can see 1 chips, 2 bread, 3 butter, 4 eggs. So the first product, that was juice, is replaced by chips. So this function is done. Now let's try the delete function. We'll click on 3 for delete, and now we have to enter the product code of the product which we want to delete. So let's say we want to delete the 4th product, and we can see product deleted successfully. We can check that. As you can see, there are 3 products left. The 4th one got deleted. So now let's go back and let's check if the customer wants to buy the product, how can he or she buy. So let's first of all we'll click on 4 to go back to the menu. So now let's click on 2 as a buyer to buy some products. Now we'll click on 1 to buy the product. So as we can see, our products are chips, bread and butter. So product numbers are 1, 2, 3 and their price are 20, 30, 60 respectively. And now we'll enter the product code of the product which we want to buy. So I'll click on 1 and the quantity I say 2. Want to buy another product or not? They're asking if you want to buy another product. If yes, then press Y, and if no, then press N. So we'll click on Y because we want to buy another product. So now I'll click on 2, that is bread. Product quantity, I'll add product quantity as 4 breads, and now butter. So for that, first of all Y. For butter I will click on 3. Product code of butter is 3. Now quantity would be 2. Now I don't want to buy any other product, so I'll click on N. So as you can see, product numbers, product name, their quantity, price, amount, and amount with discount. And the total is there, that is 272. And if we wish to buy another product, so we can click on 1, else we can click on 2 to go back. So this is our receipt, our total amount is there. So this is our complete project on supermarket billing in C++. You can try it, although the code is a bit long, approx 400 to 450 lines of code, but it is worth trying. Alright guys, with that we have come to the end of this session. If you like this video, please give it a thumbs up. I hope it really helped you all. Thanks for watching, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.